out. Right, I'm officially on screen. I just exposed my downloads folder. That's not good. OPSEC. All right. OS structure. Oh my God, what is this? Let me copy that. We'll just paste that into this shared Word doc. Is everyone on this doc, by the way, of the one that Omar shared?
Um, where is that?
It's a, it's an ed thread.
Can you paste the
Oh,
link in the chat?
All right,
can you
chat.
paste it in Discord or something, maybe?
That was a 7702311, but I also put it in the Zoom chat.
Oh, okay.
Uh, Hello? Yeah, I think Jasmine has it. Yeah. Uh, I'll just be using this for now. All right, this is A, 4 points with succinct bullets. Wait, am I losing a part? Oh, no, this is it. B, two. It's on top of my OS. I'm just reformatting these. Okay. Is that it? Okay. Should we crack open the spin paper as well and start looking at this? All right. Friend says he recalls when there are two major strikes against spin, the way it handles endpoints of object interfaces, create, combine, resolve. He says this results in spin not being performant and also unsafe due to unprotected memory access between extensions on top of spin. Should we pass this into like Claude and make it come up with like a fake rubric? Because I did see like they do on the sample test, like have a rubric of things they wanted to see. It's like the plus one, plus one, plus one, plus one.
Yeah, might as well.
Yeah.
Just give me a second.
Just keep laying out the page then with the other questions. OS structures, L3 microkernel. Is that a five-part question? I'm gonna do Control Alt Shift V.
Remembering all the things shouldn't be that hard, right? Hopefully.
I'm gonna start pulling out the paper summaries that the students wrote as well so we can start referencing them. Wait, the heck? Change this to heading one. Change this to heading one. Change that to heading two. So we can show up in table of contents. This one.
Are we copying it over or something?
I'm copying it over just
We
to
can
lay it
just
out.
let's I was thinking we can feed it into like a PDF to doc and then Just copy the whole thing.
This is not too bad for now. I think there is some formatting issue.
Copying to a Google Doc or
This is a
Word.
SharePoint doc that was shared by Omar. In this ed thread, I've posted it in the chat as well as the Discord. Um, I think Jasmine has as well, but I'll post it again.
Thank you.
For the PDFs we have to read, is it worth actually reading through it or just throw it in an AI and just have it spit out a summary?
There are review questions at the end, or there's a review question text file. I kind of set that up, but these are probably the ones you want to just at least remember.
Okay.
They're not too bad. I usually just read the first half, and once they start doing benchmarks, I just stop there. Because I don't think they're quizzing us on the benchmark results, right? It's just the design stuff.
Okay.
Like testing strategy and the
Yeah.
decisions around like why they chose this hardware versus that hardware.
hmm Plus forecast.
But there's like 21, 20 questions. Some of them are multi-part. There's 15, 17 people here.
We can go through one at a time and argue them, or we could split them up. I think it makes sense to go through it linearly. Um, it's up to y'all.
Are you trying to be here all night? or or
Well, I'm in California, so I think I'm up till like midnight for me.
okay.
Um,
I'm also in Washington, so it's only like 9 on my side.
yeah, but I'm
Damn,
recording
bro.
this.
Asia Pacific, but we got everybody from America in here.
Yeah.
Yeah. It is midnight for the East Coast people, so I don't know why they release it in the middle of the night when the people who live in Georgia can't even take it. Uh,
Like, yeah,
Yeah,
okay, yeah.
I think we should do linearly. I also agree, by the way,
yeah.
on that.
I mean, let me get through these. Yeah. Okay, and then this would be exokernel spin L3. I don't know which paper was the L3 paper.
It was
Uh,
the Litka paper.
there's two Leica papers. Yeah, there's two Leica papers. Oh yeah, Leica on microkernel construction, and then Leica improve address space switching self-study.
Oh, I don't think the second one was part of the
Uh,
exam.
I mean, the address space switching one is probably about the segment registers and stuff. And then the other one's just general L3.
uh, wait. These are so there's three parts to this question, but each part has three explanations. All right, one, two, and three spin exokernel and microkernel. That's the only one question for this section. I hate this style of test, man. It's open for now, but then you have to just memorize this dense thing of text. Uh, right. Anyone heading to?
There's no curve on the exam, right?
I do not think there's a curve.
Oh man.
Did they decide a curve before or after?
Would there be like a negative curve if we do too well?
I don't think so.
Somebody's got to take a hit for the team then.
I'll make sure to score a -10.
I was gotta pay the memory tax and then start deallocating the grade. Boy, there's a lot more questions than I thought there would be.
Yeah.
There's some really dense prompts too. Like I'm surprised. Wait, oh, assume there's a starting state. I'm gonna take a screenshot. So this is the Zen IO ring.
Any chance I could get a link to that to the doc
It's in the
This doc
chat.
or the yeah, this
or the
is
the, the shared one, or is that a shared one?
yeah, this is the thread by Omar, the 7702311.
Oh,
He
okay,
has a
okay,
doc
cool.
in the body, so
Thank you, thank you.
Combine and resolve. Okay.
so how many points does this total up to besides the 20% that are hidden? Oh, 20 points. Okay, that's not bad. If we nail these and then memorize them, we can get at least 70%.
I don't care how the grading goes. So if everybody has the exact same answer for the first 80 points, then just allowed.
I mean, it'd be kind of tough for everybody to type the same thing during the
Yeah.
canvas.
It's just a matter of who has the photographic memory.
But then I also think if we memorize like the first 80%, chances are we know the last 20%.
Yeah. Oh, hi, Corey. Corey's my coworker, apparently. I don't know if you're in this chat.
Hi.
Hello. Okay. Full virtualization. Wait. Exokernel, pair virtualization. Wait, this is a 21 points. 8, 4,
Yeah, parallel
6,
systems.
3. Right. Parallel systems was a dense lecture. It took like
Yeah, it looks like parallel systems and virtualization are like the two biggest sections.
virtualization was not too bad paper-wise, but it was pretty bad. I thought lecture 2 was denser one than lecture
Dang.
3.
Yeah, these
Uh,
are these all seem like they're about papers. I didn't expect that.
Did you take a look at the previous year ones? Because I think they were all like that, so I was just like rushing to read them.
Oof, yeah.
Okay, we've reassembled this kind of mentally tormenting thing of questions into this Word doc.
How far have people gone studying?
I think there's some good resources online. I've been using this guy's notes for a while for a few of my other classes. This Andrew the Internet thing. He goes up. I think he's kind of given up midway into lecture 4. He kind of like said this is not captured, but the rest of the notes are pretty concise. And then this repo has some pretty good PDF notes. I think they just transcribe the lectures mostly. So if I can't watch, I just read these. Um,
Okay. Yeah, I kind of did something similar, but I used another guy from GitHub's notes. It was a bit, yeah, I used that guy's Mohammed's. That was pretty good. So what I like to do was I just printed out all the papers and I just did more annotation because I think he misses some of the sections. But overall, it's
yeah.
pretty good for just a high level overview.
hmm I think these are just the raw papers. Like, there's not any annotation here. Um, unless oh, nothing here either. Yeah. Okay, let's. Should we start doing the questions while everyone's copying, or should we just
I
finish
guess
copying?
some people can finish copying all the questions over, unless there's none more. Unless some people can start working on the question answers.
Yeah. I'd rather we do the question answer synchronous. But, parallel memory systems, memory management's there. Is that a table?
Yeah, it's a table.
There's a code block here. What the? Oh no.
Yeah, we're gonna just have to use snipping tool for that.
Yeah.
1 second.
How about we just refer to the PDF while we discuss the answers? I think that will save time.
Yeah.
So
It's gonna have a reference here, but oh, start from the top. We have 3 hour less than 3 hours for this call. Be a little more concise about it. Horizontal line. Wait, no, that's not a horizontal line section. That,
a
All right.
domain name
Are we
format.
restarting up?
you're starting. So one, there's two major strikes, which is the way it handles accessing endpoints of object interfaces, not being performant and also unsafe. The memory access between extensions on top of spin. Explain how spin creates protection domains and use this to explain to your friend whether it's correct or not with regards to one, performance of spin OS, and two, safety. Um, looks like oh, I'll pull up the spin approach here.
Just a side question. When are people planning to take the exam?
Where?
When?
I am taking it Monday.
Yeah, okay.
Yeah. I don't think anyone's taking it tomorrow because I know the TA said they're going to answer some questions on. So
When's the deadline for the exam?
Monday at on West Coast time, I think
I
9.
think it's
But
midnight Eastern is the deadline on Monday, right?
yeah,
Yeah.
Okay.
so spin prize.
Do we want to like do like a discussion kind of thing, or are we just gonna like type
Yeah,
the
we should. We
Yeah,
should.
let's do a discussion so people
Yeah.
can kind of just learn what the answers
All
are.
right.
Yeah. I'll
I think that's good.
yeah, I'll change over this to reviewing. I think anyone, so we should not, so we can see who's typing what. So if you're on this doc, change it over to reviewing. Same at the top here, change it over to
So how
reviewing.
about we do something like this so that like we'll just go through like, 5A, 5B, whatever,
Hmm.
and somebody can just say like, hey, I've got the answer. We can discuss that. We can do follow-up points.
Hmm.
Sounds good.
Yep.
All right. Um, let's see.
Creates protection domains.
For this one, I feel like we'll have to dig into the paper because
Yeah.
all I remember is that it uses a strongly typed language to create and enforce the protection domains. But then this is asking you explain how it does that, and I think that's a bit in depth.
There is one
Right.
more thing, which is that so Modula 3 allows for you to create an interface and export that interface.
Hmm.
And you can only use whatever functions or interfaces are exposed.
Yep. Uh,
So like that's for the safety bit.
here it is. Logical protection domains. Extensions exist within logical protection domains, which are kernel namespaces that contain code and export interfaces. Views on system. We should put quotes on the paper just so we know where to reference, like a page number. Uh, Contact
And
linker.
that sounds like the answer then. It's the exported interfaces.
So this is page two, top left of page two.
Yeah, and then the performance is because it co-locates the OS extensions in the kernel, so they all have the
Mhm.
same address space. And then safety is because of the exported interface and yeah.
Yeah.
Alrighty.
Co-location, module protection domains is safely and overhead, but they don't guarantee extensibility. Uh, we're looking at performance and safety, not extensibility. Uh, Spin price set interfaces. Yeah. Is this just the intro? Yeah, it's just the intro. Co-location, force modularity.
In addition to
I
co-location.
feel like wasn't there one more point for spin about performance other than the co-location of the address space?
There was something like
Yes, as I was
pre-compiling or
saying.
something, right? Sorry.
As I was saying, it's procedure call. Uh, like they're dynamically linked libraries, so the overhead is that of a procedure call. That's how it's performant, as opposed to trapping to the kernel.
Yeah, so there's less boundary crossing, right? It's all in that one application level. Or
Also, Thea, if you said something earlier, I didn't hear you. Sorry.
no.
It's
So
okay.
here it is. Here it is. Okay, page 5, protection domains. That may just be the intro. I'm gonna say page 5, the paper. And I did not read this part yet, so there's no highlights.
I'll be honest,
Protection,
I've done only very brief skims of the papers.
yeah, protection domain is implemented using virtual. Oh, wrong tool. Name from one domain has no relationship with the same name in a different domain. So I remember those physical names. I don't know if it was this paper or a different paper that had physical names.
Physical names?
Uh, that might have been exokernel that did like physical names.
What do you mean by like a physical name?
They pulled exokernel paper actually. Uh, yeah, exposed names. Exokernels use physical names to move the level in direction. They just give like the address, page number directly as a way, as like an abstraction on the page. Uh, are you putting answers? Yeah, Tau, or Thou, we have a SharePoint doc that was in an ed discussion.
Oh yeah, I saw the comment, but I didn't see the link to the doc.
Yeah.
Okay, let's sum things up. So what do we have? So we co-locate address spaces is a performance bonus, right? We have the dynamically linked procedure calls, right,
Yes.
as a performance bonus. And then for safety, we have the interface, like it exposes an interface through module 3, right? Are we missing anything? Are we good?
Is there something like capabilities granted in the spin architecture, or like only callers with the capability granted can call into that procedure?
Name protection is interface level of the language.
Is that a different thing?
I remember there were different like I know exokernel has like an authorization thing. I don't know if spin does.
I just
I
control
think
F
spin is
on
like
capabilities. It's in section 3.1.
Section, yeah, so this is 3.1 on page 5. I think we should focus on 3.1 as a whole protection model to
Mm.
on the second point. Uh, for the capabilities. This is some like really dense academic wording.
yes, man, it is. It's crazy.
Yeah, like the Zen paper was easy to read. Like it was just like a person describing to a 5-year-old. This is like there's walls of text.
Special purpose hardware, virtual memory
All right.
mechanisms.
Extension redefines faculty, creates instance any type.
Its capabilities directly using pointers, which are supported by
I'm just gonna start pasting in quotes and then we
the
can try to compose them together. Spin direction. Why are my quotes doing that?
then the compiler enforces capabilities and prevents forgery.
Yeah. Domain name just control dynamic linking. So this is the compiler section where the compiler object file is safe if it is unknown to the kernel but has been signed by the compiler, or the kernel can otherwise assert the object file to be safe. I think Soviet Nguyen for performance, we also create group protection domains to interact with each other to minimize this domain crossing. Yeah, I'll try to find the page number reference if you can, so that we can all be on know where the quotes are. I'm just gonna paste in the quotes at the top, then we do the question at the bottom.
PDF head page.
I think capabilities and basically just having pointer or something. This is module 3. I think so. Like the pointer of the name of a symbol is only restricted to that protection domain, right? The same name in a different domain would mean something else, much like how. Actually, I don't know.
If if you guys have your cursors in the spot where we need to type, but you're not going to type anything, can you move your cursors? Able to make changes there.
A symbol. So the resolve object. So there's domain sharing with this resolve operation where we can link two domains together and resolve the symbols in one domain with another. Cool namespaces. They're a union of existing domains. Domain interface is used to commonly export. And so this was the create, combine, resolve. If we would be looking at resolve, create, combine. So I think we should all be around page 5 for this question.
So just quick question. Are all the answers are we putting this down from the paper? Because I feel like some of the answers come from the lecture as well.
Yeah.
Because I was thinking of that some of the answers are part of the spin approach section of for that PDF file.
Okay.
I think
Yeah.
you should just put whatever answer you like, and then when we argue over it, we'll just make sure it has a good answer.
Yeah, I'll link over whatever lectures we have in. Shit, this is the wrong page. Get do like link the page number or the video you're looking at if you can. Um,
Also, we should separate out which part of the answer applies to which part of the question.
yeah, spin approach, logical protection domains. Great. Yeah.
Also, I think like we have a pretty good answer for 1A, but if we go at this speed, we are going to be here all night.
Yeah.
Yes.
Okay.
Okay, in that case, do we want some people to start working on the next questions?
Do you want to do breakout rooms or do you want to
What if we, because I feel like there's value to having like a group discussion. What if we just go through and do like initial attempts, like
Mhm.
faster attempts at these questions, and
Yeah.
then we can revisit later to add
Okay.
on if
So
needed.
everyone takes a first pass and then we will do suggesting and commenting to refine it or something like that.
Well, so we could do one of two things, right? We could go through the paper as a group in a fast way,
Hmm.
like linearly, or and then if needed, we can come back and add on, or we could just split questions up into a group and come back to
Yeah.
it.
Okay.
Okay.
Um,
Yeah.
I'm
Um,
thinking we do the first method where we just go as a group, but we quickly go through it and then just come back if we need to answer in more depth. That way everybody has a chance to hear and kind of understand what the answer is.
That's my preference as well.
Okay.
yeah. Okay. Um, should I put a timer up like 5 minutes per question or something?
Yeah,
I
we
think
should
that'd be
just
good,
yeah,
actually.
we need to like limit ourselves. So yeah, in any case, the first question has like three parts. So I think we pretty much answered everything. We just have to go and divide up what we've written so far into the three sections.
Yeah.
Yeah. So explain spin, creates protection domain. Uh,
So for part B. I remember like a couple of times he was saying like, oh, for specific parts you have to venture outside the safety of module 3, right? And I think that's basically just the answer for B.
mhm. Explain spin, performance, safety.
Type safety for most device drivers must be designated as trusted with specific safety trade-offs.
Does anybody remember what the other things he said about like the venture out of the safety of module 3 were?
I'm looking.
I think there was
Did not.
something about how there are some certain things at in the core services that couldn't be implemented with modular free three type
Yeah,
safety.
something like networking, right? It was uh, sorry.
Did he say like why? Because I feel like, like for this answer, just saying like, oh, device drivers can't be implemented in module, like not everything can be implemented in module 3, for e.g., device drivers, the example they give in the B. Like I feel like that's enough for points, but does anybody remember like why we can't actually implement everything in module 3?
There,
I
I
think it's
think there was
because
language
you need
constraints.
direct
Yeah.
hardware
Fine
access.
grain protection.
So I don't know if this is correct, but just throwing this into Gemini, it says certain device drivers require direct access to the hardware interrupts registers and specialized memory. So you can't get that safety with modular 3 if you have to write those.
Those are written in what then? Does it say or?
Um, Not sure. So this is what Gemini spits out for B, but it's not based on any of the papers.
Okay.
Whoops. Sorry.
Collocate minimal kernel extensions.
So
All right. Well, I feel like this is probably a good enough answer for now, and let's move on and we can
Yeah.
revisit if needed.
Pointers. Create customize those. And simple extension. Border crossings.
All right. So we moving on to question 2 then?
yeah, let's just keep
Yeah.
moving on.
All right, cool. So I'm gonna start reading. Let's see.
Oh, here's default core services and spin for that part B. Um,
I think the core services bit is just like which capabilities does spin have, not necessarily like what can be implemented
yeah.
via Modulo 3 and what can't. But I'm gonna start looking at question 2.
Mhm.
Wait, are we moving on to question two?
Yeah, I am.
Okay.
I assume in general
Okay.
we are.
Spin arbitrates precious resource. Services may need to step outside the language of force protection model to control hardware resources. Core services are trusted services since they provide access to hardware mechanisms. Anything that touch hardware mechanism is hard to abstract in a way. And I'm guessing that's what that would mean for question
Oh,
two.
nice, good find.
Um, wait, which part?
That was for
Safe.
1B.
One. The lost word B was right. B. Trade-off 4.3. Yeah, hardware level speed. So hardware mechanisms
Question
are
two
hard to abstract.
could
So
just
they
be a
are
simple
provided
CPU
through.
scheduling question.
Theo, your mic's really quiet. I'm not sure if it's just me.
Yeah,
Does this sound better?
a little better.
A little bit.
Okay. Is question two just a simple CPU scheduling question? Like,
Yeah,
what
that's
are
what I
the
was
different types of
thinking of.
scheduling?
That's what I was
I
thinking
wanted.
of.
Yeah.
Um,
Ti time slices. The end. Okay.
Whoa,
Is it
that's my timer.
spin that allocates like time slices to everything? Like I know that let me go back to my notes. I know that
It's like the strands and all that. CPU scheduling strand, event handler, global schedule. There's a global schedule that gives a coarse grain amount of
yes,
time,
yes.
right? And then
Yeah.
the fine grain amount of time is controlled, or there's like one of the priority queue. I think that was isokernel that did the like the threads to reap or something.
Yeah, so then I mean the answer is the global scheduler, right? Because strands are handled at an OS level, so each
Mhm.
OS can decide like each library OS can decide what they want to do with the strands, but the global scheduler itself is what decides like at an application slash OS level which one gets how much time.
Mm.
So I think we're good on that one. So L3 microkernel then.
Which part is this? Default core service and spin. I would link default core service and spin on part B, and we can come back to it at a later time. I don't want to. I think we're moving a little faster, but where is default core services? So lecture 11, I'll just go paste it here, and then we can come back after we review that video on our own.
I think a rough like thing is
Yeah.
fine. It doesn't need to be a perfect initial.
And then part B was performing
So the answer for this one is just basically it's just a global scheduler.
grained global scheduler provides uh, coarse grained for strands. It was up to the application threads package to those routing primitives to determine exactly how scheduling is affected. All the spin does is ensure the extension gets time on the CPU to the global scheduler. Spin is for allocating time. I'm gonna put that there as well.
All right. Uh,
I
okay. L3 microkernel part one.
I'm gonna put a timer again. 5 minutes. Debug micro issue.
So roughly
Like
the answer for this is just like
where
extensibility in general.
this custom pager used to 2x ability. Uh, General answer. Can refine that.
So I would say it's easier because of the extensibility benefits of a microkernel architecture. And then it's also safer because everything is in a separate address space, at least in an L3, in a regular microkernel. But in an L3 microkernel, it's still safer because they're in like separate logical protection domains that are enforced via the segment registers.
Hmm.
Any additions, folks? I'll ask that probably after. And also, if I'm giving too many answers, I guess feel free to chime in, folks.
I mean, it sounds right. It's only worth 2 points, so there should only be 2 points
Hmm.
really for this one.
Just adding it to me.
Okay, so then one is extensibility, and then two is logical protection domains.
Accessibility.
I know a
Right.
couple of the questions had like four, like at least in like the sample papers that like the from previous years, there were let's like it's a 2 point question. They'd have like 4 points, and then they'd be like if any two.
Hmm.
I'm curious, are any of these questions the same as the previous years? Because then you can just copy and paste the same answers that they're looking for.
You can
I
go
want to say
through
some were similar, but I haven't looked through the whole paper yet.
test one, fall 25, test one. Uh, it's ever so slightly different. Or very different sections. Exokernel, spin safety, spin perform. Oh, here it is. How spin perform it. Uh, Extensions are dynamically linked. Virtual memory management. So this we could reuse a bit for 1A, but
Yeah,
I
you
want to
just
keep moving.
yeah, just copy and paste that whole thing for the first
Fall
question.
2025. Say fall 2025. Review fall 2025 sample. There's a bunch of bullet points of part A because we spent like 30 minutes on it.
Yeah. Hey, I mean, we got a good answer for it.
Yeah. Do you have to give examples? Wait,
No, it's fine. Let's move on to
all right.
two.
So
Let's move on to two.
2, you implemented global scheduler.
Okay, this question they've had like a variation of this question in every single paper.
Frequency. Third. So it's like a math thing. System runs a shared kernel libk, which was 512 meg.
It's not exactly the same though. It's the 500, the four client protection domains. Each running as a user level process. Okay, so I'm just gonna go through answers. Okay, so for 2A, it's that the kernel library address space, like the kernel code is common. The kernel address space is common amongst all the address spaces. Like all of them use the same one. It doesn't change from process to process. So
It's shared kernel libk, which requires 512 meg. If that's like is that like a read-only memory space then, or is it shared?
I mean, it's read only for the
The code.
clients, but I mean, it's not purely read only.
Mm,
XIV plus shell kernel library, which each of the
Like all the applications use the kernel, that's why it's in all of them.
mhm.
Okay, so for
yeah, it should
B,
no, yeah, you're right. It should be the kernel is the same for all the running clients. You don't need four different versions of the kernel, you
Yeah,
just need one.
well, no, it's not like they're physically saving memory, right? It's
yeah,
just, it's like in every single address space. That doesn't necessarily mean that it's physically like, we're not talking about duplicating the kernel code. It's just
yeah.
it should be in every address space.
Hmm.
I guess since the processes are running in the user space, they need a way to talk to the kernel, and each process need the kernel library to know the APIs. That's why we are
Hmm.
copying them to all four.
Yeah, I'd agree.
Hmm.
All of them need the kernel, and yeah.
Yeah, the kernel is the same, but they need to know what the library is, what the APIs are. That's why they all basically like in C program we include hash include something.
Mm.
That's what I think it is.
So there's network access permission. So they like statically linked in kind of compile time instead of like doing a dynamic call. Would this be more of like a performance thing, or is it a
It's a trap, right?
What's a trap?
the kernel
Is it for 2B?
crossing?
Is it a user function
Oh,
if
are we
you're
on 2B
calling the
now?
system call
Okay,
that
okay, okay.
traps and goes into the kernel library?
I mean, it does trap. I feel like, do we need? I agree that it traps. I'm not sure if we need to put some more info or something there. Like, I'm not entirely sure what that more info is, but
Right. I understand. Like, I'm sure there's like another level of detail you need other than just saying it traps and goes into the kernel code.
yeah, I'd agree with that. Yeah.
Let this be handled in your
Uh,
time.
I kind of small number of
This
abstractions.
is sorry,
Yeah,
this one is quite similar in the previous test. So basically,
the fall 2025
when
one.
yeah, there's one version of this in every paper, as one of the other person mentioned. Yeah.
Oh, yeah. Question three right here. 32 it.
Usually we have to do something about like changing the pointer, check if the cache is tagged or not with the address space ID. If it has a address space, we don't flush the cache. Like all of those small points.
Uh,
Yeah, so so if it was me for something like this question, I would say if the current, so the first point would be if the current address space is the same as client A, then we don't need to change the page table pointer. And if it's not, then we have to change the page table pointer. And then we don't have to flush the cache because the TLB has the address space IDs.
But that would
via
be if
which
we're
question
switching
now?
from one process one to some process two, right? But in this case, we're switching from process one to the kernel space.
Cross the border crossing. So we want to minimize cross a border crossing by having the li library for each client. If we separate them, then each time we lose some locality there. Sorry, I'm a bit lost on this doc.
If you have any thoughts, Thea?
Hmm. I don't. This is a complicated. I I think whoever was talking about trapping and checking the tagged cache
Is there a need
was
for
on a
tagged
good
cache?
track.
So okay, so our process and our kernel library are in the same address space for all of these, right? So there's no address space switch. So it's just the border crossing costs of, pushing whatever onto the kernel stack.
Yeah,
It's a
it's a protection
right.
domain. pressure
Yeah.
bubble
Right,
thing.
but it depends on what the call is, right? The call could be a trap to the kernel to manage memory.
Why does that, what does that change?
The behavior of the kernel into B depends on what the call is, like what the kernel then does. How would this be handled?
I think we're generally just, I'd like the question is generally just, I think, asking about like how would a border crossing be handled in your design, right? It's like just basically how the question is. I don't think it matters as much what the actual system call made to the kernel is. It all that matters, I think, is like you're in user space, you go to kernel's, you border cross to the kernel, and then you go back. But I'm not sure if there needs to be more anything said. But I'm not sure what that more is.
So part A is related to the TLB and how we want to keep that from flushing when we cross into the kernel. Is that just our general summary for this?
For A,
For A,
there is no TLB flush
okay.
for A. Like a TLB flush doesn't even come into the picture because that would be for switching from one client to another client, but that we're
Mhm.
switching from client to kernel is what we're talking about. All right, let's just I feel like we spent a while on B. We have a passable-ish answer. Maybe
Yeah.
we'll come back. We'll revisit. Let's move to
Okay.
C.
With a C.
Yeah, for B, just put trap for now. We'll just come back to it.
Yeah, that's reasonable, I think.
Friend is curious how your design gives the memory isolation guarantees for the clients.
So this is a L3 microkernel. Okay, so we have
Memory isolation.
okay, so you can see above that the tag TLB supports address space IDs. So that is the answer for this, right? So because actually let me think about this a bit more.
Right. Nice.
Okay, it's the segment registers actually. I misspoke. But
I guess it's both of them. I think TLB also uh, is like one point to maintaining the isolation, and the base and limit which restrict how much we are allowed to access for each address space.
that's what I was thinking initially, but so what the TLB's address space ID does is that all it does is it helps you not like it makes it so that you don't need to flush the TLB on a context switch because the entries have address space IDs associated with them.
Mhm.
But it doesn't actually
Yeah, I think
I'm
it's
not
still like if I'm trying to access the, like say the address 10 for a different process, and at the next context switch without flushing I'm still trying to address 10, how do I ensure isolation? Then I can say that because I have the ASIDs in the TLB.
okay, you're right. Good point. Okay, so the ASID TLBs and then
And
the
then
segment registers.
yeah, base and limit.
Good catch.
Thought it was mutually exclusive. Like you don't need to have tag. You either use tag TLB or you use segment registers. I don't think the lectures had any example where you had to use both.
I think in the question we are given what we are doing, so
So I think like it says that you have I agree that you don't use both at the same time. These are like two separate
Yeah, two ways to achieve
yeah,
the
yeah,
same
yeah.
thing.
Yeah,
Yeah.
yeah, yeah. Like it just says that your hardware has the capability. I think both either of these answers would qualify for the 2 points. Uh, ta- 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 ta. Design guarantees that the kernel library is protected from the client.
can we say that the base we are setting after the kernel libraries because they are all at the first, like at the top of the address space? That's why we never go into the kernel and change it. Like go into the kernel library part of the address space.
Dude, I feel like this is a harder exam than the last one. I feel the last year's.
Ani, did you take this course before?
No, I didn't, but they have like the
Yeah, the
previous year's
reference
papers
ones.
up.
Yeah. Spring and fall 25.
I guess the questions are easier when you know the answer. Maybe
Yeah.
that's the thing.
Well, I feel
Or
like they have like this style of question in both of the 25 papers, but those were like just very easy, like do we
yeah,
need to flush TLB or whatever.
either that or
These
like just calculating like how
yeah,
much you need for something.
yeah. These ones are like, damn, I gotta like really
The
I gotta
process.
dive in.
New TAs this year.
Damn, they're making me learn the material, man. God damn it.
It's probably TAs who just took the class and they're like, we suffered, so you need to suffer more.
I'm not actually sure about D&E.
Kernel lib is protected from client.
Design guarantees that the clients are protected.
That means ensure nobody else reads or modifies it.
Yeah, I think
Eh,
one possible answer that I feel is that the base will always be set to 512 in our design so that whenever the client, let's say, tries to access the index, like the address 0 or 100, since it's the kernel library, the and it's lower than the base, we never go get the authorization to change it. So maybe the base and limit is set accordingly. Yeah, I think that
So you're saying it's true for both or just for D?
just for
I can
the
agree that the kernel library is protected from the client. Okay, that makes sense, right? That makes sense to me.
Yeah.
Let's say like so ba like basically what you're saying, if I'm understanding right, is that we set the base at 512, right? So and
yeah,
then a size of like 2.5 gigs, right?
yes.
And then but so what happens after like let's say we're in the user space for client A, and then we trapped the kernel. So we have a separate segment register, but or like
Mm. Yeah, then I'm not sure.
because I'm not sure if you can have multiple segment registers for
L3 microkernel uses a kernel stack per thread.
null stack per thread.
Mm,
For Just a question. So for all the past exams, were they all answerable just from the lecture and the papers, or some of the
Yeah.
stuff you have to know outside?
I would say I haven't gone like fully through the past exams, but I would say like I went through like half of it, and I want to say it was everything through like lecture and paper. I would say actually like basically everything sh it should be like doable through a lecture. It's only actually.
Okay. Okay. I mean, we somewhat have an answer for D and E. You want to continue? Because I think we're spending a lot of time on the last two.
I'm not sure if we do have an answer for them.
Um,
Do you so you're saying that what's the answer for E then?
Well, microkernel libraries are invoked by the client,
I guess
or the
uh,
client
I think it
controls what
should be
happens.
false for E
answer
because the kernel library works in the privileged mode, so it can access the client and
Hmm.
like modify it, corrupt it.
But its directives are client calls. Like the client's the one calling what the
No,
kernel
once
should
the
do.
library is running, maybe it accesses outside of its limit, then it can technically uh, go into the client part of the address space.
I mean, I agree that the kernel is being called from the client, but that does still mean that like the client is not like protected from the kernel in the sense like the kernel can do whatever it wants.
Yeah, that's what I feel like. It's the kernel part of the address space runs with the privileged mode, so it can like corrupt the client.
Yeah, that seems reasonable to me. Does anyone disagree? And if you do disagree, please speak up because I'm not 100% sure on this.
it's a better answer than I have right now.
Yeah.
All right, cool. Let's roll with that for now then. I'll be right back.
On microkernel construction.
Oh my God. Oh.
I'm back. Did I miss anything?
No, we're just gasping at the difficulty of these questions.
Yeah, this
It's
question,
crazy.
design it in all three systems, go.
We're moving on
Uh,
to the exokernel one, or are we still stuck on D and E?
I think we're moving on to exokernel, but
Okay, fine. That's fine.
I was gonna say true and false for D&E for
Yeah,
now.
still
yeah,
design.
yeah.
Why can't this be a true or false question?
Why can't everything be a true or false?
No credit without justification, they say. Makes me want to cry.
I
What
feel
if
sorry
you
for the TAs, man. They come up with these questions and then they have to manually grade 1,000 students justifications.
what if you just said it depends?
That's a good
Kishore would
answer.
love that answer.
You
It's
see,
an NP complete problem.
That's a good answer.
I think the other course, the teacher is like, it's always correct, but it's not sufficient.
I'm
All
gonna
right,
work.
let's move on to exokernel. 3A or 3.1.
Packet multiplexer.
3.1A.
I think some people on virtualization. I'm gonna jump over virtualization if you guys want to keep working
Oh,
on
are we
that.
skipping exokernel?
No, I'm not too familiar of lecture two, so I'm just gonna
Explain how you
like
implement this
work in a little head and we can
packet. Oh
reconvene.
gosh.
I'll keep looking at exokernel stuff. I think I'm just gonna look at how it would be designed in exokernel first.
Okay, I'll catch up on the virtualization thing. It wouldn't take me too long to do Yeah, so I want to. I mean, okay, I haven't looked at the question, but if it's quick, it's quick. If it's not, then I'll just move on.
Oh my gosh. All these different kernel approaches. I need a TLDR. It's so hard remembering the differences between all of them.
Yeah, it's not easy. So for exokernel, I remember specifically they talked about like you can download code directly into the kernel, right? So that's the answer for exokernel. Um,
Yeah.
Sure.
Now for spin, oh, actually, spin is the one where you register like event handlers, correct? I
Yeah, and
believe.
then there's like that like overlapping two processes that share some event handlers or something.
Yeah, like
Yeah.
you can share like it can be one to one, many to one,
Hmm.
or one to many.
Yeah.
So for spin, it's just event handlers. Okay, cool. I didn't actually expect to remember that. Microkernel. I'm actually not sure about this one.
Micro. There was a section that he was talking about for microkernel for fast, um, for improvements on the border crossing. Um, I mean, just for micro, it's just, yeah, you have the address space TLB, so if you don't have to flush anything, if I guess if there's like multiple processes running.
But I don't understand like the connection between that and the packet filter.
No, yeah, I'm trying to see. I mean, the whole point is you need to explain why it's fast on this kernel.
I think it's just like how would you implement it in general? Right? Oh yeah, you want this to be fast. Yeah, that makes sense. But yeah. Um, does anybody have a good idea?
For micro,
Yeah.
I'm trying to look through the notes. I don't know. I guess there's some literature on if you just keep the protection domain small, then you don't have to do the context switching is really small then.
Uh, for exokernel, we can kind of reuse the answer from the Spring Test one.
Yeah. That is roughly the answer. I mean, I because it's like one part of a 3 point answer. I think just saying download code into the kernel is enough for exokernel, like for that part. I guess let's time box this to like another 2, 3 minutes maybe. 2, 3 minutes.
I guess for microkernel, what I feel is we are supposed to build user level processes, and microkernel says that the border crossings are not that uh, like taxing or has a bad impact on performance. So we could just build a user level packet multiplexer, I guess, and that would be performant because L3 microkernel says that by construction it is performant. Maybe not overthink it. For exokernel, we just download into the kernel, and the first one, I guess, was event handler. So I
Yeah,
guess
I
use
think
that.
that's actually a reasonable answer.
Yeah.
But wouldn't that unnecessarily send packets to clients that don't need them?
Yeah, I think you're saying about broadcasting.
And so every client of the exokernel does packet filtering as opposed to packet filtering at the near the device I/O layer.
Are you talking about exokernel one?
Microkernel.
Micro. I think we cannot modify the kernel anyway in a microkernel, right?
No, you
So
cannot.
I think the only option that microkernel, like what I recall from the lectures, is that in a microkernel you get like very basic abstractions and you build on top of that. And I guess
Okay.
that's what they are looking for.
It makes sense to me that like okay, so I I'm not I'm not sure if the answer fully makes sense to me, but I agree that you cannot modify the microkernel, and so everything that has to be done at the layer above that. That makes sense, and I agree. And then I remember the by construction border crossings are not as taxing
Yeah.
in L3.
Yeah, I think L3 says that we need to exploit the underlying hardware and make it non-portable. So
Yeah.
maybe make a non-portable, very specific to the hardware packet multiplexer, and that would be the answer then. But I'm not sure about the question someone asked about like every client. I don't know what the question was. I couldn't process it.
Wait, are we currently discussing 1A or 1B?
1A, but we're probably going to wrap up 1A now, and we can revisit it later.
Okay. Yeah, I just put what I thought the answer was for microkernel, but yeah, if people think it's wrong, we can change it after.
Yeah, yeah, yeah. I mean, if we have time left over, which I don't assume we will, we can go back and
It's okay. It's 10, almost 10 in PST. Okay.
I'm in Central, my man.
Oh yeah.
Yeah.
It's okay. I slept. I took a really long nap at like 7 p.m.
It's okay. If you're taking it on Monday, you still have 48 hours.
I am. I took the day off work on Monday actually for this because I did not feel like prepared at all.
I think it sounds like you have a reasonable handle on the concepts at a high level.
Maybe. I I had to review a lot of the like uh section 2 stuff like yesterday. That's because I felt like I actually went back to it like 2 days ago and I was like, damn, I have forgotten most of this. So I kind of rewatched like most of the lectures for it actually, like on 2x speed like yesterday or like day before. All right, let's move on to I've lost my tab. Okay, after you've implemented the code for the multiplex, you realize that you introduced two undesirable bugs.
Yes, for spin, what I can think is Modular 3 would handle it. I guess it has
You are
language
correct.
type
You are
safety.
correct.
So
Modulo 3 prevents out of bounds accesses.
I'm not sure about the other two though. Maybe user space does not have. For microkernel, if the code is running in user space, it's in a protection domain, so it is also protected.
Wait, just so for clarity, for microkernel, is he talking about specifically for an L3 microkernel or just a general microkernel?
I believe it is an L3 microkernel. Because the section at the top, like the section
Yeah,
header,
okay, yeah, I saw L3 at the top, but the question just specified micro, so I didn't know if it was referring to just
I'm
general
gonna
or.
assume it's an L3
Yeah, yeah, okay, it
microkernel.
makes sense if it's an L3 one.
I think for exokernel, that's packet filter is downloaded into the kernel. So I don't know what they mean by dealing with this bug. That could lead to memory corruption.
Out of diagnostic routes and out of
Unless it's
memory access that could.
unless
Sorry, could you? I was thinking. Could you say what you just said again? I'm sorry.
if the packet filters downloaded code into the exokernel
Mm-hmm.
and it gets an out-of-bound memory access.
Mm-hmm.
If the exokernel level application doesn't protect that, doesn't that mean that it could corrupt addresses that are also within the kernel space?
I would agree.
Or is it that in the same way that like user applications have address spaces, if an exokernel level application goes out of bounds, it's just that process is killed. But it depends, like, is the memory out of bounds handled at the exokernel layer? If it is, it might just kill the network packet filter. I don't really know.
Maybe for part A on exokernel, the answer they expected was to do with the secure bindings and the keys. And then for part B, we would answer that the keys is how it enforces that you don't access anything you're not authorized to.
Yeah, that's what Gemini says the answer is. It says exokernels prevent out of bounds memory by using secure bindings and capabilities, ensuring that while the library OS manages its own memory, they can only access physical pages allocated and validated by the kernel.
Sweet.
So then we should probably change part A also.
Yeah. So, I mean, it does. It does do a download. Is
Oh, okay, now I'm thinking, I remember part of the lecture, one of the example was a packet filter.
it was, and that's why they specifically keep saying about the packet filter.
Oh,
Um,
okay.
I mean, the Does the code, okay, so Spring
It's
25 test one, somebody had mentioned about it. But so one of the previous tests had a question specifically about packet filters, and how they work in an exokernel. Um, both of the answers that are in that list, basically, so like what you do is you establish a secure binding. Um, and then after you establish that secure binding, you download code into the exokernel, and the exokernel runs that code when that interrupt happens. Um, that code itself does not run at a kernel permissions level, though. Yeah, like that would make sense to me.
I think from the notes on GitHub, it says the spin extensions are created at compile time and follow rules enforced by the programming language. So I think this answers how spin handles out of bounds. And it reads, on the other hand, in exokernel, we are downloading arbitrary code into the kernel itself, which means it is dangerous. So like there's no prevention of out of bounds. It can actually corrupt. So I think
the
the writer has to ensure there is no such errors.
the paper also says that uh, code inspection is used, so at compile
Yeah.
time, checking memory bounds, and then sandboxing is also used to execute untrusted code, which would also prevent memory corruption
So
for
you're saying
accessing out of bounds.
the exokernel
Sandboxing is what?
verifies like the downloaded code?
So compilation would verify addresses at compile time, like if they're within the bounds of the running code. And then sandboxing basically isolates memory for that application that's running. So if the application were to try to access something out of bounds, it would not be permitted or corrupt something outside of that address space.
Okay, this is in the L3 paper?
This is in the exokernel paper,
Oh,
which
sorry,
I
yeah,
was talking
sorry,
about
sorry,
the
I misspoke.
exokernel.
Yeah, yeah, I meant to
It's
say
at
exo.
page 11.
Okay, let me
Okay.
And what did we decide for the microkernel?
think we have nothing that's really good as an answer
For for part B,
for the microkernel, right?
um,
I think like since the process should be running as a user level code, it does not have the privilege for out of bounds and it will like trap into the kernel because anyway it does not have the access to go out of bounds, so it should trap into the kernel, I guess.
I think that's reasonable. I'm gonna move on to part C. I think for spin on part C, there's a scheduling implementation that They're not going to allow some process to hog all of the time slices.
Yeah, I think the global scheduler, which gives like time slices to all the operating systems.
That's outbound.
Yeah.
Out of bounds memory access. I mean, for part B, since all the services are in their own protection domain, if you have an out of bounds call, it would just only crash uh its own service, but it shouldn't affect any other service, right?
Yeah.
Yeah.
Okay. I mean, that's the only answer I have so far.
Reasonable. Uh,
When they say dealt with, like for B, right? Like when they say dealt with, they just mean like what happens. And if out of bounds happens, like, because like, microkernel, for the L3 microkernel answer, right? The service crashes is not like dealing with it in the sense like we're fixing the problem. It's just like,
what happens? What
Yeah,
bug
yeah.
is
it,
incurred?
yeah, it's just like what consequences happen in the specific kernel, not specifically how does the OS like mitigate the issue. Or I guess it's mitigate, but it's just does the OS attempt to fix the problem before it can happen?
Okay. I'm good with that.
Yeah, I don't really have a good answer. Other than that.
I guess it's about how the kernel is protecting itself from the OS programmers.
Hmm. Makes
That's what
sense.
that's what it means. Like how does they deal with bad OS writers like us?
Okay. For exokernel, basically what happens is time slices are allocated at startup. Um, and we send a notification shortly before the time slice is up. And if it exceeds, uh, like if it refuses to like clean up in a reasonable time, it's preempted.
Yep. Sounds
All
good to
right.
me.
Microkernel.
That's the most confusing one, to be honest.
I agree.
Like, is part C supposed to, all the answers are supposed to be related to scheduling?
Yeah.
Okay.
I would assume scheduling or otherwise terminating a process that's not behaving correctly. But spin doesn't enforce correct behavior, so it's not going to do anything.
Yeah, I mean, for all of the kernels, there's nothing you can do if it gets in an infinite loop. It's just the only thing you can mitigate is just if the CPU just enforces fairness.
Does anyone have like does anybody know how scheduling works on a microkernel? Like, well,
I don't even know if the lectures went into scheduling on the
that's what I was
microkernel.
trying to remember.
I mean, yeah, I mean, the only thing I can think of is since all the services are in protection domains, if you get stuck in a loop in one service, it doesn't affect anyone else.
Similar to
Right, but you would
spin.
ideally want to also be like cutting off the service in some way, right? But I don't know, like,
I guess, but the kernel, like the scheduler doesn't know if you're doing any productive work. It just knows that you need CPU time to run in a loop.
right, right. So
Um,
like what would happen, like what happens for the others, right, is that you send a notification and then it respects the notification and it voluntarily gives up the CPU, or it doesn't and you just take it away from it uh sometime later. But I just don't remember reading anything about like this
yeah,
about
I don't
microkernel.
remember. I mean, I'm just thinking it back to the like balloon memory is that if you're stuck in a loop, you're not doing any productive work with the memory. So eventually the scheduler will take away memory resources from you. But that's kind of just applicable to all kernels, not specifically micro.
Yeah, for microkernel, AI suggests time slice expiration or preemption.
I think this makes sense as a general approach,
Yeah,
right? It
as
would
a
make sense for it to do the same thing the others are doing and send a notification after the time, like after some time, and pull it, like pull the CPU back eventually.
yeah, that's kind of a general answer for all kernels. I don't think it's specific to just microkernels.
Yeah, I mean, spin
Let's
and
write it
exokernel
down.
were very similar answers, so I'm just gonna. It seems very reasonable to say that for microkernel as well. I mean, it would be insane if it didn't have a mechanism like that. So
I'm okay with this answer.
I'm just
Okay,
gonna say
fair.
roughly same as others, and then be everybody can extrapolate whatever they want to extrapolate. If somebody else wants to fill that in with something they want, feel free. Uh, all right, let's move on
Okay,
to
yeah, let's move on.
virtualization. Full versus para virtualization.
Okay, I think somebody already went and answered a bunch of stuff.
Yeah, this
Yeah,
seems like there's
someone.
a lot of background activity on these. And there's some debate on the pair visualization IO ring one.
So virtually, the work performs much better than virtual. Guess OSs are responsible for.
We'll say everyone has review lecture two for the previous section.
Yes.
Wait, I'm
Then is
confused.
full or para virtualization again? It's been a while since I looked at virtualization stuff.
Para is your
Is aware of the fact that
No,
it's
no, no,
virtualized.
no. But Zen is full or para is what I'm
Zen
saying.
is para, VMware is full.
Okay.
Okay, so for this question, you have to use the papers to answer this one.
I put some quotes in there. I don't remember the whole shadow page table lecture for part A. I do recall like there was like multiple trap and blade, but once it is installed onto like the TLB,
Yeah,
then
I
there's no
mean,
solution. But
the whole idea for the shadow page table is if you have multiple OSs, since they
Mhm.
all need to eventually run on the hypervisor needs to schedule time for all the OSs, it makes sense to just cache all of their page tables and just store a
Mhm.
copy in each OS so they can just load it instead of having to go and retrieve it from memory again.
Yeah, but the first time it's established, it is a heavier operation since it has to create that shadow page table
Yeah.
like entry. Whereas Zen, you give them direct access to the hardware page table, which is what the paper quote is, as well as patching. Um, I need to find an exact quote or lecture for that hypervisor side.
Okay. I mean, A seems reasonable. Whoever filled it out. Is that one of us that filled it out,
I
or
filled that out.
okay?
It's working in the background. Part B looks like they're not confident. You want to double check this one.
Yeah. I mean, I think we're good to go through the whole
I
thing.
think we're good. Let's just
Yeah.
keep going because we're only like halfway through the test right now.
Mhm.
I'm gonna go through it real quick. I'm gonna do a quick read through. You guys can move ahead. Feel free.
I think this answer is reasonable, except I don't know about virtualized OS will have more performant CPU interrupts.
Uh, which part of the question are you referring to?
Uh,
Uh,
part
1B
B,
she's talking about, I think.
International
1B.
process.
the last bullet point in red.
It's whether
Uh,
like trap and emulate or a hypercall would be substituted in that place, right? Or yeah, if there's significant IO boundary crossing or something that needs to execute on a privileged domain, then you would see better performance of a hypercall. Or you know, one significant. I would say it's dependent on the profile of the workload. Small memory footprint, interactive process.
All right, let's move on to the para virtualization for now.
So does anyone know if for the 80% that's covered here, is the other 20% on all of the other material that's not covered, or it can still be over material that's covered in the 80%?
You can see the hidden ones in the previous exams, the potpourri.
Hmm.
Um, looks like they are the same material. It looks a lot
Yeah.
more looks a lot more lecture focused than paper focused on the 20%.
Yeah, I think it could be anything in that remaining 20%.
Yeah.
Oh man.
I was also thinking about this. It would have been nice.
Yeah, process of elimination. If we know the first 80%, we can reason out what the
Exactly,
last
exactly. But
20%
you know,
is.
you get we gotta be ready for anything.
Well, all of these requests are from the same application,
Yeah.
so they could be batched within an appropriate slice of time.
Or if the OS knows multiple IOs are coming from different applications, right? Uh,
Right, in this case, though, it's one application
mhm.
making calls in parallel, but each thread is a context switch.
Each thread context. It was optimized for receiving, not optimized for sending.
Hmm.
Like, uh,
I think the part B should be about device virtualization because it's I/O. So in
question one, part B on full versus para.
yeah, it's your workload consisting of a small number of interactive processes. So here I think it's in fully virtualized.
Memory I will be slightly different from device IO, right? It's mostly on page access or hey, memory footprint interactive versus device IO. Uh, uh,
Wait, are we on 1A or 1B?
are we on full versus para or on para?
I thought we're at para, right?
I'm looking at para, but I'm reviewing I'm reviewing some stuff. I'm rewatching part of the lecture video to
I, do you want to say to maybe this is different? Just say don't in flag the IO request to not be reordered by Zen this way. This way going. Freaking wake up notifications. 3.3 point. So this quote domains may explicitly pass down reorder barriers to prevent reordering when this is unnecessary to maintain high-level semantics, is a quote from the paper. So if they put a reorder barrier on all of these outgoing requests for the user application, they would come back in
I,
one block, right? That's my intuition.
well, I think you can just tell Zen what the batch size is, and you can just get one context switch. All of them return at the same time.
I'm a bit confused now. Is batch at the VM level or is that the
Yeah,
application
I
level?
confused myself. It's at the VM level. So like each VM gets the IO rings.
I'm leaning towards the reorder barrier for all of the requests for the same map on the OS. But what do we think? Chat. Batching is more for fair access across VMs.
I don't think you need to do reordering. I just think you need a batching.
Yeah.
Yeah. Well, I see the comment says, or in the paper it says guest OSs may batch update requests to amortize the overhead of entering the hypervisor.
That's for memory page allocation, right? Or is that for
That's in like you're talking about which section?
yeah, this is for IO ring, which I believe is for device IO.
Uh, device.
Because that would be 2.1, right, where it says you could batch for
That yeah, it's 2.1.1 on memory management.
yeah, I think 3.3.6. 3.3.6 had some hints on the reorder batch part before.
Wait, is the second part of the question asking um, after you've optimized the number of context switches, then how many context switches will happen?
One. One in and then one back. So I guess two.
Okay, that's just assuming it batches everything in one go and gets all the data back in one.
I think 10 requests in parallel is reasonable to batch on. Yeah, that's the assumption.
Other
Where
I
where
mean,
have we arrived at as far as an answer goes for this, roughly?
don't reorder and then send and return as one big batch. That's my
We're saying don't reorder?
well, send it as an or all in one large batch instead of having it be sent and then come back with reordering in place where some other process may be substituted in between multiple returning messages.
Right, because we're only optimizing for this one user application from this one OS.
Yeah. So put a reorder barrier for this one application to prevent other things from being substituted in between.
But a reorder barrier will never
No,
make
application level
something
stuff will
more
be
efficient, right?
application stuff is opaque to the Zen, right? It just sees all requests coming from a VM. Uh, and some of those may be different applications on the same VM.
But I'm not understanding. Like a reorder barrier will never make something faster or more efficient. No?
It depends if you wanted to prioritize one application's responses ahead of others. In the
But I
case
thought
where there are multiple
reorder barriers were
applicants.
passed down at an application level, right? Like the way a reorder barrier works, from my understanding, is like some application will be like process my requests in the order I gave, like that they come
Mhm.
in, or like the order that I gave you them in.
Yeah.
But that would never make it faster. That would just make like at best case scenario, that would make it as fast as Zen.
No, it can make it faster because then you're prioritizing faster responses to come back first.
Yeah, it can make it faster, but then when you consume it, right, there's gonna be context switches if they're being
Yeah.
delivered to different applications on the same domain or the same VM.
I mean, nothing about the prompt says that they need to be processed in order, so I don't know why a reorder barrier would
Yeah.
be necessary.
I agree. I don't think it's necessary.
Hmm.
But if you can instruct the batch size on Zen, to minimize context switches, you would say do all of these in one batch. Because we've already written, at this point, we've already written to the IO input ring.
Mm-hmm.
So we're just optimizing for the return context switch.
Yes.
Okay, so batching the return is a
Yeah, I agree. It's batching the returns. So that would be two context switches uh, for after we optimize performance.
Yes, that would be my answer.
Okay.
Is anybody here in Eastern right now?
who's burning the midnight or 3M oil.
Oh, I'm in Austin.
You're in Austin?
Mm-hmm.
Okay. I'm in Dallas.
Woo.
Washington, I have another hour before it's Saturday.
Lucky
Do
man.
weekends even matter at this point?
Yes, man. All my weekends are just AOS, AOS.
I don't think I have a life outside of work other than school.
I think last weekend was monopolized by the freaking project and the auto grader being
Yeah, and
super
next weekend's
finicky.
gonna be even worse, right? Because we got the project on Monday, but we can't do the project this, or at least I'm not, because I have the exam this weekend. So I'm studying for the exam
Yes.
this weekend.
Yeah.
It's so annoying. I don't know why they schedule the project release a week before the exam. Like nobody's gonna be doing the project when we're cramming.
Yeah, and between the project due date and the next test, we got like 2 weeks between those, right? 9th versus the 20th.
Yeah, but I mean, it would only work out if you've taken the class before and you've already
Yeah.
done all of the projects.
You have
Allegedly,
until
at least
March
what
to.
I've heard is Project 2 and 3 are not too much work. I've
Yeah.
heard Project 4 is like ungodly, like like it's gonna take up your whole life for the whole month, but 2 and 3 I've heard are not bad.
Are y'all getting a partner for the rest of the projects or doing it solo?
I was originally thinking of doing it solo, but
Let me
I
solo
don't
it.
know. I got a partner.
Okay, just if anybody else needs a partner, I'm still looking for one.
I think there's a couple of posts up that you could probably throw something onto.
C is 1. C is 2.
Okay, so we're already through virtualization. We're just going to
Parallel systems.
memory management.
Memory manage.
Yeah.
Memory
As a
manage.
quick question, what were it's two context switches, but what are the two context switches? Are
Trapping to the kernel to perform the device IO, and then trapping back to the OS to receive the
okay.
responses.
Okay. Cool. I'm not as locked in as I was like an hour and a half ago now that it's 1 a.m.
I took an 11 p.m. coffee.
Oh, yeah. I think starting off lecture 2 threw us off. We should have started off with the most recent lecture and work the way back.
Wait, are we gonna schedule a part two for this
You
tomorrow?
guys can join the Eastern one, the one at 7 Pacific.
Dude, I am not gonna be up for the Eastern one if I'm up for this one.
Honestly, I should schedule a part two if we don't get through everything
Yeah,
tonight.
Electric Boogaloo.
Are we at memory management now?
I think so,
Are
yeah.
we okay with the full virtualization answers?
The full virtualization ones.
We haven't gone through those, but I mean, if people think it looks right, then I'm fine to just keep going.
As
Let's
the
give it
night
like
goes
5 minutes. Let's go do a quick rough skim through of the full vert and the other, and then we move to the next one, or
okay.
okay,
So
cool.
malicious tenant gains root access and attempts to access memory from another VM on the same host. So
They don't
I
have
agree with
access.
the
Yeah, no access to machine page numbers, right? Or
in fully virtualized. No, they would
yeah,
in para virtualized. They
yeah,
would
but
go
this is
demo
only for
page
full
table.
virtualization, right? The question
This
prompt
is
is, yeah,
correct.
in full.
I would agree.
Ooh, ooh.
Yeah, is an abstraction. Uh, Customer runs special application using MySQL instruction. That was this. If you guys did geos, I think they had like a whole section on that, right? The 20 different instructions ahead.
Yeah. Yes. So like
Yeah,
the trap and emulate that could fail.
yeah. We have to probably mention trap and emulate for the
Points.
must mention are known to fail in virtual edition.
I appreciate you actually typing these out, by the way.
True or false? Oh, thank you.
Specialized application visualized feature.
Peanut.
I'm gonna do a quick verification on that.
Memory
I
management
can
3
remember.
points. Parallel system. Let's list out the invariants for this one. So when A is 1, B is 0, 1. B1 and C is 1, A is 1, but B is 0. B must be 0. And C is 2, A is 1, and B is 1.
Are we on memory management now?
I think we're just verifying the other ones, and then
Okay.
we
I
just,
think the answers for full verb look pretty good.
yeah. C is 2.
Oh, by the way, just because we haven't had like a group of people, how long did Project One take you guys? I had to spend like a pretty good chunk of time on it
The whole
actually.
time. The
I
whole
spent
time.
I spent 1 week on it because I was busy the 2 weeks since it launched, and
I
like
spent all of the time. I think the problem was just tuning it.
yeah
Yes.
What kind of algorithm? Like, I feel like the memory part was straightforward. The CPU's
yeah,
scheduling, I don't
memory
know
idea
what bumpy it was.
percentage bound, right? If it's above like 80%, then start allocating. CPU, I think someone mentioned in Ed, there's like a greedy approach. Pick the highest
Impacting.
impact on the highest loaded PCPU, and then move it to the lowest PCPU. But I found that I think if you do that, like there's some things that take like 2 turns to actually equalize, like on the test case 5. I did another swapping approach where I swapped the lowest one on the lowest PCPU with the highest one on the highest PCPU, and that was able to pass test 5.
Okay. I had a very, very rudimentary approach where I limited it to only one swap per iteration, and I would just take like the lowest usage vCPU on the highest used pCPU and just move it to the lowest used pCPU.
Uh, yeah, I was thinking of like picking the 2 extremes that would contribute to the standard deviation and then moving it or something like that.
Yeah. I mean, I'm sure there were way better approaches than mine. Mine was just
Mhm.
good enough for the graphs, and I'm like, that's good enough for me.
Yeah, I
Yeah,
also use the
honestly, yeah,
similar
it's just
approach.
once I had the graphs I wanted, I was like, all right, don't need to modify anymore. I don't care if it doesn't fix all the edge cases.
Yeah, I also use the greedy approach, picking from the highest, but
Yeah.
instead of picking the highest VM from the highest eCPU, I picked like the ideal one, which would minimize the difference. But
So you
again,
tested every single standard deviation to pick the right
yeah,
one.
yeah. No, basically I choose the vCPU which is closer to the mean,
Mm.
like the difference between the
I
utilizations of high and low and divided
Mm.
by 2.
That makes sense. That makes sense. I was thinking about making that change, but I was like, man, I'm done with the project already. It's okay.
Yeah, I think that gave me really good results. There was no oscillations, and it was
Nice,
quite
nice,
similar
nice,
to the samples provided.
nice, nice. All right, we want to move on to memory management.
Yeah.
I
Yeah,
think we're there actually.
let's move on.
Actually,
How many
those.
more questions are there? There's one,
Wait,
two.
there's question two about the asynchronous I/O rings on pair virtualization. I don't think we touched that, or do we just double check that? As I just said, fetch an increment. I think there's Coulter on that doc who's doing a comment thread about kind of
What are you
the
what are you looking at? I'm sorry.
so like pair virtualization question two. There's the one of the picture of the I/O ring, and then the thinking, do you
Yeah.
need a mutex?
No,
Um,
you don't need a mutex. All right. Like they're.
'Cause it
I'd have to go back to the lectures, but I think this is a straightforward answer.
yeah.
That's covered in the lectures, and it's not difficult, so let's just move on.
Okay.
I think the IO ring was a single producer, single consumer, right?
There's multiple producers from different
There are
VMs, right?
multiple producers, I think.
But the response is a single producer from Zen, right? Share an update by Zen, share update by Guess. Yeah. A request producer, response producer.
Okay,
Yeah,
let's just
that.
well,
keep moving
Yeah,
on.
let's
We
keep
still have
moving.
like four
I think
questions.
let's keep moving on. I
Yeah,
think let's
yeah.
keep moving
Let's
on.
go to parallel systems.
Well, did we do the memory management? There's a three-pointer, quick three-pointer.
Memory management. I
Which
put
one?
two down. Someone else had a red one there.
What is the red text, by the way?
The red
Just
is someone else. I'm using suggesting, and like someone else is doing the red text to mark their
okay.
own. I don't know who's who.
This uses content-based sharing. Or best friends.
I agree with number 2.
Looks good enough.
Yeah. This looks good. Shared memory machines.
All right, cool. Let's move on.
Right, parallel
Parallel
system.
systems.
That one is one.
Man, why we got these tables in here?
Okay, I just like list out the conditions, and then we just eliminate the ones where those aren't true.
Wait, what the heck is Lampert's sequential consistency model? I don't
I
remember
thought that
that.
was in like one of the lectures that were in like section 5, like
Section
week 5.
4 is like one of the very initial ones where you want to have a policy or something in place for programmers to know what to expect or something like that.
Sequential consistency
Yeah,
means in a thread, the orders will be like top to bottom, basically.
yeah.
Yeah,
That's
but somebody
There's
said something about
interleaving.
lamp or something,
there's
Yeah,
right?
something about interleaving being allowed, but something about within each thread the consistency. A memory consistency model. This was the lecture.
yeah.
Yeah, so you can interleave, but every thread has to be up
Yeah,
top to bottom. You can't
program
have like,
order.
yeah, it
Yeah,
has
program
to be in
order
program order.
over interleaving.
But I don't know where the Lampert part comes from.
Lamport is, I think, the name of the person who said that we need sequential consistency.
Yeah, I'm just gonna ignore the word lamp ports because I understand the question without lamp ports.
Yeah.
You're just plagiarizing his ideas as our own.
I mean, okay, this one should be pretty easy. It's just
Yeah.
pick which ones
Yeah, this
shouldn't
is just a
be
logic.
Yeah,
possible.
I honestly like. How about this? Anything that's super straightforward, we'll just skip because
Mhm.
it's late.
Okay.
Yeah.
Are we good with
Okay.
that?
Yeah,
Yeah.
okay, let's
All
just
right.
All
skip it
right,
for now.
cool.
Mutual
This is
There's
straightforward.
still
We
exclusion.
just
answer.
skip. Mutual exclusion locks.
Oh my
Good.
God.
For
We
wait,
love
for part
technology.
Like War and Peace
wait,
on
for
every
part I
question
did somebody
prompt.
paste correctly?
We're based on every question. You're right, man. 32 cash.
Impossible because that's
Invalidation
okay.
based cache concurrence.
Okay, we're
Time.
going to mutual exclusion blocks now.
Yes.
Okay.
Spin on test and
Is
set.
this the last section?
We have
No.
Okay, we
one.
got one more tornado and LRPC and whatever the fuck. Okay.
Lock
Now you still have
barriers,
locks and
LRPC,
barriers and
tornado.
then LRPC and tornado. So there's three more after this one.
Dude, tornado. Okay, like I feel like I really just I'm so iffy on tornadoes.
You just don't get Numa, man. It's all about that
What, by
Numa.
the way, I had to like did I just like miss the lecture where they introduced Numa? Like I had to like go read about it myself. Did I just like miss a lecture on it somewhere?
I've, was it in the 2200
Well,
like
they
reviews?
briefly talk about it. It's
Yeah.
basically just network is everywhere.
Yeah. It's just like it's basically like a
Or
local
the memory
cache.
is
Yeah.
everywhere.
Your local memory versus a remote memory.
Yeah, no. Like I know what Numa is now, but did they really like properly explain it in the lectures? Like I'm like I guess I must have
It,
missed them.
Passing.
they
It
might have
It's
appeared
also
assumed
not
that,
about the
yeah.
it
cache,
appeared to
right?
be
It's
an
about
injury.
like local memory is closer. Like the memory that is closest to your socket is faster to access. Like not
Yeah.
all memory is the same cost to access is what Numa is.
Yeah.
Yeah, I mean, Numa basically is just all the CPUs have their own local cache and we'll just access that.
But it's not about cache, right? It's about memory.
Yeah, it's
Like
memory.
Okay,
there's
yeah, they have their own memory and it's faster to just access their own, but they can,
Mhm.
it just takes longer if they need to fetch the memory from someone
Yeah.
else.
yeah. All
About
right. Mutual exclusion
32
blocks.
core
question
cache coherent plus
spin and test
validation.
globally
Local
atomic.
architecture supports atomic tests.
Spin the cache copy. Oh, cache creators call. Ticket log. Fetch and add. Next. Okay, okay, they just restated the algorithms. Create spin on test and set.
So for A, is it 63 times 100? No.
Create.
Okay, so 32 times.
Each
No, that's way more than that.
logarithm requires 100 iterations of the spin loop for each thread.
1023 times 100.
I feel like everyone's going to have to go to the spin loop, right? It's not like just to check it, since they have to fetch the new value from main memory or something. Thread- wait. Where do you get the thread number from? Um,
The
Thread, it says there's
prompt.
32
core
threads.
cache coherent bus-based multiprocessor.
wait, no, not 32 per cores. Who's saying 32 per cores?
No, there are
There's
32
32
threads.
total. Yeah, 32
Yeah,
total.
32
One per
total
core.
threads, one thread per core, and then there are 32 cores. So just one thread for every core
Oh,
right now.
Yeah, I feel like
okay.
that
There's
that
not
math.
32 cores.
1,023 threads.
So,
How many?
33 threads.
It's okay. It's
You guys
okay,
have
bro.
to
It's
check
late.
yours.
It's late. It's late.
31 threads.
Listen, I understand. We're in Central. We're in Central. It's not our fault.
It's
Yeah,
that
yeah.
Texas
Okay.
weather, man.
Math's mathing now.
It was chilly actually in the morning, man. It was like
It
In
like
was.
California, we got like whipped back and forth between hail, rain, and then a sudden cold snap.
I don't know what like the mornings are cold and then the afternoons like are nice and
Spin on read. One thread is in the critical section covered by a lot other spinning. How many tests set? So because it's write and validate, it's like walk through like because write and validate, then everyone's cache gets invalidated, and then they all have to go to main memory. Uh, wait, oh man, who's reformatting? This is why I do the control enter on each new section so that they don't do the movement. All right, let's see what we got here. Are there any like Hangout sessions that are like really useful? Like you got a lot of information out of because I don't want to rewatch all of them.
I was thinking about it. I feel like it's just very dependent. I'm not sure if there's that much separate value from the Hangouts. Like I feel like the material that's covered in the Hangouts is generally covered in the lectures. But like while you're doing the Hangout, I feel like it's nice to like have like I'm recovering the material that was in the lecture and like remember it better.
Hmm.
I guess the
But I
quiz
don't
questions are different.
the quiz questions. Yeah, there are a couple additional quiz questions.
Yeah.
This thing's gonna get a little laggy on my.
I feel like there's a lot better use of your time like at this point than going through the Hangouts now though.
Yeah, just go to the papers probably, especially the section 2 papers.
Many test and set operations.
Uh, one squared. Yeah, that was on. Gosh, go here.
But why are we saying n power 2 minus 1 axis for spin on read?
This is for the. That's not the ticket lock, is it? This is the
Spin on read
spin
is
and
that?
read. Spin on read. Need a
So
spin on. Okay. Wait a minute. Cache value of lock. So there's a cache value, and then there's a write and validate. Then everyone's just going to main memory, right?
Yeah, so wouldn't it be like
What if
n minus
ends?
1?
It's just
Yeah, I think
unlock.
it should be n minus 1.
Yeah.
And the first one should have like n square, I guess.
No, test and set and spin. Yeah, test and wait, write and validate n square plus transactions. Everyone sends one
Yeah, that should be the
update.
first part.
Yes, everyone sends one update, but then receives n updates back from the other, or n minus one updates back from the other chattering threads, right? There's something up it.
it's just asking how many test and set operations happen, not how many bus accesses
Yeah.
for this question.
So it would be n minus 1 test and sets, correct?
Yeah, they're being tricky.
Yeah, but when someone else does a test and set, then that invalidates your cache copy as well, right? So then you have to go test and set again, or something like that. Uh,
No, I
No,
because
well,
think
it
because they're
I
doing
think
it
the only one
locally.
who has the lock will invalidate, right? When it releases. So all the other
Yes.
31 will go and do the test and set, and that's it.
creation every
And
waiting
only
thread,
one will win.
Yeah.
it's like a Thunderdome. Cellular disco.
Bro, where are you going?
By the way, how did they come up with the name Cellular Disco?
Freaking MIT people, man.
Yeah. B should be n minus 1, right?
Yeah.
I'm thinking n minus 1.
I
And
think it should be n minus 1 because, yeah,
cat.
the one thread that has it doesn't need to call it anymore. And out of the n minus 1, only one of them will get the lock, and then the others will all fail and then just go back to the while loop and wait.
I agree.
So I think it should be n minus 1.
Yeah, we're looking at test and set. It's not cache invalidations, right? Or something like
It
that.
says for the
So
spin
caches
on
don't even
read,
come into play in test and set, right? Because
It
it's
come
just
in
directly to memory.
on spin and read, right? Because you're
spin and
reading
read does the cache. So it just stays in the while loop and then reads the cached copy of the lock. And then
until
once
the
it
protocol notifies.
Yeah,
But
until that one thread that exits the critical section unlocks it, then all of the th
mhm,
remaining threads will attempt to acquire the lock again.
mhm. But every time someone tries to acquire, they do a test and set, and that
Yeah,
test and
every
set.
time, yeah, only one thread will succeed. All the other ones will fail.
Okay, so
Mhm.
we're in agreement that it's n minus one
Yeah,
test
it should
insets.
be n minus one.
N minus one. I remember this order n squared thing. I don't remember which one it was for though.
Are you sure
Unlock.
that's not for notifications?
That's yeah. Sorry for
Bus
I
notifications,
know there
not
is
for
an n
Yeah.
squared for notifications
yeah.
because every time somebody uh, changes a value, it has to
Hmm.
invalidate everybody else's.
Yeah. I'll just mark that n squared minus one is for cache notifications, not test and set operations.
Wait, the n squared is because is that assuming that every thread gets to acquire the lock ones?
Now everyone tries to do a test and set once, and then they
Uh-huh.
hear other people do a test and set n minus one times, and then each for each one they reach. I'm not.
Yeah, so like unlock invalidates the cache of every other
Mhm.
thread, and
Yep.
then someone acquires the lock, and that
Oh, yeah,
invalidates
okay,
Yeah.
the
you're
cache.
right. Yeah, test and set
Yeah.
it
Te
always writes,
yeah.
so it will
Yeah.
force a invalidate on everybody else.
Mhm.
Doesn't matter if you acquire the lock or not.
Mm-hmm.
Yeah.
Ticket lock. How many cache reload operations happen during unlock release?
What does cache reload mean? Like it fetches the
That's
cache
a
again?
well, this is a cache
Like
invalidation,
after you
so
invalidate the cache, you bring back the cache, like you update
you
the cache value is like what
yeah.
they're saying here.
Governed by the lock, what is they're spinning, waiting their turn. How many cache reload operations?
I have to review goddamn
On
ticket lock
it's
Yeah.
a
here.
targeted thing, right? Ticket lock that just increments to the next waiting.
Only, yeah, I thought it was
Only one, right?
only one, right? Because it's just the next one in the queue gets to
Right.
get the
With
lock. Everybody
ticket
else will
gets
still be
later.
stuck with doesn't
I
have the
think
lock.
in
Yeah.
that's the queue. I think in ticket, everyone is waiting on the next
Oh yeah, yeah, yeah.
kernel.
I'm
Yeah.
sorry. Yeah, you're right.
So yeah,
Okay.
the
So
now
all of them
serving.
are cached. So it
Yeah,
should be 31 again.
yeah, so everyone's waiting on the now serving, but some people are pausing on the loop. So there's a procrastination in there.
Yeah, but still the
Yeah.
cache is invalidated. So after the pause, they will refetch.
Hmm. Yeah.
I think it should be
Yeah,
31 again.
yeah,
Yeah.
updating now serving results in cache coherence traffic.
It
Yeah.
still has contention. Yeah. Three,
31 again.
one.
All right. These questions are easy compared to the other questions.
Freaking lecture two is the hardest out of all these from what I can see. Like uh MCS lock. They called this by something else. I remember it was like
Was it? I thought it
Well,
was always called MCS
this
lock.
is MCS lock. The other one you're thinking of is Anderson lock, which is
Anderson.
similar but
Dude
different.
named it after himself.
MCS is
I
all
think a
shared
lot of
by
people do that.
himself.
Fucking shit.
This is the array base versus linked list base, right? I think one of them was the
Yeah,
linked
Anderson is
list.
array based, MCS is the linked list.
Yeah, whoever's typing win, he's got it. So
Is
it's a
lock.
race condition on checking for nil because someone could also be updating
Yeah, that was a
the root pointer.
two stage update route and then set next or something, right? Uh,
Yeah.
you have a bus space non-coherent. These adjectives or modifiers are becoming longer with each section. Bus space, custom, non-cache coherent, shared memory, DSP.
What the fuck? Wait, what? The digital signal private cat. Okay.
Okay.
Batch,
Cool.
flush, hold, on hold.
For take a log algorithm, we tried it but
Oh
it didn't
God.
work. Today's only value. So you have to let, so this is like if this there was no cache coherence mechanism, you had to do it in software or something like that. This is what question two is.
Yeah, you send
Yeah,
a signal.
non-cache coherent you have to do. Oh,
Yeah, I think this answer in red is good.
yeah. Next ticket only updates local cache. So you have so it's basically you turn it into a critical section. You have to like fetch it, hold it, modify it, flush it, or something like that.
Or
Basically,
you
after
can't
we
use
increment
it.
now serving, we have to flush the cache into the main memory because now serving only updates the cache.
But you have to pull before you flush, right? So you have to lock and pull it, then flush it.
Well, you can do the atomic
Mhm.
operation,
There's
but
no
it's just like
atomic in a non-cache coherent, is there? Wait.
a,
Non-cache coherent means that the hardware won't do the cache updates for you. So if somebody writes to the cache, it won't automatically update everyone else. You have to do everything in software.
yeah, but atomic instructions are still a thing. That doesn't have
Yeah.
anything to do with
Atomic is
cache
still a thing
coherence.
because it's just on
Mhm.
the same CPU.
But is atomic only on the local copy, or is it also to main memory?
I believe it's to memory.
Let's
Yeah,
see.
it
Let's
should
look
be
at
main
the one
memory. It's
through
just it
four.
won't update anybody else's cache.
So you have to do a pull before you do an atomic, or do a fetch before an atomic, and then a flush.
Yeah. Okay, so this is just basically which calls would you make to implement cache coherence? I think this one is straightforward.
I want potential unflawed unlock. There's only local cache. Since they
Well,
would.
since you're holding the lock, you don't have to fetch again,
Mm,
but you do have to flush.
a lock function. Yeah.
Just for wait, for part A or
For the
part
for
B?
part B
Part
is
B.
Oh. Yeah, makes sense. You need to flush the value back.
yeah.
Okay, that seems pretty easy.
Oh.
Yeah, I think it's right. Yeah, you should once you update once you increment, you need to flush so everybody else is aware.
Yeah, then part C is basically what you're doing in part B of this question. Do you think is straightforward?
Let me check it real fast. Okay, so you need to hold.
I think the hold is just like a mutex, right? Just
Flash max ticket increment equals ticket L plus 2, then you need to flush.
card ticket, hold, fetch, ink, flush on hold. That looks right. While
Yeah.
wait, three fetch.
Yeah, three's fetch.
Wait,
So
the
you
hold
don't
is
Yeah.
you don't need to hold when you do a fetch, or
Well,
wait,
uh wait.
do you not need to hold when you do fetch? Unlock, yeah, unlock flush. So you don't need to hold when you do a fetch.
Well,
It's
what
either
does hold
zero
do?
lock or unlock, right?
there's an unhold, so you have to have a hold somewhere before that.
Uh, oh, on number three when you're waiting, so on the wait logic.
While L1 serving is not equal to my ticket.
This is like a sleep, right? You have to sleep until you can jump back or something. Wait.
I think it should be fetch because yeah, if somebody else is if you're waiting for the lock, you need to fetch the new value.
Mm-hmm.
Um yeah, you need to fetch the new value since whoever releases the lock doesn't automatically notify everybody else.
Yeah. But also you don't need a hold to do a fetch. Then you can just read, and if it's still one, you don't have to like lock it and confirm.
Yeah, I would
Let
agree.
me think. Okay.
Right, reading doesn't require you to have the lock. Writing
Yeah,
does.
okay, you're right.
Okay, so hold, flush, fetch, flush is good, I think.
Okay.
Yeah, should be good.
Great.
I thought we were at the end, but there's just this blank page here.
Oh my God, man, there's still three whole ass questions left. Oh my
Mhm.
God.
All right, we got
Maybe
30
make it
minutes.
easier.
I think
Consider new.
Consider NCC NUMA machine each.
I implement MCS barrier on such a machine.
Fuck.
The barrier synchronization is a foreign topic for me.
MCS barrier on such a machine. 6
So
point.
MCS barrier is the
MCS.
4 array up call and then the
It's the
binary tree
yeah
wake
the
up.
yeah the tree link phase. Conveyor sensor tree barrier. Yeah, for a
Wait, what does MCS stand for?
MC
It's three guys, I don't know, two guys, their
I think
names.
Muller color, something like that.
Oh, I was like, I don't know
And
why it's
Scott.
called MCS if it's a tree.
you just wanted to make it hard to remember. Spin location is statically determined. Each node in NUMA is a CCSMP.
I mean,
Cache
Cache coherent.
coherent simultaneous multiprocessor. So each node is basically like a normal machine, but then across machines, like it becomes a NUMA thing.
No, but the
Wait, uh,
MCS.
barrier. Um,
Like, like you would just have one be the root, and then you have three children, right? Then you just wait for the three children to arrive, and then
yeah, each machine would be like that at the base level, but then at the next level, I don't know how many levels there are.
MCS. like like we just want all of the cores to just wait at the barrier, and then once they all arrive, they just continue, right?
Yeah, so if we're
yes.
looking at this, there's 16 cores.
Wait, oh, is it 16 cores or is it
Did
just
they
one?
enumerate it, or is it that we just like
Where does it
pretend?
Just
say
looking at the
16
picture.
cores?
Oh,
It's just
Oh,
looking
just
at
like
the
literally
picture.
counting.
I don't know
Yeah,
because it doesn't
there's four
specify if it's
circles
16
each
cores.
square. Are we supposed to just regurgitate what the algorithm is?
I'm also not sure what they want from us here. Does it make a difference it being CCSMP?
Well, it the primary thing you would optimize for is local versus memory that is far away from your node.
That
But
makes
Yeah,
because
sense.
there's a parent-child relationship, I think what you would want to do is have processors that are local to each other.
wait on the
Be
same memory batch or something.
Yeah, so like
Yeah.
don't have children from a different core be your child. Like you want to minimize that tree and
Okay.
the 4 array. So like if we look at one of these squares with 4 circles in it, one of them is going to be the parent of 3 children.
Yeah. And this, so there's the data structure is all hosted on one cache coherent SMP for that
Right.
parent-child group. And that data structure has the is it the have children not ready. I'm
Yeah.
not ready to
Okay,
have children.
so what you're saying, right, is that like for each individual processor, right, we want the one to have 3 children, right? And then
Yeah.
the level above it is like 3 processors.
Yeah. Yeah.
Level
So
above it.
like
Yeah.
the leaves of the 4 array are local to each processor with 4 cores. And then there's another node level on this tree right above it,
Maybe we should draw a
or
picture for
maybe
this
two.
one.
Yeah,
It's kind of
we
hard
need
to
boxes with
just,
words,
yeah.
Out of four nodes
whiteboards.
each. Do you guys have
I mean, it's roughly
Excalibur?
similar to what that picture on the screen is. It's just there's instead of like each one of those nodes on the second, like the middle level, also has 3 leaf nodes, like children nodes,
Yeah,
right?
Yeah, like P2, P3, and P4 will have three more children.
Yeah, and then P1, P2, P3, P4. So like for example, let's take P1 on this, right? So P1 is one core on a CPU, and then its children are the other cores that are on that CPU. And then P1, P2, P3, P4 are like the representatives from each
Yeah.
processor.
So they will all have
Yes.
access to like a shared memory P0 thing that's a cache coherent across multiple processors or multiple CCSMPs.
Say that again.
So all these parents have to wait on P0, right? This P0 would be shared across all of them and synchronized. Uh,
Wait, P0 can just be
I've
one of the processors, right?
P
Yeah.
is
It's true.
Yeah, that's why I said we should draw this out because it's hard to
one
tell
of
who's what
these
how we're pointing out.
parents is
somebody pull up MS Paint.
Wait, let me pull up PowerPoint, see if I can make
oh
something real
man.
fast.
When I used to do research, we did all of our paper diagrams in PowerPoint and just export as PNG. But Excalibur is nice.
Excalibur
Okay, yeah,
is
just
nice.
whatever you can use to draw fast.
So yeah, everyone
The only
has it.
time I ever used it was for interviews, but
I am a person at Amazon that uses this all the time. Let's see, P1, P2. We're not allowed to draw on the test, so we have to like somehow turn this into
Yeah,
a
like once you
long.
draw it out, then it's easier to just regurgitate into words.
And so these have a group. I'm gonna send it back. I'm gonna change the color of this actually to change it to transparent. These are all CC Numa machine.
These are
Right.
CCSMPs.
These are CCSMPs, and then I'm gonna put a local data structure block here. Put a that has next, and then the is it not ready?
What about?
Wait. So these are all a local one. They all spin on these, right? Locally. But then one of these, I'm going to change the color to purple. Or what's like colorblind safe? Uh,
Black.
Black.
everything's black. It's just a big black box, and we're all just
I put a picture.
oh
I don't know if this is the most efficient way.
oh. uh, I'm thinking about what the memory is for this, right? Are they just looking at the P0 as next?
well, ideal if we did it that way, right? Then it we're not really parallelizing the work very well, right?
Well,
Because like it would be sequential rather, like it would be pro like
I see.
6. That's for the wake up, right? Not for the
This
sleep.
is the up call. This is the arrival at the barrier. The wake up is a binary tree.
Yeah. What's up call?
Not up call is not the best term. This is a barrier arrival is more specific.
It, it's yeah, the two operations are arrival, so waits for all the processors to get to the same point, and then wake up is once the root node has seen that everyone has arrived, then it tells everybody they can start advancing again.
I
Nice.
thought he was making a joke.
The what's up dog joke.
Yeah, that's what I thought
Oh,
he was
sorry, no, I
doing.
thought you were like genuinely confused.
Okay, so everyone has a copy of P0 has next? Or is that a like they all decrement a share copy or something? P0 has next.
I think everyone just like responds to their parent, and the representatives know about their parents, which is in a different CCSMP machine. So not,
Yeah. So only the parent has a one shared P0, right? So they are aware of the other.
yeah.
Uh, so wait for everyone to arrive. I just put a P0 has next on all these boxes or something. There's some like NUMA cache coherence thing to wait for on this. P0 has next.
I don't know if I get the parallelization argument because
It's not parallelization
I,
as much as it's reducing the amount of things you're syncing on, right? So only one out of these nodes have to sync
but
on.
the
Wait,
each of the children, right, can say that they're ready independently of like the other leaf node's children. So the only lack of synchronization in the drawing I had is synchronizing between the root of P3, P2, P1.
3P2,
But
P1.
but all of their children, all of the child processors local to that core or that machine area can wake up independently.
Yeah, it's just I think we're all spinning on P0 since it's kind of an invariant that all, if one of the parents are done, then P0's done.
Um,
Has next is a locking
Wait,
semantic,
so
but we're
like
talking
what
about
like so
barriers.
one of the cores on P3 would not be able to start until all of P4 is done, right? And then one of the
Yeah.
cores on P2 would not be able to start until all of P4 and then
That's not the
Hmm.
case. No, because the children of P3 can be like, I'm done, and they're telling P3 that they're done. The children of P2 can be done, and they're telling P2 that they're done. But P3 can't tell P2 that it's done until P4 is done.
It's kind
So
of
like,
invariant. All the children have to be done for the parent to be done as well.
yes.
Yeah.
But like all of the four array children can say that they're done independently. Like the children of P3 don't have to wait for P4 to be done to say that they're done.
yeah, like because in the diagram, P0 is the root. It'll just wait for all the children before it advances to the next whatever layer, if there
Yeah.
is one. So
okay.
yeah, same
I
for
mean,
P1. So it doesn't matter if P5, P6, or P7 uh, arrive in different orders. It's just P4 or whatever the root on that level is will just wait until all the children are done before it goes up the level.
Okay.
otherwise I have a hard time distributing
I mean, yeah,
16 nodes
it
in a tree, in a
it
four array
looks
tree.
correct. Like the drawing you have does look correct right
Yeah.
there.
All right, we have 20 minutes. I don't want to. We've been on this for like 15 minutes. I don't want to hold too long. But,
Yeah.
so that's the up
I
call.
think
But
yeah, I
then
think as long as you put the tree there and then
Mhm.
just put the diagram of the half child, I think it should be self-explanatory how
Yeah,
to do
but this should be something we should ask the TAs. Like, do we have a number for the number of cores per CCSMP? Because it looks like they just give us an image without the number. Uh,
Yeah, but the like the verbal articulation of this is that as much as possible you want to be checking local memory
hmm So check local
instead of
memory. So children and parents should be as local to a CCSMP as possible. So one
Yeah.
CCSMP is
yes.
a
Yeah,
parent
that's the
child set.
root thing. That's probably the core thing they're looking
Yeah.
for. Okay.
LRPC and
Is a
scheduling.
Okay. Yeah, let's just go to the next one.
child relationship. All right. Other piece parts, sub costs or the actual costs. So they're amortizing the setup over multiple repeated calls. Binding face is a sub communication channel. Haystack. I didn't get the difference between this and Geo's shared memory, besides just having a layer of kind of semantic understanding of what the argument shared memory is. Um,
It's just the difference between LRPC and like traditional RPC, which isn't doing this shared memory mapping for this.
uh, Client card is a trap. Trap is required. I remember this. What was it? This was a
Well, 'cause
validation. They had
yeah,
that bit that had the
validates the binding object, says
binding.
that the client can call the server procedure,
Yeah, validation,
and
and
then
then
the
also
kernel
kernel
also,
response.
well,
Response.
kernel allocates an E
I think the
stack for the
context
server
switch,
to
right?
Oh yeah.
execute.
Yeah, it
Yeah,
should be
Context.
well,
binding object. It calls it
not
trap.
context switching, but thread doctoring.
Yeah, thread doctoring.
Does anybody have a good understanding of like what thread doctoring is exactly?
It's like you
Kind
kind
of
of like
like an
substitute it
address
in the
space
stack in
switch, right?
place of the server, run it on without context switching, and then once you're done, you like drop the server process a little bit or something. It's like a not a full context switch, right? It's just like a substitute in place and then run or something.
But we
Seems
are
like this
doing an
is in the.
address space switch during a thread doctor like thing, right?
Let me see.
That is a good question.
Overheads.
Like I'm not 100% sure in like which way it is more lightweight. I know it is, but like in which way. And some of the things I'm saying might be dumb questions because like I am lost in the sauce. Like I'm actually like I'm
Is what 2
it's
a.m. for you?
rough at this time of night for me.
All right. Client server right if I'm mediation kernel permission. Yeah, what
So
was thread
just
doctoring? Binding object. Is a stub. So take arguments, copy into E stack. Who
No,
finds
it's
info?
doctoring the client thread to run in the server domain.
Yeah.
And what is meant by doctoring?
Uh,
It directly transfers the execution context of that calling thread. So instead of like dumping the registers and everything, the execution context transferred to a different protection domain, which is the server's domain.
I'm still confused, like, because so you have to like switch a PCB to like change threads or change process, like that would
It's
have
just
all the
basically kernels taking the client's thread and scheduling it where the server domain can run. I think maybe
versus.
the process
But we would still need
switched.
to, like, I would imagine we would still need to do all the things that are associated with a context switch, right? It's not like there's any wasted actions there,
Yeah,
right? You push things onto the kernel stacks and into the various registers, so you save your state for when you undoctor or return to the client thread, which presumably you want to do, right?
I guess it means just switching the address space back in the thread.
thread thread doctoring
I
versus
wrote a chat GPT output.
Yeah, exactly.
thread doctoring. I don't want to think too much about thread doctoring. I think this is all we
Put it
need.
in the chat. I think that kind of answers it.
Bless.
So it's like a temporary modification, kind of making it look like we are in the server now instead of the client. And then we kind of,
Do we get like full safety of that though? Like, okay, that it sounds more in line with like a like a kernel context switch where you have to do like a privileged call or something. So you like execute some kernel code. I don't know.
The
Uh,
answer for B is good. On to C.
yeah. Okay, link list is form parameter. You're running client stub. It should be copied. It should be like a deep copied or something. Or
Yeah, like a full
it needs to be
replication.
passed by value, can't be by reference.
Correct.
value is a deep copy.
Sounds good. Tornado. 3 points. We're at the
Oh,
end.
Holy shit, I never
all
thought
right.
I'd make it here.
All right.
This is all the questions on the PDF, right?
Yes.
Okay.
Page fault handling worsens performance for
Process
region
improves
deletion.
control.
Uh,
Replicating the process.
This answer is good. That's
yeah.
directly from the paper.
That's
I
directly
read
from the
this
lecture as
earlier.
well, right?
Yeah.
Okay, region destruction takes more.
Optimizing for the common case.
Region destruction
Because
synchronize
yes.
of the deletion.
Uh,
I pull it from the
Across
lecture.
all shares. Yeah.
Browse
All
all share.
right, we're done.
Besides that lecture two thing, I think we really have to just review it on our own and then come back and
Yeah, or we're screwed.
all right, just hopefully the hidden one is not all lecture two, or else we're all doomed.
it'll be lecture one on what is an OS.
Hard
I
hitting
It's
did not
not.
stuff.
review that at all.
Wait,
I think that's Yeah, but there's not a single one on there. OS structure. Yeah, two,
Maybe,
three, four.
maybe we should review that one.
He's
Wait,
I,
like
he's.
I, I
what?
don't think they asked any of that in like the previous year's papers
I've
as well. I
never.
think they're kind of just assuming that like, hey, if you don't know this, you're kind of fucked regardless.
Yeah, it was. Yeah, it was pretty much just him giving us an overview of abstractions and then talking about Google Earth. That's all I remember from that.
Yeah.
When
Oh
are
God.
when are you guys taking the exam? You said Sunday or
Oh man, I thought Sunday, but now that there's so much crap to remember, I don't know if I want to take it on Sunday.
Yeah,
I
it
got
depends
work,
how
man.
much
I can't.
studying.
Yeah, I know. I got work on Monday. I
dude,
didn't
I
plan
I
to take
I I I
Monday
took the day off work on Monday for this.
off. Snap. Maybe I should just tell my boss I'm sick on Monday.
Is it possible?
Allegedly, this is uh, the difficult part. I don't know. I read like some ed stem thread that was like, "Hey guys, I took this class last semester, and this was like the hardest
How to
part."
survive or whatever it was.
Yeah. So
What's the weight for this exam?
109.
I know, I mean like on the grade, how much
It
is
like
this
12,
is
exam
right? Isn't
weight?
it?
It's
12 point.
16%. This is the highest weighted test.
What the hell? I stressed over freaking homework zero. It's only 3%. What the? And class participation's at 5%. So if you're not on ed, get
Dude,
on
I
ed.
gotta be ed posting. I need to be ed posting.
Ed maxing.
Ed maxing.
Two paper summaries. I didn't even know about this until like people started complaining about it.
Hey,
Who?
so do
Who's been
you,
complaining? I didn't see
It's like,
anything.
oh, all the papers are full. Oh,
hey, do
I
you guys, in your grade section, do you guys have like dated things worth points?
these are the hangout
Yeah, those are the
summaries,
Yeah.
and
hangouts.
I did really badly. The only one I attended.
I'm pretty sure those are really just attendance based. Like if you
Yeah,
just show up and you like answer most of the quizzes, I think you should be fine.
they're really
I've never
discriminating
been to
against.
one. I didn't know that
I
I
think there's
it would
like
be
a
joined.
worth so many
slight extra
points.
credit for
Yeah,
them,
Yeah,
I
it's a
think.
slight. Like they said, like if at least
Yeah,
like
it's very
80%.
small,
Yeah.
0.5%. Like, yeah.
But I mean, I
well,
guess
after
if
this
you like
test, we're gonna need it. So,
I'll see y'all there.
yeah. Freaking turning point. I look it up. It's like some kind of political group. I had to
Yeah, I know.
do
I
it
thought it
too
was so hard. Like he kept saying turning point. I was like, what the heck is this? I can't
because it
find it
turned it Echo
online.
360 point solutions. I guess they got name squatted on by some kind of political group and then had to change their name. Uh,
Oh man.
they gotta update this. I don't want people getting radicalized by the freaking.
Oh crap, we're supposed to be doing lesson 5 by this week too?
No, well, at least they moved it, like they moved the hangout and shit to Thursday.
I
Like
mean, okay,
he
that doesn't
knows
really
and
help
like
much.
Test one clarification thread. Okay, I'm gonna post something about this Numa question with the. Okay, I'm already sleepy. The this Numa question about the MCS barrier. We don't have a count on the cores and nodes, and we know there's like a four-array binary thing. So is it gonna be like a super generic answer, or do we need
Dude,
counts?
are the TAs gonna have office hours this weekend?
They said they're gonna be watching the thread until like
yeah, I
afternoon.
don't think there's any office hours. I think there's office hours
Yeah.
on Monday, the regularly scheduled ones.
Yeah. Or they will be watching until.
Man, this like last 20% shit has me like a little bit concerned as well.
Well, I mean, I look at the previous. It's not as bad as
Is
this.
it not? I didn't look at
Let me
the
pull them up right now. So this is spring 26. The hidden. He didn't even show them.
I would
Um,
suggest doing the review summary, like the review questions for the papers.
yeah, those are good. But these ones, I think a lot of these are more closer to the lecture. So the fall 25 ones, VPN, PPN.
Okay, that's
Yeah.
very
I mean,
reasonable. Okay,
okay,
what
These
else
that's
you
are
got?
reasonable. Okay, I'm guessing it's because they know that we
yeah.
can't prep for this
True,
one,
false.
like before the exam, so they make it a bit easier.
Yeah.
Okay, very reasonable. Okay, what else we got?
Blocks and
Blocks and
barriers.
barriers.
This hardware, it's all true, false, with justification though.
Wait, is it really just true or false? So you get a
Wait,
50%
true,
shot of getting it
false,
right?
but with justification. So no
Right, right,
credit without
right. But like, I
justification.
mean, yeah.
It came to me in a dream. That's what I'm just thinking. I'm Ramanujan or something. I don't know.
Okay. I mean, I
Uh,
can live with that. You know,
yeah.
This is
50%.
the fall 25. Can you pull up the spring 25?
The
Is that
Spring
also true or
25
false?
is empty.
What?
Wait, the hidden po oh, ours is empty. This was 23. This is it? There's a hidden. Oh, yeah, this was in Design L3 Leak. We talk about him like this is the freaking Bible, and he's like having his revelations or something about microkernels. The fact that he uses mock as an exemplar, as an exemplar for microkernel performance. But so there's still some paper justified ones, it seems. I feel like based on the difficulty of these other
No, no,
questions.
he covered this in lecture.
Okay, so these are more lecture bit biased, which is not too bad. Zen's I-ring data structure.
Spring 2025 test one.
Uh, Looks like some people are dropping off, headphones are dying, all that. All right, yeah, we have 7 minutes if you guys want to continue staying on until our scheduled end. Right, API.
Does anybody know what the past, I guess, the grades average have been for past semesters? For at least a test.
It was let's see what the OMS Central Review was. Uh, if there's big consensus, is probably the correct answer. Right, I would agree with that.
I do like Kishore as a professor. He seems like pretty chill.
Yeah, fifth course.
Guys, discuss the full versus para question, the part
Oh,
B.
the part B.
I'm still a bit confused about the answer.
Part B for full
Full versus
versus
para.
para. All right, so part B. So you have a memory footprint interactive process. So that's a lot of disk or memory page access, like memory address translation stuff. Or any type of fully virtualized environment on Zen, which you see a significant difference in the performance of the two.
So by the interactive process, it means it's like I/O processes, right?
It says memory footprint, which is
Like it's small memory footprint, comma
so
interactive processes.
lots of that would mean lots of page tables, right? One page table for each process. Um, but they already started up, right? The part A was thinking about the creation of these processes once they're already running.
Yeah, the party had like heavy workload. The
Mhm.
second one is like small memory footprint but interactive. So I'm reading it like this that they have small memory footprint but they are interactive processes, which mean they go for I/O. So
Would
that's
interactive mean IO, or is interactive like the operative word? Is it like interacting with memory, or is it interacting with
I think
like
it's
devices?
interactive processes means they go off for I/O and then they have to like wait for the I/O to complete. That's how I am seeing, and someone has written that fully virtual uses trap and emulate. That also corroborates with interactive being I/O.
Trap and emulate. But trap and emulate will also relate to the address translation, right? You trap the virtual page translation turned into the machine page through a set of abstractions.
You think in terms of memory then, right?
Yeah, I was thinking like memory footprint would mean trap and emulate for that whole page table process. But it seems someone's thinking about IO devices here.
Wait, which question are we on?
Question 4B. This is something we should ask. What is memory footprint
I
charging
think
for?
I think that's a good idea.
We are in
Virtualization part B.
full versus para virtualization. Part B. What
Wait,
does memory footprint interactive process mean? Uh,
Yeah.
what
It's like
does
small memory footprint. That's what the question said.
small memory footprint does the
This mean.
interactive word or the keyword mean interacting with memory or an interactive IO process?
I think we're in a pretty good
All
spot.
right.
I think we covered a lot tonight.
Yeah. Or at least we have a first pass, which is good for
Yeah.
someone who's up at for you guys like 2 p.m. or 2 a.m. or something.
Do we want to schedule another session for tomorrow? Or I guess
Oh,
now it's today.
there's the East Coast one really early in the morning for some people, and then we can do
But
another one if that's.
are they going to be adding on to this one, or they're going to be making their own doc?
I feel like they're gonna add on because I think this is the generic doc that
This
was
is
used
this
Yeah.
is
earlier,
the
right?
master or main doc,
Okay.
and
Should we
uh,
should we keep a copy right now?
we have a history on this, but we
Yeah.
can download a personal copy.
Yeah, I'll keep a copy.
Save a copy. I'll keep a personal copy. Class doc, end of PST says APAC. All right, that's where we are now. And then this is a.
Does the call automatically end at 3 or what?
No, I just schedule it to end at 3 so we know start and end time box this, which I think we did a good job of spending 30 minutes on part A of one question.
It is good that we it's good we were able to get to a faster pace after this.
Yeah. Well, because freaking lecture 2 is just dense, and the way they rely on the research papers to
Mm.
come up with questions.
I feel like 3 is the easiest, I want to say. 4 is not too bad either.
4 is not too bad because it's mostly synchronization and cache coherence until you get to the NUMA part. Then that gets a little trippy.
Mm.
Um, 3 is not bad. 2 is all right. 2 makes sense up until we start getting to Zen L3 and all that because I think the first half of it was not that part. Actually, no, it was all that part. It's just all research paper based. Yeah, 2 is probably the densest if you want to review the lectures again before we meet again. Yeah. When is everyone free on Saturday or today? Um, Afternoon for Pacific or
Well,
probably
is
more.
this just for like chatting about the exam or like what are we meeting up? Like what is the purpose of this?
Do you want to refine the questions? Like we can spend some time on our own looking at lectures, citing some sources, and then once we have some sources, we debate on which one's the more accurate one, or I don't know. We'll see who joins the Eastern one in the morning, and then
Man, I'm so jealous of those guys. They get to wake up to a nice Word document.
it's gonna be like a bunch of midnight hallucinations about what Professor Kishore said. Okay.
Yeah. I don't know if Gemini is accurate, but it says that the average grade for exam one is in the mid 80s.
46.8? No way. Course critique. There's a critique app for Georgia Tech? No way. No way.
Wait, what is this? Critique GA Tech. What is this?
Critique.gatech.edu. No, 46% get an A? This would include a curve, right?
I feel like this. Oh wait. Oh, this does include the people that dropped the course, huh? You telling me half of us are coming out with A's? Holy shit.
Or including Kishore, withdrawal 26.9%.
So a third of the class drop, and then of that remaining, almost half the class got an A.
It's
Wait,
pretty
does this
good.
sum up to 100?
Wait, where are they getting this data from? Is this accurate or
Is this including on campus people?
it looks like it is,
Oh my
right?
gosh, look at this drop. 3.64 to
Because
3.05.
it says the lowest recorded GPA 2012. I don't think was this like OMSCS wasn't a thing in 2012, right?
Yeah, filter options. Let me see.
Where,
Very
where are
large.
they getting this data from? Do you know? Or
It might be just people who like, I don't know,
I
surveyed
I
after
think
the
this
new
is
class.
including in person as well. It's probably why it's biased upwards, and then they stop collecting data.
because if it's a survey, then I don't know if it would be representative. But
They have like a Tableau board I could look at. Uh, Home Essential.
Dang. Dang, I'm reading on Reddit right now for people who took the exam 5 months ago, and people are getting like 30s and 40s.
wait, but how? They release 80% of the exam.
Yeah,
There's
I
no way
know. I'm
anybody
just
should be getting
confused.
a
Like,
40.
either these are the people who like didn't participate in the group discussion and just like went in without knowing how the questions are.
But even like we did the hard work. Like even somebody that doesn't like understand can just like
Yeah, I know. You don't
memorize
have to
them.
understand like, I mean, even if you didn't read any lectures, as long as you read everything we wrote down, you would probably get at least an 80 on it.
Well, at least
At
a
least like a
50.
50.
Yeah, at
Yeah, yeah,
least a
okay, maybe a
50.
50. But I mean, assuming our doc covers exactly everything you need to answer for each question, you should be able to get
Yeah.
an 80 easily just by reading the
Yeah,
document.
so then how are people out here getting 30s and 40? That
Yeah.
doesn't make any
I
goddamn
Yeah, I don't
sense.
know. Maybe it's definitely the people who like
Mhm.
didn't participate.
Yeah. I feel like starting from virtualization onwards, if you read this, you would have a pretty good chance at these questions. This one we're still
Work in
very unconfident
progress.
on.
Maybe
Yeah.
they get the marks in the test, but not in the projects.
Mm.
I I I want to hope that my project one was fine. It looked
Yeah.
fine when I submitted it. I want to say it's fine.
I think some people were sharing charging one
Yeah, there was
share.
a thread where people shared their graphs, and I think
Yeah.
like because the README just said it's looking for functionality. So like as
Yeah.
long as your graph was like as expected, like everyone else's, you should be pretty okay.
Hmm. Yeah. I think five. Yeah, five. This one's balanced. Look good. Uh I did not post mine, but yeah, I tried moving multiple CPUs at a time too, but then there's this big spike at the beginning. It throws it all off. Um,
Honestly, I'm just hoping they just go off your graph and it'll actually like run it to see
yeah,
if it actually like reproduces the same graph.
it is very
Oh God,
inconsistent.
I
It is
wasn't even
very.
thinking about that. Now you're unlocking
Put my
trauma
graph
for
in the
me.
chat.
No, that's what, yeah,
Oh,
so that's what I was thinking. Like, do I have to like fix every edge case? Like, what if they actually like, oh yeah, let me try running it to see if I can reproduce his
yeah.
results.
It's very
One of my
inconsistent run to
graphs
run.
was like a little bit iffy on a certain like
Yeah.
sometimes I'd run it and it was like repinning and sometimes it wasn't, but that was for one specific graph.
Yeah, it's like once I got the graphs that looked like everyone else, I was like, okay, I'm done. I don't need to fix it anymore. Just don't
Yeah.
touch anything.
I just if after iteration 10, there's no more pins unless it was that one where there's a hump. Like,
Yeah,
yeah,
I mean,
that would be good.
if your graphs follow the general trend like everyone
Mhm.
else, I think it should be fine.
Yeah. I hope they're not grading the readme too hard, but that was just one point.
Yeah, it's just one point. I think it's just okay as long as you look like you implemented something and wasn't copy and paste from somebody else's, it
Yeah.
should be fine.
All right. I don't want to think about Project One anymore. I'm like, this is behind me.
I'm out. I'm out of that shit.
I haven't even looked at the Project Two brief. Like,
It's like barriers. Something about like, yeah, it's just implementation for barriers and some like
uh,
performance testing.
But basically the rough way it works is that you have two specific platforms, and then I think one of them is focused on like a message passing style implementation, and One of them is a shared memory style, I think.
Yeah.
And you have to implement two barriers on each one. And then you have to implement one barrier that's like a combined. And then you have to like run experiments and testing on all five of these that you
I
can
think the
memorize.
major part would be the experimentation because they don't give you any test cases. So you have to read the paper and think about how to generate the graphs.
Uh, I don't want to think about project until we finish the test. So
Okay. But for project two, do they show you like what the results are supposed to be, or they didn't even show you
No,
that?
No,
nothing.
oh
there's
my
no.
God.
You just have to copy the paper, the
God,
MCS
you're
Mhm.
really
paper.
kidding
Do
me.
your best.
Yeah.
At least project one was straightforward, as in, okay, if your graphs look fine, then you're pretty much done.
Yeah.
Yeah.
I'm surprised people didn't know about the logs. You could like check the logs on the project, right?
Yeah.
I posted about it and then people didn't realize like if you open up the console, if you do print statements, like you would get the logs in here, which is how I did it. But
Yeah, I also just downloaded the logs after I ran mine, but I was like, okay, as long as the graphs look fine, I don't really care what the logs say.
mhm. All right, it is past midnight for me. It's
Yeah.
probably way too late for you guys, but I'm
Oh
gonna end it
no, it's
here.
Past midnight.
midnight for you. How
Yeah,
sad.
yeah, because 7 hours from now we're gonna do another one. And I'm gonna open up that
Yeah.
call as well. So
You're going up to the Eastern one?
I created both meetings. And then some people don't understand ISO 8601, which I'm kind of sad about. But yeah, I'll be on both.
I'll be
Um,
joining too.
yeah,
It's like
Wait,
7 a.m. for me.
wait, when is it for PST? It's
7 a.m.
7 a.m.
it's in like 7 hours.
I mean, what are you even gonna do there? Like the docs mostly filled out, right?
Yeah, I know it's mostly filled. I guess it's just reviewing at that point to make sure the answers are.
Able to join. Um, yep, so if you guys were not on the last call, last night, what we were doing is opening up this thread. I think Omar shared this class talk. So this is this 7702311 thread. Um, and there's a SharePoint inside that thread with the stock that we've been working on. And then last night we went through all the questions and did a first pass where we were trying to get like a low effort answer in a few minutes so we could have something down and then come back and refine them. I think we are struggling a bit on this lecture two part with the OS structure. We still have to go back and find some better evidence for some of these questions. But we did pretty good, I think, on the L3 and lecture 3 and lecture 4 parts if you've been going through this thread. So if anyone has any expertise on the lecture 2 content, yeah, please feel free. We can start editing this. But I think one thing we should do during this call is go through all these questions again in order and double check some of the work that we put, or if you have any new um, ideas or points that you want to put for these questions, like refine them to their a little better. Yeah. How many people are we? We're at 12 um, joinees. Hi, Harry.
Hey.
Hi, Demir. Who else is on this document? 40 people. All right. You want to get started? We're going to get top down from the first question. So, Open up the previous ones. Did some of this just get deleted on the doc? I'm not. Also, like there are some edits.
Looks like someone just nuked the document.
Oh my God. You, all right. Is there like revision history on Word? Browse revision history. All right, someone just edited like 3 minutes ago to delete every question. So if you have uh which version? 702? Is it me? This is at 702. Looks like the past 3 minutes, or 1 minute. Actually, I'm not sure what time I'm on. Yeah, a few minutes. If you guys are on, could you restore the previous answers to the questions?
It looks like it was you
Wait,
from revision history.
version, do I have? Oh, I don't have that history. Let me.
Like press on your modification, I guess.
It's not showing. So if I don't see, uh, file. Let
Do
me see
you
on the. What did I do on this one? Let me see. Wait, wait, Harry, do you have this? Where's my edit? I don't know where my edit was. These are in red. That's in blue.
restored this one?
Yeah, let's restore this one for now. If anyone is commenting, you probably have to. So everyone else has to close the document and reopen. Is that okay?
Yeah, that works.
Okay. Sorry, y'all, I think there's some syncing stuff with SharePoint. Oh, it's still not restored. That's weird. File. Probably do a copy then, or not sure. So this was 5 minutes ago. Okay, maybe the other one you just have to close and reopen to see the previous version. File recent. Oh, there it is. Okay, I think yeah, close and reopen or something. Right, and then we lost someone's like well-written answer. Oh, here it is. Okay, so if you don't see this, all right, I think Nicholas posted his answer about the spin 1A.
This is the only one I've done anything on.
It took us 30 minutes last night to get through 1A, so
So the thing I was trying to call out is the compiler citing is the theory of safety, and then the sharing resources at memory speed once resolved was the theory of performance. But I don't know if I'm right about that. Willing to listen to others on that.
yeah, I think the safety part we were a bit confused on. There's not many good points, but the once we do the linking or the resolving, that's a language feature, and then those same name variables are visible across the protection domain, and then there's some performance there. Uh, I'll go to reviewing. So maybe if you're on the stock, change over to reviewing at the top so you don't edit. You have to suggest a change before you make it. That way you can get like these um, colored things where you can see who suggested what. Um,
I'd say just paste it in, um, yeah, at the bottom of the question, and then we'll just go through, and then I think we should trim some of these answers.
yeah.
I guess we should just start from the top and then just read the answer and then evaluate and expand or remove it.
hmm Okay, I don't think I can copy a Zoom message, so I think Nicholas probably have to paste something in at the end. Uh, the heck? Someone pulled a answer from how spin performed in fall 2025 for kind of half of this answer. Um, So +2 for any of the following. It's a dynamic linking into the hardware address space, virtual memory management, essentially define application-specific system calls. Okay, so I think there's two parts to this question. One is to explain how the domains are created, and then which is this section, and then two is to either justify or counter this assertion that at the beginning of the question was the strikes against spin.
Yeah, those assertions are that spin's not performant and also unsafe. So
Yeah,
they're both clearly wrong.
yeah, and
So then we just need to explain how to create protection domain and then perform why is it why is it performant and why is it safe. So I guess we have the three sections down.
mhm.
So yeah, let's go through the points and then refine it. Okay, so how it creates protection domain. The correct answer we have is packages OS services as modular 3 objects which supports exported interfaces. So I think I wrote that one last night. I mean, it sounds correct to me, but um, I don't think the lectures covered this that much. So yeah, it'd have to be from the paper.
Yeah.
I mean, for this one, couldn't we say something about the dynamic linking that's involved to, ensure performance because it reduces kind of like the overhead involved?
I think we could stick that in the performance section. I mean, if you were doing this on the test, I don't think you would even need to label what you're answering. You just put these bullet points back to back. So then that could
Mhm.
be the first one in the performance section. So yeah, go ahead and paste in that dynamic linking part.
So I think safety, there's some points here on unforgeability in section 3.1 of the paper. So capabilities unforgeable reference. Um, Individual resources are protected to ensure extensions are only to the resources that have been given access. And then compiler compile time prevents a pointer from being forged or dereferenced in ways inconsistent. There's no runtime overhead with using a pointer. Uh, just pasting quotes from the paper if you can. So we have a place in Go. Uh, for more evidence. Give me pass. I pasted in a few quotes. I'm just pulling from the paper here. 1, 2, 3, 4. So for the creation, do these three quotes kind of suffice? Can we summarize them as like 3 bullet points? Create will initialize the domain and export, but not do any importing. Resolve will do the linking across domains if you want to start sharing symbols, and then combine. Wait, no. It create resolve would resolve some of the names for dynamic linking, patch them into the target domain to allow resource sharing, allow cross-linking, and then combine will union existing domains to create a new domain that is a linked namespace. So that's the explanation of how partition domains are created in the end of section 3.1. Create, resolve, and combine, which I think is what the body of this question was. And then after we explained that, we explained how that provides performance. Collocation. I don't know where the quote for this was. I do recall this collocation point in the, I think, beginning of the paper. Yeah, dynamically link compile libraries who run at procedure call speed. This was, I think that's probably something from the lecture, but also section 5.2 resources. What?
The paper has a section that says memory speeds. I don't know if there's a difference.
Yeah, that might also be one system performance end to end, so they can benefit. There we go. Memory speeds. Okay. 5.2. Try to find a quote for this. So first, it uses kernel extensions to define application-specific system calls for virtual memory management. Installs handlers on its that occur within. So there's handlers within the virtual address space. There's no switching outside of the address space to do these kernel calls. In contrast, they provide a Unix signal and interface, and they use an external pager. Uh, Focus on generalized functionality since dominance is that each, and they post these as a performance thing. Some handlers. Neither signals nor external pages have especially efficient limitations, since the focus is generalization. Page 18, bottom. Um,
In section 3.1, it states during resolution, text and data symbols are patched in the target domain, ensuring that once resolved, domains are able to share resources at memory speed. That's why I wasn't sure about the language.
At memory speed.
Yeah.
Is it page 8?
It's tough because the pages aren't labeled on the freaking PDF. So
No line numbers either. It's really tough.
yeah. So 3.3.3.1,
Yeah,
bottom
3
left.
dot
There you
3
go.
yeah, firing
Bottom
control
left.
heads.
It crosses over between the bottom left and then the next section. Domains are able to share resources at memory speed. You're right there.
Bottom. Okay.
You're there. You're
Yep.
right there.
Domain or patch ensuring that
That
their
sentence. Keep going on that
Yep.
sentence. See, at the very end, it goes memory speed over to there.
Yep.
Which I basically, like you said, like a proceed, like there's no. That's the domain crossing, right?
Yeah. So they're all in one. I'll put this up at the top here as well. Now, that's kind of a point of resolution. So point for speed.
Yeah, that's why I think safety is the compiler signing and
Yeah.
performance is the resolution in the domain. I think. I don't know.
Safe performance is resolution of the domain, firing control. So the handlers are within the virtual address space because of this whole resolving point. So the handlers don't switch address spaces. They're operating in the same region of memory. So there's no like page dump and swap, and my thing is not rendering. Uh, 5 point. Spins in kernel predicted procedure call time is conservative. So modular 3 generates code for an intramodule call, which is twice as tough as slow as an intramodule code. Crisis clarity. Probably this not perform inlining. So the overhead of the protected communication can be in the procedure call. If you have a procedure call executing in. So that's not a design thing. This is just saying that the speed is equal between the protected in kernel and the system call. Spins does not preclude. However, the spirit of performance of protected in kernel call and other mechanisms encourage the use of in kernel extensions. The spins allows applications to find specialist fault handling extensions to avoid user kernel boundary crossings. So because they're able to extend or create extensions, they can avoid user kernel boundary crossings, which is page 11. So there's less signaling or external, there's no signal or external paging like in other operating systems in Spin because they can do specialized management. And then second reason is that for each virtual memory event, which requires a series of interactions between kernel and application, yeah, there's a fast in-kernel. So that virtual memory events are reflected through a fast protected procedure call instead of a boundary crossing or a trap message. Those are some things for performance. They interact through direct procedure calls, and that would allow that will reduce user kernel boundary crossings, which is mentioned several times in page 11, and I think this is actually page 12, page 5.4. Page 11 would mention. So for several user kernel boundary crossings, instead of doing a boundary crossing or doing signaling, like another OS, I think they mentioned mock and deck, um, they would, so they don't have as many messaging. They do procedure calls, which is faster than traps and messages. Okay. Okay, and then part B, I don't think anyone's had many. Um, so speed versus safety. Yeah, access to hardware mechanisms are hard to abstract, so they're provided as core services that are given through Spin. Uh, and this. And I don't know if Nicholas, you could post your questions that you're putting into the Zoom chat because I can't like copy and paste those, but they're really good answers that we could.
Hey, thanks. I'll copy him in there. You just had me scared, and so I got out at the beginning.
Yeah, that's why
I
I do
swear I didn't
the.
delete. No, I'll copy
Yeah,
him in there and
yeah,
try to keep the formatting a little bit better.
yeah. Thank you. It looks like question one, we're in a good state. Looks like Gemini answer. Memory safety and isolation in favor of hyper. Even spin or do certain things in hardware. The spin-offs has spectrum type protection boundaries. Yeah, that was a direct quote from the lecture, which said that these trusted services are not uh, are hard to do because certain things in hardware need a bolt that point for part B. Then question 2 on spin. You've implemented MyOS using extensibility in spin. 2 user level process on top of MyOS. One's currently performing CPU intensive computation work. Global.
I've been staring at this one for a while. The global scheduler is unrelated to how I think the OS implements strands. I mean, like the my OS is what we're implementing strand on, right? For our threads. That's the question, right? How are we implementing our strands to handle these two processes on top of our OS? Am I understanding the question correctly?
Yeah. Let me. You've implemented MyOS on some of the extensibility mechanism in spin. There's 2 user level process. Uh, how do you prevent the first process? I think that the first part is a preamble. So how do you? This is the. So you have to implement the custom checkpoint and resume at that point. Um, so I guess they're looking for an answer on how to design the checkpoint resume to interact with the global scheduler.
Okay.
So additional applications to schedulers and we place on top of the delivery of resume indicates that a new schedule can schedule its own strands. The block and unblock are routed dispatch. So you have to design a global scheduling policy and design a global scheduling policy, knowing that the workload would be um, you have to you have to design a global scheduler policy to replace the default one across the whole OS, knowing that the workload is not equal across processes. And then I guess go into how you would design that. So the current implementation is a round robin preemptive priority policy. This might be something you have to dig into geos to think of a policy that's good for splitting up these uh, CPU intensive and non-interactive processes. So we do a like a there's like a way to like decay or something where over time you would increase the priority of something that wasn't scheduled.
I think the key here is, given the question is asking about, one process hogging the CPU and the other not being able to get CPU time, I think the key there is that our scheduler be preemptive, right?
Preemptive. Yeah, I'm pulling my geos notes and trying to find policies.
If I can jump in, I'm pretty sure all you need is to set the priority of the long running process as low as you can, right? As long as the web server is higher priority than the other process, it will always preempt if it has something to do. I think that's all you need.
Server process is higher priority and preempt the long. Be preemptive and priority based. Preempt the long running process. Yeah, that sounds correct. So based on the paper, we know that the global scheduler is replaceable at the entire OS level. And then because of that, we can change the global scheduling policy, knowing this is our workload, that it's not just that a round robin won't serve this process well. Uh, and because of that, we can replace it with a priority-based preemptive scheduler and then give the web server high priority to preempt since it needs to serve fast interactive requests. Um, oh, the global scheduler implements a round robin preemptive priority policy. I think I quoted that sometime.
I don't think you even need to replace the default policy.
Yeah, I think, but this is a new OS using accessibility mechanisms in Spin. We've
Yeah,
had
I'm sorry. Yeah, I agree that we don't want to. I don't think the question is asking us to manipulate the global scheduler. I think it's asking us with block unblock and checkpoint and resume, what would we do to make the web server responsive coincident with this long computational process in our MyOS implementation of the strand of both. Is that am I even understanding the question correctly there? Does anybody else concur?
Uh, yeah, and I think an additional point here, going off what you just said, is in the paper on page 8. Let me see the section. 4.2, on the right, just below the figure.
Yeah.
Additional application-specific schedulers can be placed on top of the global scheduler using the checkpoint and resume events. So instead of what I'm thinking of is, instead of replacing the global scheduler like it says in the next paragraph, we could have an additional application-specific scheduler on top of the global scheduler, and then, like you were just saying, use these checkpoint and resume events for to manipulate these two applications that we have. That's sort of how it's fitting all together to me.
Yeah, so I think knowing that we can replace the application scheduler. So in that case, like for the web server, since we know it's coming in and out to serve these interactive requests, we can update that scheduler to not blinking here, but update that to be have a fast replacement policy. Uh, should design additional application scheduler for both of the running applications. Interactive application knowing it require a non-CPU request, frequent non-CPU requests should. So if we have like a non-CPU request, like an IO request for an interactive application, in that case, we didn't want to do long time slices, I believe. It was a the long running application can use a into completion application for a long CPU operation. Right, that's my initial pass at this application scheduler. So looks like we're not updating the global scheduling policy since the spin one is exactly what we want, which is that preemptive priority policy. But within each application, you may have multiple threads. The interactive application, knowing that each thread won't want run very long, can do a shorter time slice for each thread. While the long running one, since it knows it's going to do a long CPU operation, doesn't want to do many switches between processes and then just have a long run to completion on its application level scheduler. Does that sound like a accurate, cohesive answer? Is that more or less anyone have any comments, questions, concerns? Okay. I think we're already 15 minutes in and we only got through two questions, so I think we should start moving a bit faster, but this is a much more detailed answer than what we came up with last night. Um, Are we good on the spin questions? Are there any other things to raise here?
Yeah, like you were saying, time is of the essence.
Yep. All right. I think the next one was L3, and I recall last night we were not too familiar with L3. Fluffy architecture is not is difficult to modify, whereas the well, if this is not easily extensible. Also, someone cited the lectures, which is awesome. Um, that looks accurate. So we can, because it's modular, we can only replace the debugger locally instead of having a global replacement to do this custom debugging, which is limits kind of the blast radius of our change to only the um, custom implementation instead of this global update. Um, it's structurally safer as custom pager run his own hardware address space, protection domain. I'm actually not sure about this address space section on this question. Custom pager run his own.
It looks accurate to me. Like if there's, a failure in the custom pager, then it'll be only a failure in that it's isolating the failure
Mhm.
to that one hardware address space, and L3 is the one that has the or no it isolates that failure to the protection domain, and yeah, L3 has it's a microkernel. It has different protection domains for
Yeah.
each of the extensions.
Okay, so that sounds right. I think the other ones are just it sounds more accurate since we have a like a source to them, but I think if we can find a lecture where that mentions that or in the paper,
Yeah.
that would help. But that looks good for now. And then question two, this one is a long five-parted question. So why would you put kernel in each of the clients? Uh, how map was done? Yeah, I think that might be a TA question if Javier is asked that. I don't think there's border crossing even without mapping. Kernel lives in OS extension, which lives on the same side as the border. Client makes a call containing the kernel lib. How would this handle? This looks like a detailed answer, and I don't have any like detailed counterpoints. So, oh, I think that's accurate. Part two, C. Friends curious how design gives memory isolation guarantees for clients. Agreed. ASIDs prevent TLB flush. But when switching, I don't see how they restrict access to other memory. I thought ASIDs are more of like a TLB thing, where if the TLB, so we can like speed up the check on the TLB, right? Instead of if that TLB entry is accurate. I'm not sure if it is a process to process isolation thing. Um,
Yeah, so we don't have to flush the TLB on a context switch. Yeah,
yeah,
the process, the safety in between protection domains is either through segment registers on whatever those architectures are, or separate hardware address spaces.
TLB to prevent flushing between. So looks like this bottom one here, this each one has its own address space. So in conjunction, oh, so I think this is like kind of like a logical sequence, ASID, then plus its own address space. I get that that's still just a TLB like flushing thing, because if you like needed absolute isolation between them, you just have different TLBs for each process, right? This one's trying to ensure that you don't flush a TLB, you just keep it all in one, and then on the check, it's either valid or invalid with the ASID. is a segment register. Yeah, I'm probably leaning towards the segment register as a more correct. Um, yeah, I think Joseph also commented the same thing here. It's the logical domains or event cross access. Yeah, I'm thinking lean. Segment registers being the correct answer here. What's going on in the chat? Bottom of RHS page 6. Oh, this is for a different MyOS thing. Okay, I think part D and E we were having lots of debate of last night. Looks like someone quoted Lee K's paper. Implies this is false. So the kernel is protected from the client, but the client is not protected from the kernel since the kernel can access these spaces simultaneously. That would sound right. I think someone's gotta do like a proof by decomposition of that statement and then see like what that each of those like things would imply on the access part. But then D, we don't have much justification for part D on this one. We had some arguments last night about how we would design the base segment registers. I think someone brought up if you set it at 512 for the base, uh, then that's more the application level access. We kind of restrict the kernel access of the first 512 megs of the address space. Um, Let me pull up Lee K's paper on microkernel construction. Yeah, this was a hard to read paper because just how dense it was. Array, thread switches and IPC address space switches. Uh, Sorry, I have an alarm going off my phone. Uh, okay. All cookies. So on micro, I don't know if this is easier to search. Okay, it probably is. Republication. Let me look up having kernel lib. Speed of execution. Map. The owner of an address space can map any of his pages into another address space. So we're not like duplicating the data, we're mapping it. Is that to prevent like a TLB flush? So since we have the same like address space or pages that are removed. I'm thinking this is like a TLB optimization. So since you have the kernel lib mapped, then it would have the same like ASID and all that. Page of that page 2. So kernel address space is mapped. Okay, so kernel has its own address space, and then it's mapped into all the other address spaces, which would is this like a TLB optimization? I wonder if anyone has any disagreements or changes to this answer. Since kernel is mapped from its own address space to another in the tagged TLB, it will not be flush.
The other benefit of putting things in exokernel combining different protection domains into hardware address spaces, in addition to TLB optimization, is cache locality, right? Like you'll get warmer caches if you're not switching between hardware address spaces.
This was something on lecture 2. The tag was from a hardware address space, right? So if the kernel lib was, one hardware location for the code, it would have the same tag.
Yeah, yeah.
It's common across all address spaces since it is the same hardware address mapped into all processes. The tag would be the same in the TLB. Derived from the hardware. Be the same in the TLB. So that leads to TLB optimization. Since we map it instead of duplicating the code, the tag in the TLB is the same. And that will stay fresh in there because it's going to be looked up several times in different clients and not flushed, since it would appear the same in the cache. And then since they are the beginning of each of these virtual address spaces, it would also have the same virtual uh, end of the virtual address, right? Uh, process. It would have the same full address offset. That will lead to TLB optimization since you would prevent flushing of the kernel data. Uh, since the tag derived from the hardware address is consistent across all domains, virtual address spaces. And First section. So I'm thinking primarily is probably TLB optimization since I don't know, and then cache locality. Yeah. Let me think. Need TLB flush when I use tagged. Oh, here it is. Explicit cause and then implicit cause is a cache locality is an implicit. So this was more of like a lecture thing on lecture. Uh, so this is an explicit cost is TLB optimization. Implicit cost. Implicit cost. Okay. The explicit cause is the cost for not flushing the TLB at a context switch. Um, the memory footprint is so big it occupies hardware address space completely. That's the explicit cost. TLB address space is not tagged. Uh, yeah, so we maintain cache locality. Um, and that makes sense based on, I think, I don't know what the lecture number is. We should cite that as this question if you want to review. Exokernel, microkernel, yeah. So lectures 9 to so 8 to 12, I guess. Review lectures 8 to 12. 8 to 12 for this answer. Uh Client makes a system call contained in the kernel lib. How this handled in your design. So this is a Gemini answer. System calls are implemented by IPC. Strikes against microkernel. Right, each of these are all 2 points. By construction, they're really large. I think we've already been on this for like 10 minutes, but I do want to just nail this down. Um, I think I think we've looks pretty good based on what I've seen on lecture so far. If anyone has any complaints, B looks like there's no concrete answer here. I think one person put trap. I think that was probably my answer last night. This one is a very detailed execution. Um, Gemini says there's no trap. Uh,
Uh, if the syscall requires like protected or privileged instructions, right? Then I think we would have to trap to set the processor bit on like the protection bit on the CPU, or change the protection level on the CPU.
Yeah, but is that true for microkernel?
I mean, I
there's
think that's a architecture specific thing, like regardless of the
Yeah, I mean that's what we generally learned. It's just yeah, the microkernel part, because I mean the kernel library is in user mode also. So
Mhm.
maybe if the kernel library needs a protected call, it'll make it. Um, but if we're trying to use the library, if it's yeah, it might not that might not trigger a trap. If the kernel wants or the library needs to do it, then that's up to that. That's
there's some
yeah.
hardware dependence on this. Uh,
They don't specify what this kernel library does. So yeah, I would imagine if it does need to make a protected call, then it would trap. But if that kernel library doesn't, then I don't think it needs to trap.
The right above the in the test one questions, right above the client A, client B, client C, that thing it says the clients use services provided by the kernel lib, libraries for network access, memory management, and CPU scheduling. So there's a little bit of what the kernel lib is doing in there.
let's highlight that.
Yeah.
Okay, so I think CPU scheduling may require trap. Memory management. Okay.
Yeah, because if that's the case, then I don't really see the benefit of even putting the kernel library in the same address space.
Maybe address space this makes sense because it's just that lecture section about reducing the cost of the explicit cost of TLB being invalidated.
There's a little bit about this like shared kernel library structure in the other L3 paper, like the address
The
space.
the Pentium one or the
Yeah, the Pentium one. I think on
uh
like page 9-ish, 9 to 10.
okay, this was rationale. I did not read through most of these. This is page 12, 11, 10.
Or 9, page 9 or yeah.
Parts of the kernel area shared between has yeah this the kernel area contains the kernel code and physical memory needed for page tables. Parts of the kernel area are shared between all address spaces. Address space thus has no effect on these parts. Yeah. So this is reducing the effect of the address space switch. Uh, should I put this down here? Kernel, page 9. These are like really old and badly formatted papers. This is improved address space switching. Page 8. However, interrupts handles IPC. Interrupt also causes address space switch through IPC path. Uh, Let me see if there's anything on. Is a system call? Wait, system call. So IPC system call destination test. So what I'm thinking is, because kernel library is shared, we don't have to switch address space um, when we do the system call. Based on we have this if statement here, if destination task is not source task, then current space and flush TLB. So are we reducing a TLB flush on part B because we've co-located the kernel library together? Hard interrupts handles IPC. Interrupt usually causes address space switch. First thing, trying to check where the same register is loaded in flat space. Come back to it since it's only 2 points. I don't want to spend too much time on 2 points. Memory isolation. Very Right. I think E is good. D, we have to find some evidence on. Um, your friend is curious how design gives memory isolation. Yes, C and D, I think, have some open questions. Uh, some notes. I think Omar has some questions on, or some comments on this TLP flushing. Seems like this TLP will never be flushed since it's edge space ID'd.
Right. I agree with the TLB explicit cost makes sense because the process is in there. It seems like you could sum up a lot of this, just the kernels in the address, basically.
Mhm.
Uh, yeah,
Yeah.
we're going to need to have whatever the basic answer of this is in our heads when we take this thing. So for explicit cost, it's switching address spaces, right? And the
Hmm.
implicit cost is the cache is warm because of the TLB lookups don't require flushing. I don't know.
Yeah.
Are those kind of the two basic points, or am I missing?
I feel like this maps very closely to the lectures 8 to 12. So edge space switches of tag TLB. Since it is tagged, you're not removing that, or not invalidating that entry and overwriting it, since the tagger is the
Right,
same.
right.
And then large protection domains, this was something about the cache effects of not flushing or not removing things from cache.
I remember, yeah, this is a pattern that we saw in the other the example exams, from previous
Hmm.
semesters too, with the L3 um the questions about L3 it was like it felt like it was repeating a lot. Okay, it's in the same address space, so you don't have to flush the TLB, you don't have to like the caches will stay warm, don't have to reload the cache, but you do have to change segment registers or something, and it was just that answer over and over again.
Yeah. There's a context switch. How do you facilitate context switch? These these questions seem a lot larger than past year's questions.
I was thinking that too. I was like, this isn't fair.
Yeah, yeah, I agree.
Is OS structure exokernel spin L3 and then this year of exokernel spin L3 and then combining how would you do it in all three? This one has 15 points. I've never seen that before in the previous ones. This is even larger than, oh my God. Right. Tactile have zero cost for Azure Space switches. I think that's one we mentioned since we're tagging out the hardware space. Uh, Tactile available explore hardware feature is a large, maybe detrimental performance. Monolith kernels, building OS. Seems like past few years had this easy, there's a context switch. How do you facilitate? And the answer was just this simple load and flush the register thing. Um, but it seems like this year they asked it very differently. How would you map it? What's your justification? Uh, this is, I think this is probably closest to the context switch thing. No. Uh, yeah, this is probably the loading lower and upper bound registers would do a switch, and then anything outside. Clients are in their own respective hardware address spaces, the VIP cache. Yeah, I thought that was more of a performance optimization. Uh, and then from the paper, it was.
Is the kernel library running in user space and then it just traps to the kernel whenever it has to access hardware resources?
Yeah. Um, where's Pentium? There was no, this is on the optimization paper, not this paper. It was improve address space switches, IPC path. Right. Says address spaces can be handled differently. So anything outside of the segment register value would trigger a fault or something, right? Is it page 7? Paper, page 7. That'd be like a segment register reload versus page switch microkernel. That's just the same page. So reloading. Probably reloading. I think this improved address space switching on Pentium processors transparently multiplace. Uh, so I feel like I don't want to spend too much time on this, but on this part C, But I think the one thing here was that the segment registers define so the boundaries of the production domain, anything outside be a fault. I feel like that is a sufficient enough answer for a 2 point question. Uh, yeah, like the previous ones only asked for process. Now they're asking for justification, and then that's so much more complex. Uh, right. C is done. I think B is system call. Is there a system call question? Nope. Right. I don't want to keep progressing. It's been 30 minutes on this question. I think the next one is super dense because it had to cover all three. If you guys want to start looking at that one, uh, sure it has a packet multiplexer. Kernel library and client. Right. Are we good on this question? Should we start moving on to this really dense one that combines all three topics? The spin one was discussed in the lecture. Is that where this is from? For the packet filter.
I think extension is the basic answer, right? We're not going to be writing a page on each one of those, I hope. And I
Yeah.
think the exokernel answer in the green there is the user space. That sounds right to me,
Yeah.
as it's just exposing the resources. Microkernel is the one my brain gets stuck on, but I haven't paged down that far.
Yeah.
For exokernel, like in the exokernel paper, they reference packets filter specifically as things for the downloading code into the kernel.
Oh, my
Uh,
bad.
do you think that like I think both would be possible, right? You know, have your extension uh do the packet filtering, you know, expose the hardware resource to that, or download into the kernel. But I think with the speed as a requirement of the question, I open to be wrong here, but I think downloading the code into the core kernel would be
Yeah.
like what they're guiding us towards.
I rescind my answer. That's a better answer. Thank you.
That's directly from the paper. Let me cite that. It's download it and then allow it to be run quickly on each access time instead of crossing between into user, right? Is that what that would be? Page 3.2, page 4. Page 4. Um, so another example is packet filter, which allows predicates to be downloaded into a kernel at bind time, then run at every incoming packet to determine which application the packets were at access time. So bind the packet filter directly into the exo kernel um, to prevent. So the download into the kernel is just binding it before you start running anything, right? It's like registered as the thing to use. Yeah.
Oh, and it is specifically putting the code into the kernel,
Yeah.
so that like when you know when a packet comes in, you don't have to do any
Any user crossing your
yeah.
yeah. Directly to kernel. Spin okay, spin is
Spin, there's a specific segment, like a section. I'm
on the
wrangling
lecture
windows right now.
the spin approach.
5.3 in the paper as well.
5 and 3 and section 10. Section lecture 10. I'm gonna say lecture 10. Lecture 10. Spin supports events using event-based communication model. Services can register um, event handlers to the spin dispatcher. Uh, let's illustrate network report mapping. So you can map many events to the same handler. So we will want to register. I think lecture 10 on the spin section or module 10 on the spin section of lecture 2. Module 10, the spin section of lecture 2 discusses this in detail. So services, so in spin we just register an event dispatcher. So when the event or when the event comes, spin will call the handler, which will be your packet filter. Um, exokernel would be downloading them into the kernel, like binding it into the kernel. So we prevent that from executing user space. It's simply run in the kernel quickly and then multiplexing that packet. And then microkernel. This is like this super detailed TLB optimization question, which I feel like is not it.
For microkernel, did you say?
Yeah, microkernel. Looks like this was like a discussion on TLB and cache locality instead of implementing
Well,
packet.
that's all I could come up with either is
Yeah.
just make it small and have your TLB tag your address space ranges. But I mean, I've already proven myself an unreliable resource here. So what does anybody else have to say about it?
No, no, I think you're right there. Like it's make it a small extension, and then
Mhm.
also uh, pack it into the same address space that it's going to be, you know, working with the most, so that like you were saying, avoid flushing the TLB, keep the caches warm. It's just like pretty much the same thing we've been saying about
So
L3.
basically added as a kernel package into every user process. Is that what the for microkernel?
That
Kind of
sounds right to me. Yeah.
so kind of like what we were doing with this kernel lib section of the memory. We just map it, do a mapping of it once we write the handler into every address space or something. I'm already starting to blank as well in this microkernel. I'll write a small extension to perform multiplexing and then map into address space of every process.
I'm not sure about the map into address space part. I think it should be a separate user process. That's what
The-
microkernel said that.
yeah, there's a section on IPC in this, I believe. Let me look it up because I feel like
Yeah,
that
it
would
says
be.
that IPCs, like by construction, are not that slow. So even a user process is as fast as monolithic. That's what the L3 paper was about. So I guess it's
Yeah.
just build a user level process or server
Mm.
for handling the packets, and that should be fast enough. Like if we exploit the underlying hardware well. I think that's the idea of microkernel. So it has to be something along that lines, or maybe it's something completely different.
Shouldn't it only be a different process if the packet filter, I guess, code can't fit in the hardware address space? But otherwise, you would try to like package it into the same address
I
space.
I feel like this is the packet filter is like something that's going to ping or deliver events to multiple processes kind of asynchronously. It's not like a synchronous. You call it and you get a response. It's like we have to find a way to create the packet filter as something that would do IPC and wake other processes instead of being woken by those ones, right? Or
Yeah, I think you're onto something there. And like the PE data structure, right? In the
Mhm.
uh for each guest OS has entry points for what should happen when has program discontinuities like a packet coming
Yeah.
in. I think that you're onto something there.
IPC enforces our agreement, sender decides information to its contents, receiver determines. So the care of address space is the foundation of it. This guy talks like he's like having some revelation about independence and philosophy. The forms of communication are right, message transfer based IPC, supervised IPC. Memory mapped IO. Should we consider microkernel to be like a we're doing memory mapped IO to uh I feel like, yeah, memory mapped I so like the way like IO rings worked or something, yeah, like memory mapped like return space or something like that. Uh Controlling IO arrays and device drivers is also done by memory managers and pagers on top of microkernel. The ground operation is required in special situations. So what I'm thinking is kind of like what shared memory would be like. So the packet filter process would perform mapping, Lexer, shared memory mapping, mapping into um into every application application registered to receive packets as a send return space. This would, yeah, I feel like map here is something that would be used for IO. And then this would say shared. This would facilitate message passing IPC. IPC if I send a message. This is page 2. So packet multiplexer for shared memory mapping into application to receive packets as a send return space is to facilitate IPC. A thread is actually executing inside an address space. Must use for classical messages transferring message between threads. IPC always enforces a certain agreement between both parties. The sender decides to send information. Note that the grant and map operations need IPC since they require an agreement between the sender and recipient of the mapping. Page that 1, 2, 3.
So the mapping is between the uh, packet server and the applications.
Mapping is between there's a mention of packet server somewhere here. Let me look it up.
So basically, a packet server will have a lot of mappings with all the application messages.
Yeah, so that would facilitate just fast message delivery into the shared region instead of as independent. Get the server thread that has mapping into recipients. The memory mapping file. So this section seems to indicate that microkernels have IPC, but only for to a degree only for granting map operations establishment. Uh, this is just like a very theoretical or philosophical discussion of what IPC means. Like I don't know what the implementation was. Memory manager, server managing digital address spaces, class one main memory manager. Memory managers can be stacked. Pagers. Oh wait, pagers may be integrated. What is the standard IPC mechanism? He like mentions it, but I don't know the implementation of microkernel IPC mechanism.
I think IPC is only used when you have to go across address spaces, right? I guess like if in the same address space you don't you don't need IPC.
Yeah.
There is a little bit about like small working sets for device drivers in the like 4.1.2
One
address space switches section.
4 yeah, kernel user switches and then Azure space switches.
Yeah, if you search for like I guess device driver, it talks a little bit about like if a device driver has like a small working set, you can like map into
Device drivers. Yeah, I feel like a device driver would have a small multi-working set than a total application. Should have 232 global space. Say 1 MB or less for a device driver. We can multiplex one 3 GB user address space of 8.
I guess in the paper, can you go to the pager part again?
The trick is
Where
to share the smaller spaces with all large 3 GB spaces. Then any address space switch to medium or small space is always fast. So I think what I'm kind of discussing on the memory mapping so far on this one is kind of doing sharing address space of a um small device driver to all um process to prevent address space switch. Um, so where was the this would be page 6. Right, and then the pager part. Synthesis spin. Is pager the memory pager? I'm thinking that's probably not
I
the
think it's the on the page fault handler thing.
a pager may integrate memory manager or memory server. Pagers used to grant map and flush primitives. Device driver, wait, and pager device driver are completely based on IBC and are user level defined. Stack pagers, multiple layers of pagers can be combined for access control. User supply paging strategies. This seems like it's more of a memory manager discussion than if I look up device driver. Okay, they are linked somehow, pagers and device drivers. I feel like device driver is probably a closer word for it. But, alright, device driver.
So I think in everything, if you see a trend, the device driver says that compared to other user level processes, there is nothing special about a device driver. So everything is a user level process, and
Yeah,
I feel
but
that's what we have to do basically. So like keep it
yeah,
user level, and the packet filter should just use IPC to send the packets to the respective applications. I think it's just that.
yeah. So one thing we are doing is since the device driver is small, we're mapping it into every address space to reduce, just to improve the address space switching part. But the device driver itself, when it has to deliver messages, is through IPC or is it through
Okay.
through the standard IPC mechanism? I feel like that is actually a good quote to this page 4.
Yeah, that's also supported by like in the pager section, it says like the remaining interfaces, and then device driver are completely based on IPC and are user level defined.
Yeah, is a user level independent application, independent process. It has memory mapping into recipients, so sharing address space with a small device driver into all processes for an address space switch. That's probably the most I can go before designing the actual user space thing itself. Actually, we're not talking about how the logic would work, right? The IPC part, just implement it. You want this fast since it sits on the critical path, examining every packet. So it examines every packet. Uh, so like half of, or most of this paper is just talking about reducing address space switches with its design, not, wait, ooh, on IPCs limited, which this communication hardware is addressed by device drivers. The microkernel is not, so, ooh, okay, this is a good one. Remote communication. Remote IPC is implemented by communication servers, which translate local messages to external communication protocols, and vice versa. So if special sharing of communication buffers and user address space is required, the communication server will also act as a special pager for the client. The microkernel is not involved. I feel like that's the answer, since that's tied into this whole device driver mapping itself into the address space. And then once it is mapped, and needs special sharing communication, it will be the pager itself instead of going through microkernel 5. Design as a independent process as my mapping recipients. The multiplexer will act as a pager of the recipient without kernel involvement. Okay, that also ties back to that exokernel question B, where we were thinking about um, how we'll make a system call in the kernel library. The thing is, as most of these are device drivers, network access. No, no, these are not. All right, I'll keep progressing on this combined questions. Device driver, device driver. That's probably the most I can say about device drivers here. After you implement the code for the multiplexer, you realize that you introduced two undesirable bugs. The first bug results in outbound memory access that can be potentially very dangerous. Explain how this is dealt with in spin, exokernel, microkernel. Modular 3 prevents out of bounds accesses.
Basically, it's the compile at the compile time it will prevent because of the type safety in the language itself.
That's related to the process, not the memory management, right? Protection domain, spin domain. Uh, yeah, this is like a protection domain, like memory region question, not necessarily a compilation of the code question, right? Lesson 2B, logical protection domain. Actually, no, that is no memory leaks. Modular 3 supports a data abstraction of an object. Only the entry points of the object. Yeah, that sounds right.
So it says that, and there is no cheating possible as you can do with a language like C. So basically, it's
Yeah.
like a strongly typed language. So in a way, it helps with out of bound errors.
Objects, inputs, specific services. Modular 3 exposes externally visible objects inside an ob oh, sorry. What you can do from outside the object is the entry point methods, no more.
There's a bit of this in the spin paper on page 4, relevant properties of module 3, where it talks about like type safety prevents code from accessing memory arbitrarily.
It
Page.
says compiler enforces interface boundaries between processes.
All right, all right, here it is. Compiler forces this restriction compile time. Type safety prevents code from accessing memory arbitrarily. This is enforced through both compile time and runtime checks, which is this bounds violation, right?
Yeah.
All right, so bounds violation would, yeah, runtime. So both at compile time, it would do restriction based on the interface. And then runtime, it would do the type safety. And then at runtime, it would do this runtime checks. So all the compiler forces when we only refer to objects. Bounds violation. Check for out of bounds. Violation.
Yeah, and I think yeah, like with the out of bounds violations, like outside of referring to hardware resources by the inappropriate type, there's also just the standard go too far in your loop and you go outside of the memory of accessible to you, that kind of thing. And I
Yeah.
think what would happen there is that like this individual spin module would fail, but
Array index.
it wouldn't take down the whole system.
Check. Okay.
I think that could be the answer for the second part.
For the
Where
exokernel?
there's an infinite loop.
Yeah.
So if the extension fails, only the applications using that extension will be affected. That's what I think someone said right now.
Exokernel. Um,
Yeah, I think this was from the paper itself.
okay.
That
Inspection at compile time for checking address.
sandboxing and compile time.
Let's expand on sandboxing a bit because I feel like that's not sufficient enough for this answer.
Okay.
Exokernel. Let me look up sandbox. Oh, wait, this is for Ash is an untrusted application level mishandler that's downloaded to the kernel, made safe by code inspection and sandboxing. What is sandboxing? That's the only reference to sandboxing in this paper.
I think you have to read the reference 52 for that.
Reference. Oh my God. Okay, what's sandboxing? Efficient software base. Okay.
No, I think that should be enough because it's just like 1 point.
Let me just understand ACM is open access. Thank you, ACM. Box. Oh, sandbox. Recording language of translation size to render object code enable escape its own code. Concentrate a simple translation technique called sandboxing that slightly increases of the modified object code. 4% overhead. That's quite a bit. Address sandboxing area, section 3.2. Is that just segment and guard? Wait. Introduce runtime overhead server. Wait, this is what microkernel does, right? Just have the segment register set, and then if the comparison is not equal, then trap. But you set upper bits of target address to the correct segment identifier. We call this sandboxing. I just symbolize requires instruction of two arithmetic instructions. Uh, I feel like this is exactly what microkernel does, right? It's just set the segment registers of the valid access, and then anything outside is an out of bounds memory, right? That's what sandboxing is. Microkernel EK does use memory sandboxing. That's Google AI thing. Yes, it uses memory sandboxing and cites freaking MIT, ResearchGate, runtime recruitment. This leak KL3, full kernel. Yes. I feel like yeah, memory sandboxing for both exokernel and microkernel. So microkernel sets segment registers. Any access outside of this segment register would generate fault. If you Does that sound right for compared to this like previous one we were discussing about switching segment register for memory isolation? Like if we have an out of bounds thing, that would be a segment. It would be outside that segment register, right? For part B. And then I think Ariane was mentioning some part of part A, which was this infinite loop thing was also addressed in part C. So we do that runtime check of the array at index access. Uh,
Like what I was saying was that we cannot prevent an infinite loop because that is
that is a runtime
yeah, a
coercion, right?
runtime thing. But even if it fails, it won't affect the like other services running. That's what I was saying.
Hmm. This is through scheduling, failures limited extension. It will crash its own service, but does not affect any other service. Right, part B, part C. Second bug is much more serious. If you're at a certain edge condition, your player can multiplexer against an infinite loop. Construction. Yeah, since this is not like a kernel service, it is a like user space service, right? It's only isolated to when that user space is running and not running in a privileged like level or something. Uh, are we sure this was like a time scheduling thing or was it like a memory thing?
I
See
think
class.
that we have to, I think that would be one of the assumptions how you uh, like to answer it. If what we are saying is, I think the whatever server that is running should not be the only one scheduled because it's in an infinite loop. So how does the kernel maintain fairness if there's a loop? So it kind of looks like scheduling, but that would be the
Uh,
assumption that we're talking about fairness here.
Memory exclusion, visualization. This is the Spring 25 one. L3 microkernel. Group prioritization veins. Oh wow. So this was a network packet minimizing data loss. I think for Spring 25 they had a similar question. Place packet directly into OS pin receive buffer. Oh, so this is a detailed explanation on how the exokernel would work, right? One-time authentication. Okay, this is for part A. We could refer to Spring 2025. It would use secure bindings. Xcos Harbor, libOS, installs Facet. I think, yeah, this is all we had to answer for ours, but then this one had like a full detailed description of how it was invoked. Spin border crossings. Save file event, L3 microkernel. I look at infinite.
I feel like this has to do with like CPU scheduling. Like I guess in terms of the exokernel, I remember there being like some lectures on the like the time vector. Um
Yeah.
and that it would like if one library OS is misbehaving, it's going to like penalize it the next time it gets rescheduled.
This might be a TA question just to clarify if it's a time-based answer. That might be too direct to them. They might like shoot it down as we're not allowed to give answers. But I do agree. I think since you can't really beat the bug since it's running, you can only deprioritize it to prevent it from monopolizing the system CPU time.
Yeah.
Um,
I think there was a global scheduler. I think it was Spin that ensures that each service gets a time slice, and what the service does is up to the service. So I think that looks like a good answer for Spin.
yeah, spin. Where was there was I remember there was a paper, I don't recall if it was one of these three, where like if it's over like 50 microseconds, they could re forcibly revoke. Was that exokernel? Like you could do a forcible revocation?
Yep.
Yeah,
Um,
exokernel can like take up the
yeah.
any service, like any hardware that it exposes.
This was spin. Yeah, it was. I think yeah, exokernel. We have an exact quote I remember on how to do the like a force break of the service if it's taking too long. Where was it? Visible resource revocation, resource, yeah, simply killing library operating system associated with the application if it fails to respond quickly. Is exokernel simply breaks all secure bindings and reforms the OS. I feel like that's the answer for exokernel, is to break it if it's over the time bound. Um, and repossess it if it's running. Yeah. Right, abort protocol. Exokernel defines a second stage of revocation. Please return to the memory page within 50 microseconds. However, if these fail to respond quickly, they're broken by force. I think that's the exokernel answer for part B. Uh, is the abort protocol.
No, it's the one you're writing in the wrong
Oh,
place.
there's an
It's
oh, there's the
below.
out of bound memory
Yeah.
access. Part C is the all right, part C, I would say it's the abort protocol. The abort protocol will break and does it break the bindings to the scheduler if
I
it
think someone has already written an answer. Can you check page 7, the line above?
page 7, exokernel paper, page 7. Wait, page 7, applications pay for access time slice consumed. Uh, excess time counter. This is applications combined to machine resources and handle events second using visible revocation for each. This is discussing aegis, which I believe is an implementation of exokernel. I'll put both down. We could kind of refine and argue then but this is the abort protocol, which is the revocation. Secure bindings. This stuff in a sufficient time frame. This is page 6. I'm not sure which. I gotta read this code in detail. They might think it's not rendering properly on page 7. Well, I found this on page 8 instead of page 7, but this is relating to the scheduler, not the. Yeah, this is a time scheduler, right? Let me just finish up my thought in the wheel. Is recalcitrant defined by the abort protocol? Explain how this bug would be dealt with. I feel like the abort protocol, like personally, sounds closest to what it's describing is that if it fails to respond quickly, exokernel has a mechanism in its schedule to break it. Um, is there a similar abort protocol?
I feel like the time forfeiting description of the Aegis implementation kind of more closely follows what we learned in lectures. Because I don't know if um there was ever like a lecture on revoking CPU time. I think there was one for like the memory, but it seemed like for CPU time it was always just penalizing like a future time slice.
Yeah, this lecture 2, GitHub. Yeah. Okay, the Discord. We had. I don't remember the abort protocol being discussed somewhere. Or no, it was in the paper, but not in the lecture. Which one do we prioritize?
Would it hurt to just mention both on the exam? I feel like it
Yeah, probably.
there's wrong.
They always do like a +1 if X is mentioned. They never do like a -1 if like you give a long lecture of multiple potential options. Uh, out of bounds accesses and sandboxing, real kernel. Right, and then so whose answer was this? This was IPC message, size fade on bounds. All right, and then saying was much more serious. Yeah, these both seem sufficient. Either you penalize this time slice if it's running too long, or you can break it if it is a registered resource handler. Um, but it seems like everyone was on the same track that this would be a scheduler resolution, not a like a mechanism to break things. Exokernel seems to be the only one that's explicitly mentioned this revocation and return process. Microkernel, yeah.
That sounds iffy. Roughly same as others, man. I'd rather look at the papers.
Yeah, agree. I want to say that, but
Everyone's on the same track, just like deschedule it if it's not running in time. Or
I think when you talk about the abort protocol, it says the secure bindings need to be broken. I don't think there is a binding between the CPU time and a process. So
this
this would,
is yeah, exokernels regarding the like response time of a process in that quote, if I remember correctly.
I think
It,
I think this bindings are built between like the hardware it exposes, but CPU doesn't look like something you need a binding to. I think that's the basic thing. So there's no binding built between a CPU and a process. And I feel the above answer, penalizing for excess time slices, sounds like more appropriate in case of an infinite loop.
abort was in regards to revocation, which revocation would be deallocation. Yeah. All right. Now I'm starting to think if it's a CPU time issue, abort. So if it's like hogging and not relinquishing control to memory, then there'll be abort and then breaking the binding. But if it's a CPU time thing, yeah, it would be okay. So abort was in regards to someone not relinquishing control of a memory in time. You would simply shut down the process and inform the it that it no longer has access uh, to because it didn't respond to a revocation request in time. That's what I'm feeling this is saying. So that would not be a CPU time issue, and then the rest of them is right now. I'm also on the same track. I think it is time slices and preempting or penalizing if it's running an infinite loop. Um,
It could be kind of both because I guess like if it's in an infinite loop, like the kernel has to stop like the process from running at some point.
yeah, so I feel like it'll deschedule, but then if it is like if it received a packet but it's holding on to that memory, eventually it's going to hit some point where that memory is going to be reclaimed because no one's been using it, and then it will hit the abort protocol. But like the macro level of this looping time is the is going to be captured by some scheduler issue. Um, okay, as secure bindings, applications can securely bind to machine resources to handle the events. So this, I mean, like packet multiplexer is bound to the network, the NIC like device, right? So if it's hogging that connection, then it would both exceed excess time and forfeit, and then eventually hit that revocation.
I feel the exokernel does not care what we do with the time that we are provided.
Hmm.
So it only has to maintain that all the services get a time slice. So
Yeah.
even if I'm hogging up the network, I can only do it while I'm running, I guess.
Hmm. And that's not like a system-wide thing running on that, network. It's just a application dependent process, right? So we can identify the application that is bugged.
Yeah.
Okay. Um, just look up how does microkernel handle infinite looping error? Process isolation or preemption. That's why everyone on this Google is saying just isolate it, preemptive schedule, resource limit. Is there a resource limiting in the other two? I think source limit.
I can find is the word isolation in the paper for both server and user program malfunction, but it would still impact performance.
All right, so because server processes, which the packet filter would be considered, so this is like the IPC server is considered a user program. The fault would be
Yeah,
this.
that's
Okay,
the exact line I was looking at.
okay.
Yes, sir.
Right.
And
So
and I've searched. I don't know if you can search for words on that paper. I have failed, but this is like the best I could come up with too, because so much of this paper is focused on other things.
yeah, one is when it is isolated to only its program. Best I can say there. Um, yeah. I also have an issue searching on the PDF. So this is a looked up ACM version of this paper, which seems to be better at searching. Um, let me look up isolation. All right. That seems to be it then. So mostly CPU time scheduling, descheduling, and then spin. It's a spin paper. It is a registered handler. So they're all, since they're executing not in like kernel space, we can say it's just go get descheduled, I guess, on every platform. A function isolation. Right. Oh, this is for memory address. Actually, this would tie to part B. Software fault isolation relies on a binary rewriting tool that, oh no, this is a survey of other processes. Uh,
So does this call end in 30 minutes?
uh, yeah, unless you guys want to go longer, which we could.
Oh, we can go longer. Okay.
I mean, I put 3 hours just to be fair, since the last night was also 3 hours and we ended right on time.
Okay.
But again, like we kind of rushed through this for our first initial pass. If we're kind of going through and detailing it, I think it does make sense because this was the least confident section, the OS structures. The virtualization and the other ones, I think we had pretty good answers last night.
Cool.
Which I think everyone's been going through. Um, right. Spencer can support a larger number of clients. Efficient software-based fault isolation. This is in spin, right?
Another thing that I feel we are talking in context of the for exokernel, it's downloaded into the kernel itself, right?
Mm-hmm.
So the abort protocol says that it takes away from library operating system. So it might
Mm.
not abort it from the kernel itself, right? Now the packet filter is inside the kernel. So that it again comes back to CPU scheduling. But
Yeah.
since it's a part of a kernel,
I think it doesn't hurt to mention it on the answer, but it's just I would rather focus on this as the primary than because I feel like we can just overload it with a bunch of
Yeah.
potentials. In any
But if
just,
something is installed in the kernel, are we still time slicing that thing?
a kernel's just executing at a higher privilege, right? Is it not?
So it's like
Uh,
a time slice for the kernel, then for the library OS, like that. Because the
Access.
infinite loop is now in the kernel itself, right? In a way.
Look at section 3.2.1. I see the second is more subtle. The execution time of downloaded code can be readily bounded.
Yeah.
I think
Okay.
f further
Ooh.
down, yeah, I don't
Till
go on it,
default
yeah.
access time per to be downloaded by time. We use three mechanism. I don't know why it keeps de-rendering like this. That's really weird. Secure binding such as, let me exit this. So kernel, here it is. The code is invoked when downloading code. It can be voided. Uh, wait, on 3.2, then 3.2.1, downloading code can be bound. Let me look up bound. Wait, fault isolation is ensured by careful language design to bound runtime and runtime checks present. Can okay, software support for demultiplexing can be provided by packet filters. Implications of secure binding. Uh, chronologically to application while protocol checks determine whose couch. Whenever uses pro pack filters because the current network doesn't fight hard. Is use compiles at runtime, increasing built like the yada yada. On the system that assumes no malicious process, our language is simple enough to she here. Yeah, something more subtle. The execution time of download code can be readily bounded. The point is that tame code is executed when the application is not scheduled. Uh,
Yeah, the paper says the packet filter runtime is bounded.
yeah, okay. So that
Yeah.
I'm gonna just mention exokernel can bound installed.
Yeah.
So exokernel section 3.2. So exokernel can bound the runtime of an installed process. Uh, I'm gonna strike through this for now. So seconds per shuttle, the execution time of downloaded code can be readily bounded. So I think exokernel knows that you're installing custom code into the kernel, and in that case, it would put its own protection on that installed
Yeah.
code if it in the case it is malicious, which is that time bound. So it has a mechanism in place that's not a scheduler but a bounder.
Yeah. I think this looks like
Okay,
the most appropriate answer to me.
3.2.1, yeah. All right, thanks, Nicholas, whoever brought up this quote. First is obvious, elimination of kernel crossing. Second is subtle, really bounded. It's yeah, so downloaded code is running outside of the context of an application.
Yeah.
And then if it is taking too long to run, then it would be bound hit the bound. Uh,
Yeah, the loop will not be fixed, but at least other services will get their fair share of time on the CPU, I guess.
mhm.
So the infinite loop is up to the person who wrote the downloaded code to fix.
Mhm. Packet filter. Right, so fault isolation is ensured by careful language design to bound runtime and runtime checks for memory references. Alright, so I think that also ties into part B. Exokernel has, alright, that was already mentioned, is code inspection and runtime checks. While knowledge is limited to application packet ownership. Update the answer for part A. Exokernel. So packet filter runs outside the context of an application. Because of that, it could be a downloaded. This is for someone deleted the control enter on here. Is a separate page. All right. So download a code in order of execution and execute outside of the context of an application. Is that good enough for this? I feel like part A, B, and C is satisfied on this 15 point. Wait, are we missing something on exokernel? Spin L3? Uh, Spring 26. Wait, 9 points. Is it 3 points? 6 points? Six. This something doesn't add up here. One is 9 points. Part A is 3 points. Part B is 6 points. Part C is 6 points. So this should say 15, but it says 9. And if we bring it to the TA, I hope they correct it and take some points off the test. So it's like 6 points less or something. Uh, Unless it's like an easy win, then let's actually bring this up on the TA thread. Verification thread. True solution log. Or all right, this is an issue on the summation of the points here.
I think they'll just bump up the 9 to a 15 because
This
A,
15
B,
point
C are 3, 6, 6. That is 15.
to question one is 9 points. The components worth 366 points, which total to 15. Says so. Is question one worth 15 points, or is part B and C supposed to be 3 points each? Um, I feel confident, more confident in this answer than last night now, since we've kind of just gone through and cited some stuff on how we design. I think we did change a little bit
Yeah,
about
only thing I'm not sure about is the microkernel. What did we decide on microkernel?
for part C.
For part C, memory, ne- the time slice and memory both.
Time size. Part C, it was. I was just thinking on the segment register. If that outbound memory access is outside the segment register, it would be
Okay,
a fault. That
okay.
seems correct.
Yeah, and now that I've sort of been running it through my head a bit more, it's saying like microkernel but it doesn't specifically say L3, right?
Hmm.
So just given the definition of a general microkernel, right? Like these services are running in their own address spaces. Uh, I wouldn't go so far as to, what it says in the paper and say it would be like the others, but something more like a memory fault would, cause a failure in
Hmm.
this
Specific application or something.
exactly.
Right.
Yeah. And then however the microkernel is scheduling among these different applications, burn up your time slices as you would like,
Mhm. And yeah, replacing with others. So yeah, malfunction is isolated to the user program, and then if user program is stalling, I guess they could have mechanisms to break it. So download code has a time bound on exokernel. Spin is a global scheduler thing. Yeah, spin is also like this is which one is the spin? This is the spin paper. Um, fault balance violation. Uh, the extension model. There may be any number of handlers installed on a particular event. The default implementation model may constrain a handler to execute synchronously or asynchronously in bounded time. So spin also has a time bound for a handler. A handler may be bounded by a time quantum so that it is aborted if it executes too long. So this is for spin. There's also a time bound. It's not a so spin also has a time bound mechanism, it seems, on um spin paper page 6. Okay, does that do you guys also see this on I think section 3.2? Section 3.2. Yeah, so spin has a bounded time for a handler that is installed in an event. So it's bounded by a time quantum, so if it is abortive executes for too long. So that sounds similar to what kernel is doing. The downloaded time can be readily bounded. Um, so a handler in spin can be bounded by a time quantum for a synchronous handler. So I'm guessing is also not the scheduler thing. It is a handler time bound now. If you look on page 6, top right.
Yeah.
So spin as a time bound, exokernel as a time bound, microkernel. What would that be? Microkernel is just a user space program, so that would be probably the scheduler. Um, or we could have it be asynchronous. Um, so it can either be bounded if it's synchronous. So if it's synchronous, the handler is bounded, or run the handler asynchronously to prevent it from hogging the other ones. The handler may be asynchronous, isolating it from the handle latency. I feel like you probably have to mention both. Um, so it could be either synchronous, of which then we time bound it to prevent latency, or it's asynchronous, where if you have an infinite loop, it's spun off into its own thread, not handling it in the same thread as the razor. That way, the razor doesn't have latency on the response, or something else can pick up and handle it. And that's probably the answer for spin. From my perspective, does anyone have any disagreements on that? So spin is synchronous time bounds or asynchronous handlers to isolate the latency of a infinite loop. Exokernel is downloaded code and then bounding runtime of an installed downloaded code. And then microkernel is using the same mechanisms as a user program malfunction to isolate the error to only the program. That seems more more confident. I'm not sure if anyone has any additional points or if something sounds incorrect. I'm now going to remove this abort protocol part. Um, is anything else on here? Is there anything else we want to add to this 15-point section, or are we okay to move on to the lecture 3 questions?
I think I'm good with these answers.
Yeah, let's move on.
Okay. Virtualization. Yeah, so this one, I think last night it was because guest OS have hypercalls, they can do it direct access to hardware to create new page tables for new processes. Um, and then they could also batch them as one fewer hypercalls. Whereas on the fully virtualized, every new creation will be a trap and emulate, but there is a caching mechanism on subsequent calls where the TLB would have that direct translation instead of the trap and emulate, but it's only on that trap and emulate that there is additional latency or new process creation that there's latency because of the trap and emulate. Um,
Yeah, and I think guest OSs can also maintain their own hardware page tables.
yeah, that was the
The
section
first point. Yeah.
2.1.1.
Yeah.
Because of that, they have direct memory access versus this indirection through the trap and
Yeah.
emulate. And they want succinct bullet points, so I feel like that's enough detail. Part B, I think the person here was not confident. I don't know if there's any other. No, they're not basing a performance difference. Uh, for fully virtualized memory footprint interactive. I think once it is installed, the memory footprint part, um, yeah, TLE is not updated frequently. Right, someone had an argument on here which it would not be significant. Which I would tend to agree because once you stop hitting that new process creation part, the cache in the direct access will be roughly similar for memory access. And then you're not spawning new processes, so you're not creating new page tables, shadow page tables. Um,
Yeah, I remember that from one of the Hangouts, that like one of the improvements that you can do for performance on fully virtualized systems is that these page table accesses don't have to go through the hypervisor. So yeah, in that case, yeah, I'd agree with that argument.
So consensus with over all the details is that they're equivalent.
roughly equivalent.
Yeah. Okay.
And and they don't mention anything about CPU or anything, so I don't want to bring that up. So just focus on the memory performance.
Yeah.
I guess
Only
we are
only
not
thing I brought up
focusing
is they
on.
don't tell us about IO, so we don't even know if there's any
Yeah, we
optimization
had we had
possible.
some debate about what they mean about memory
Yeah.
footprint interactive. Does interactive mean IO interactive, or does it mean using memory
Uh,
often? Um,
I yeah,
I
I don't
feel that
know.
it's more about IO. That's what I feel. That's why I think you put that in the TA
and he,
discussion.
he has not responded, but he did have a newer response, so I feel like he saw it and ignored it. Um,
They said that they'll have a new thread with all the answers if they feel appropriate to answer it.
yeah, everything is free response essays, even multiple choice. What the hell? All right, so. Also, he's just going through immediately. Pursuing hidden. All right. So that makes sense. The caching and then the direct hardware access will roughly equalize over time. It's just that initialization if you're spinning up many new processes that you don't hit the cache part yet, and then direct hardware access is faster for part A. Um, and then there's no mention of anything CPU related on this. Um, for part B. But I think the thing is that small memory footprint interactive, does that mean reading and writing often to the memory page, the hardware physical page? Or does that mean talking to IO in between running the process?
I
Um,
just think we say if IO is involved,
If IO's about, yeah.
Zen is faster, and that's how we get out of that.
Yeah. Uh,
Yeah, because in case of IO, it's trap and emulate versus like hypercalls, it can be batched. Like the
that's very
guest
fair.
OS can request the
Mhm.
hypervisor to uh,
So having direct,
give the
yeah,
notifications later. That's what I remember.
present in paravert. Yeah. Just qualify. I'm confused about what that means when you actually answer it. But if this is related to memory accesses, then it'll be roughly equal. If this is related to IO accesses, then it will be significantly faster on uh paravirtualized. The- Since they are cached on the TLB. Virtually virtualized, so the performance of memory access is in paravirtualized. All right, this is yeah 4 points. I don't want to focus on that. Paravirtualization. This was imagining an OS that sits on top of Zen. And then suppose a multi-threaded app issues 10 independent blocking I/O. The prime metric is to optimize the number of context switches. So I think we said just batch them all to be delivered to one VM at one time. Um, and then so that's just one big batch sent, and then when the request comes in, is one big batch to receive. I was originally thinking about reorder barriers, so I was thinking like if you send out multiple requests from one VM, they should come back in the same order. Otherwise, you might have other things inserted, and then you'll read a few, stop, go to the other VM, read that, come back, continue reading from the IO ring. But that's at a macro level, more like a VM to VM, not process to process. Um, it could be both, but I think batching is a little stronger of an argument. Um, for pair virtualization, question one. Uh, Zero context switches need to be notified. Yeah, I mean, I'm thinking batching and then deferring it until all of them are present in the response ring. That way you could just read that at once instead of polling for each response ring slot and then reading them one at a time. Um, that's stronger. And then yeah, reorder barriers, you had to do it when you were sending. This one assumes it was already sent and how to optimize the reception. So reorder barriers would not apply to received messages. Only if you're sending new ones to not reorder them. Uh, that was
Does
only 2 points.
anybody feel like this is a trick question at all?
Yeah. It's
Because it says multi-threaded application issues 10 independent blocking IO system calls.
mhm.
Does that mean it's 10 threads and you're going to context switch 10 times no matter what? I struggled with that one.
Is it one application, one th they're sharing memory, right? So once they send IO, they should receive it all as one, or
Yeah, how are they defining a context switch?
yeah. Let me open up the we are at almost 10, but I'll keep going. Virtualization context. Right. When you do a context switch, you switch to the page table as a hypercall available. Do a context switch from guest operating system from process one to process two. Page table you use from now on. The yeah, how are they? Right. These are the only mentions of context switch in number 10 efficient mapping. Right. This is shift burden to guest OS, maintain contiguous physical memory, map to discontinuous hardware pages. But this is for memory mapping, not IO response. Uh,
Is it the context switch between the hypervisor and the guest OS?
hypercall switch page table, update page table. Yeah,
Yeah, that's all memory management. This
that's
is
memory
just
management. Yeah.
the IO ring.
So it could target. Yeah, context switching is a memory thing, but then this IO ring is a device ish IO ring. Control and data transfer in action.
There
No
we go.
queues. All right. There's no copying of the package itself. Pointers have been embedded in the descriptor. Um, oh, so pointers are embedded in these descriptors. So when these were sent, they have a embedded pointer of memory where the IO response will be placed in. And then I guess that comes back to the context switching part. If you block that big response area in one contiguous IO um, pool of virtual memory or hardware memory, then you don't have to switch between them or uh, receiving packets from network and passing to appropriate domain works similar to as described. It exchanges the received packet for one from the guest operating system page that's already been provided as a holding place. So the network buffer is pre-allocated. That's like an assumption. We could directly pull the network package into the buffer that's owned by the guest OS and queue the descriptor for the particular guest. Wait, so Zen can directly put the network package into the buffer that's owned by the guest OS, then enqueue a descriptor for the particular guest OS. But then the domain or the process on the OS itself, what would it be? Uh, I feel like request reordering is involved in some way then, because it said competing domains are reordered. Is a VM a domain or is a process within the VM a domain? Um,
The VM is the domain.
And
uh,
and it's one VM, right? One VM, 10 calls. Is that correct?
yeah.
Right. So it feels like the batch concept makes sense
hmm
for the hypervisor doing its work and then returning when all the pointers are filled if the context switches between the hypervisor. But I don't know if that's practical. I just don't. This one's a tough one for me.
Ring optimization. So Zen is optimizing ring by default, so the return for one big domain is all grouped together, reordered in a batch. But then once you go into the domain, you still have to like demultiplex the incoming package to the correct process. Um, interrupt coalescing. Let me look up interrupt in the paper. I feel like there's going to be a mention of it somewhere. Uh, wait, RPC, Zen. Right, hardware interrupts are replaced with a lightweight event system. Event mechanism replaces hardware interrupts for callbacks are held off the discretion of the guest OS to avoid frequent wake up. Float alert dispatch interrupts at their high load. Right. Subsystem virtualization. context switching times. Wait, this is related to ownership access control and queue. Yeah, it's starting to feel more like a trap on this. But it's only 2 points, so it can be a super complex trap. Um, Look at the older exams on this. There may be something there. For virtualization. Yeah, I'm feeling also the guest can batch updates to coalesce interrupts. This is from Fall 2025. Guest can batch updates and mass enable the channel to coalesce interrupts or pull whenever it wants. So I feel like, yeah, batching the updates would roll it up into fewer interrupts rather than interrupt on every update.
So batch, so if the hypervisor already has the 10 requests, are we talking about the hypervisor batching the interrupt to the guest OS
yeah,
so it
the
only
upcall.
goes to the IO rings all at once because it's a single process?
Yeah, the upcall. So instead of being call on every response on the ring,
Right,
you batch them into one big interrupt from Fall
right.
2025.
Okay.
And that's 1.5. So that would only be one big interrupt for that thread instead of one for each request. Um, Zero copy semantics. There is a question on the IO ring on every test, I believe. So Spring 25 had, oh, they went deep on parallel systems that year. Memory management. Uh, Balloon size. Balloon would be so easy on this test. Why didn't they add it, man? Or batch jobs.
Gotta hope for the additional questions, right?
Yeah. Please give me balloon in mutexes or something. Oh, whoa. Um, so the memory text, program discontinuities. Right. I'm fine rolling with batching as one big interrupt, and then one big context switch instead of for that one.
Yeah, and
And
I think that like given that it's saying, I think we had talked earlier about like counting context switches. Are you counting context switches of the threads, within
Hmm.
your guest OS? Based on how the question is worded, like how many context switches will occur for Xeno Linux to be notified that all 10 requests are complete?
Hmm.
It's not saying how many context switches will occur for all the threads to be notified that all 10 requests are complete. So
Yeah,
that wording specifically is making me lean towards, it's one, it's all batched, and then it goes up to the operating system.
yeah. But so then this is not two context switches, one context switch for the reception. The trap to kernel for device IO is a request one, right? So just one context switch.
Oh, that's a good question.
So it's switched
Oh,
out after the
ooh.
reception, right? Oh, is it monkey?
Yeah, or yeah, sorry. Assuming the starting state for our measurement is that all 10 requests have already been placed in the IO ring. So that is telling me that we don't have to do the context switch from
for
the
the
operating system to the
response.
hypervisor.
There is one context switch from the hypervisor to the guest OS to receive responses when they are patched. All right, so I guess we have to restate the assume the starting state. We don't do the trap to kernel for device IO. We're trapping for response or context switch from kernel back to us for response.
Yeah, do people agree with my exegesis here that I'm like reading way too deeply into the wording of the questions?
For a context switch from the hypervisor to the guest OS to receive the response. There's one context switch from the hypervisor to the guest OS to receive responses when they are batched together. When multiple requests are batched together. I feel like that's sufficient for 2 points, unless they break it up into 0.5, 0.5, 0.5, 0.75, 0.75 as a very granular 2 point rubric. Um,
Yeah.
I don't want to spend too much time on a 2 point question, so it seems good. Uh, yeah, even channels, asynchronous up calls. That's probably not zero. That's probably one. Then for part two, this one I was thinking it would be just the fetch and increment, but I think this was like thinking about how many readers and writers on each pointer, in terms of why we need a mutex. So like the Zen is only the one writing the response, but there's multiple writers for the request. So the request pointer could be a simple fetch and increment, or it could be like you lock it and then you move it. Um, but the responses are read asynchronously. No, response consumer is read. Uh, the request producer and response producer pointers are shared by Zen. So I feel like yeah, these keep moving around. There's a request producer, the only writer. There are multiple writers. Multiple writers to the producer. Each producer can use a fetch and increment atomically acquire their pointer at a given time. Writers guess OS's response. So no mutex is needed. And then response producer. Only Zen is the writer for this pointer. So no mutex is needed. Only Zen is the writer for this. Alright, so request producer shared updated by guest.
So
So
doesn't each VM get its own IO ring? So I think there should be just one
Yeah.
producer,
Yeah.
right?
I
oh,
thought there was no mutual exclusion with these.
Yeah.
Yeah, I
okay.
remember that from the Hangout.
That's
Yeah,
a
the
that's a that's
Hangouts.
a way
Yeah.
simpler answer. It's just that it's
Yeah.
one per VM, so there's no
Well,
mutual since they're the only writer.
Yeah, because there's only one person writing.
Yeah, it's
There's
like
only one
single
thing
consumer,
writing. That's
single
the thing.
producer. I
Yes,
remember
these
this
are
from the
these are both
handout.
single. These are
Thank
both
goodness someone else agreed with that because
both
I cannot
consumer.
find my notes on it.
and
So
just to be
no,
pedantic, there can be multiple IO rings per VM. It's
only
not just
the
one
guest
per VM.
is writing, is updating.
Is it for like different devices?
Yeah, I think so,
Okay.
or however they want to
Let's
organize
say
it.
that.
I don't
All right, that
remember.
makes sense. These are both single producer, single consumer. So no mutex is needed. Only the guest is updating request producer at any given time.
That is my
So these are
understanding.
Yeah.
that is so much simpler than like going through the freaking whatever we were thinking about the proportions and all that. All right, that makes sense. That makes sense. That's a good 2 point answer. They're both single producer, single consumer. So all right. Yeah, because then these private ones are the ones that are wait. Because the only thing that Zen is doing with the request producer pointer is to know when to stop reading, right? And the only thing that the response producer is being done with the guess is knowing how much longer is left in the queue. Like they're not updating that or changing that point. And then it's a little, I guess it's okay since it's atomically incrementing. It's okay if it's lagged a bit. Um, yeah, I don't want to think about a 2 point question too much. That makes sense. All right. Full virtualization, 6 points. Uh, the root privilege is not. It will do a trap and detect. Yeah, no access to machine page numbers, so it can't. There's no authorized access to the machine page of another VM. Does that make sense? Like the because there is a PMAP process to map to a machine page number, the physical page number is not the same between VMs. They represent different machine pages, which protects against unauthorized access to a separate VM, since there's no view of a machine page to the VM itself.
Yep.
Yeah, all their memory is isolated.
In separate VMs mapped to different machine pages, and VMs have direct access. The machine page number self. Or that makes sense. That's a good 2 point answer. I guess that hits on everything. Part B is a specialized application that uses modern CPUs. This was like a Geos thing. We spent some time in Geos where they discussed part of the x86 ISA failed silently. So for those, they did binary insertion and then um, replaced them with a trap and emulate.
So this one I did sort of have is this a trick question one? Because from the paper and from the Hangouts, I remember that it was old versions of x86 that had the failure to trap unprivileged instructions when run in user mode. But this question specifies modern CPU instructions. So do we go with the, pretty much what was spoon-fed to us that s- we have to do the binary rewriting because they're old instructions, or is there a trick here?
Um, this it's just like this could also be like a protection ring thing. So like they could be executing at a lower or protection ring than what they expect. Um, But that's also the factor for the other one, which was the trap and emulate. If I go to where is full virtualization? Let me see if it was asked before. Guess OSs don't execute in privileged mode. Addressed using trap and emulate. Hypervisor traps a fail instruction and emulates. I feel like this is a privileged instruction question, maybe. Um, like it could be like you have more privilege on a bare metal, but you're running at a higher protection ring on a VM,
Or,
and that will
or
cause
it's
some things
as
to fail.
or it's as basic as the the virtualized VM in the cloud is not running on those modern CPUs, which I think was one of the first. Doesn't make any guarantees about supporting chip-specific instructions outside the.
Yeah.
I think that's a fair answer given the scenario that we've been given.
Basically, the hypervisor doesn't trap on the modern instructions
Yeah,
because
it's
it's
the
not aware.
older, yes, older instructions have a quirk where certain privilege instruction. Um,
Yeah, it's like the reverse of that one, right?
it
It's
reverse trap
somebody,
and emulate.
it's like somebody trying to call a new function that's not available on the underlying architecture of the cloud VM. It did not say that the bare metal was the same physical infrastructure. Is that a fair assertion from the question? Would we have to state that?
Functions, higher privilege, need the VM to explicitly know to trap and emulate the functions. If the functions do not exist or the functions do not exist on the host machine. I have the VMs they don't emulate, right? Emulation is different from virtualization of architecture. Machine or logic is not implemented to trap and emulate modern instructions. Trends fail silently. I'm just gonna use the logic is not implemented to trap and emulate the modern instructions. Yeah, I feel like it's partially privilege level, maybe partially trap and emulate. Uh, Binary rewriting.
The emulate part's only the hypervisor, right? I think ultimately it's just the VM needs to, or like these instructions need to trap to uh the hypervisor and not fail silently.
Right. Which is what's done is done on bare metal. Need to trap to the hypervisor. If the logic is not implemented at the hypervisor, then they will fail. It's probably sufficient for 2 points. They need to trap the hypervisor instead of CPU directly. Directly. Uh, done. If logic is not implemented, the hypervisor trap emulate the modern instructions, and they will fail. So the hypervisor needs to know that these instructions exist in the instruction set, and then emulate them. Yeah, hypervisor doesn't know how to trap and emulate a specific modern CPU instruction. Memory protection is less strict. No VMs. A higher protection ring. I feel like that's sufficient. Like the what is not known yet to trap and emulate by the hypervisor. That's not implemented, so it'll fail. No saying that's identical, yeah.
Wait, do VMs execute at a higher protection ring or the hypervisor? Because I thought the VM was like kind of like just like a regular process, but the hypervisor has uh is on a higher privilege.
Maybe VM has no access to lower protection rings like it would in bare metal or something like that. Because I know like domain zero or whatever it was called, like is the one with the lowest ring. Oh, they actually like ring one or something, right? Instead of like ring three and zero or something. Uh, I probably wouldn't mention protection ring if you can't memorize it for the test. Just say they need to trap to the hypervisor instead of the process directly. And then if it's not implemented to trap, then the hypervisor doesn't know that to do rewriting and it'll fail. I think that's probably sufficient enough. Um, I'll thumbs that up as well. How do you thumbs up? All right. Are we good with this answer? Like this one is just the I see a variation of this in every test is like the machine page and physical page is different. This one is like the trap and lo emulate logic is not implemented yet. Um, on that. And then part two is wait, what is part two? Oh,
It's a true or false. Yeah.
yeah. So it's PMAP is doing PPN to NPM. Shadow page table is a shadow VPN to
MPN.
NPN, yeah. And that's to I remember PMAP being mentioned on the VM. Or was it? Was it? All right. That makes sense. Memory management. Two VMs running the same host using content-based page sharing. This were my reasons. One is hypervisor has a better view, whereas if you had to do it explicitly, the VMs don't know each other's memory, so it would require message passing to identify the correct one. Um, wait, PPN to NPN? Shadow page table.
Sorry, I pasted that in there like 2 minutes ago. There's a delay.
Right, PPN
Uh,
NPN mapping is in the PMAP or is that in the so would that be true then? If it's going by this image?
No,
that's
we're
just
talking
from the
about the shadow
lectures.
page table, not the PMAP. The shadow page table
Maps the guest physical to
Is
the host machine.
PPN to NPN. That's why I was putting that in there. I just wanted to verify what the hypervisor SPT actually tracks.
that tracks
Hyper
the virtual page to the machine page so that
that would
it's
be a
efficient.
TLB like thing, right? Not the um let me pull it up actually. Where is ESX? It was so PMAP is so ESX server maintains a PMAP data structure for each VM to translate physical page numbers to machine page numbers and PNs. VM instructions that manipulate guest OS page tables or TLB contents are intercepted. Separate shadow page tables are VPN. Wait, right. Separate shadow page tables, which contain virtual to machine page mappings, are maintained for use by the processor. Oh, so the PPN on the guest OS is considered a virtual page number by the hypervisor process.
No, no, it's like there's two level of translations. First,
Mhm.
a VPN goes to PPN in the guest operating
Hmm.
system, but the PPN is not the actual machine page number because the hypervisor is emulating it. So the hypervisor maintains the PMAP, which converts the PPN of the guest to the actual machine page.
Um,
But the shadow page table, what it does is once it knows what the VPN corresponding to a MPN is, it just saves that. So we don't have to do two translations for each memory access. That's what it says. The shadow
yeah,
page table
separate shadow
contains.
page table contain virtual to machine page mappings
Yeah.
maintained by the processor. Okay. Let me just copy this indirectly so we know which quote this is.
Thanks. I was about to put that image in there.
Okay, so this image is a little misleading, it
Yeah,
seems.
it is.
We can take it out then. Um,
All right.
Yeah, I would just trust the paper since it specifically says VMware's virtualization approach.
We have page 3. Um, so PMAP is maintained for each VM to translate physical to machine page. VM instructions that manipulate guess OS page tables or TOB are intercepted, turning update to actual MMU. I'm gonna bold this. This is the most direct way to answer it. It's just that they literally said that in the paper. PMAP is used, and the shadow page table is separate for virtual to machine page by the processor. Memory management. This one, yeah, hypervisor has a better view. So because VMs don't know the memory of each other unless they share a bunch of messages. So because there's a higher view, it's a better candidate. And then also it's done transparently when there's less load on the whole system. VMs themselves don't know when there's a light load on the system as a whole. They only see themselves. So those are my two reasons. Like both CPU load hypervisor has a better view, and then total memory usage hypervisor has a better view. Whereas each VM has isolated to themselves. They don't know their neighbors and what they're doing.
Also, we don't need to modify the guest OS. That could
Yeah.
also be like a small point three that the guest OS, like it works both for full and para.
Yes. OS. If it is done. Right. I feel like any of these could be valid because they just said specific reasons. This is, I guess, OS will not have the ability to, without modification to guess OS, to mark pages as shareable. I think, yeah, okay. I think these all have like logic behind them, so it makes sense to keep that.
Yeah, someone also mentioned the paper. That
Yeah.
also says the same thing.
The transparent one explicitly is mentioned in the paper. The other two, I think, are more just conjecture. But
No,
they do.
like in the
Okay.
red text in the next
Yeah.
page, it is like the exact answer we
Yeah.
have.
That was the first one, right? It has to eliminate the hook to understand guess code.
Yeah, more opportunities.
And then the transparent one is also a direct quote from the paper,
Okay.
I believe. Let me do a. Yeah, serving a remap that's completely transparent to the VM. Or maybe that was from the lecture. It was done as a background task.
Hmm.
Right. I think that's good enough. Parallel system. Where is it? Yeah, 1-4. So these are kind of like the invariants for this. So if there's anyone that breaks one of these rules, then it will be called out. So A is 1, B is also 1. So then this A is 1 and B is 1. Um, C cannot be C cannot be 1. It has to be 2. Or it could be it could be in between A being set and B not being set. So C can be either no, C could be all of these, right? 0, 1, or 2. So if it's done after these are set, then it's 2. If it's A is set but B is not set, then it is 1. And if this is the first one run, then it's 0. D can be either, so when D is 0, C must be 0. That makes sense. Um, C could be updated before D, but D could not be updated before C. So that makes sense for 4 because C is 1 and D is 2. So D probably caught the next one when, oh, what the heck? Uh, so 4 doesn't make sense because D is 2, which means C would have had to have been 2, but C was already incremented to 1. So 4 doesn't make sense. Uh, so 4 doesn't
One
make
doesn't
sense.
make sense because E is 0 and C is 2.
Yeah, that which means A and B would have both been set by the time C was
Yeah.
set, and then C needed to be set for D to be set, and then E runs after D because of the process order, program order. So it
Yeah.
doesn't make sense. 2 makes sense. E is 0, D is 0, C is also 0. That means these were run before thread 1. 3, D and E are both 0, so that means third T3 could have been run before T2. T2 runs between I1 and I2. So 3 makes sense. 4 was the number that broke. Uh, 5 was A1, B1, C1. So C1 runs in between I1 and I2. D1, D runs after C, and then E runs after. Okay, that makes sense. Um, then 6 A's, 1 B's, 1 C's, 2. T3 was run at the very beginning, that means. So I think these are all good.
How is 4 wrong?
4 is so C is 1, D is 2. Yeah, D is 2, but C is 1. Once C has been set, it's not changing again, right? For D to be 2. So C is 1, D is 2. D is equal to C.
No, can it not be like the A is set to 1, then the thread 2 runs, so C is set to 1,
Hmm.
then B runs, no, the thread A again runs, B is set to 1, then,
D is equal to C is
oh
what
yeah, then D, okay,
yeah.
yeah, I see.
Okay. Um, is that the only question on this section?
Yes.
Parallel systems, 4 points. Wait. Uh, ooh. Mutual exclusion locks. I think we had some arguments on how many threads per core. Someone's thinking 32 threads, 32 cores, 1,000 something threads. But yeah, each one sends 100 bus access each to do the test and set after the invalidation. Um,
Here's one where I had a question or a disagreement with what was on the paper with A. Um, so I agree that 31 threads each do 100 accesses. I'm leaning towards that we should also count the bus access for the one thread that is successful in acquiring the lock, right? Like, so
they all run
that,
the same operation. It's just that one proceeds afterwards.
right,
To
yeah.
acquire
So
the
31 of them are getting 100 accesses. One of them is getting one access. So then in my calculus, that adds up to 3101 instead of 3100.
It should be 30. It should just be 100, right? Each lock position results in 100 iterations of the spin loop. It's not like they do another thing after they do the test and set.
Right, right, yeah, that's exactly what I'm thinking. But the one thread that is successful in getting the lock has performed a test and set.
They all do a test and set to 1, right? But it's just if it's still equal to 1 on the previous value, then they keep looping.
Right, yeah, yeah.
Um,
31 of them are doing that 100 times. One of them hits, the one of them that is successful in getting the lock hits the test and set once, which incurs a bus access.
uh,
So I think it's one more than,
while test and set equals. There's no second thing. It's just that part of the
no, no,
lock.
no, yeah, exactly. That's not what I'm saying.
Mm,
The 31 of the threads fail to get the lock, so they spin 100 times. They hit this test and set 100 times, right? That's
mm.
that's in the problem statement. one of the threads, the 32nd thread, succeeds in acquiring the lock and hits this test and set once.
So you're assuming initially no thread has a lock. The thread that acquires a lock only runs one test and set, and the remaining 31 red like run 100 times. So that's like 1 plus 3100.
Exactly. And yeah, I'm looking at now the specific wording of the question. How many bus accesses are incurred per lock acquisition?
I think it's just 32 because they all get the new value once it's been invalidated. Or 31 because they all get the new value once it's been invalidated, right? So 31 new fetches, and once it's been fetched, they don't get updated again. That test was still gonna fail. I think 31 bus X's. What the heck? 31 bus X's is. But then they spin on the cache copy once they retrieve the new value.
No, on test and set, I think they don't spin on the cache.
Right, yeah.
Yeah.
Test and set these
It's
atomic
test on
operations.
like spin on read is the cache one. Test and set is go to memory every time.
So bypass cache, yeah. So upon unlock the first thread will succeed on the first iteration equals to 1 bus access for test and set. 30 other threads will attempt to run test and set after the first success. Full acquire equal to 100 bus.
31.
There's 32 cores. One just released it. There's 31 up for grabs.
I
Right.
think the initial state is not agreed upon. You are thinking one thread already has a lock, and others are thinking no thread has a lock right now.
Hmm.
So that assumption needs to be stated.
So
So it
it's either
says
the
all
program
threads
just
are
started.
contending. The second last point says all threads are contending for the same lock, which means initially no thread has a lock.
Okay, so this is assuming initially no thread has a lock.
Yeah, then it would be
No
1
thread
and 3100.
lock. One bus for test and set. 100 iterations. Iterations with atomic test set is equal to 100 bus accesses. So that's 31 times 100. So that's one successful test and set plus 3100 was access. So is it each test and set incurs a bus access to go directly to main memory? Upon unlock, the first thread will succeed on the first iteration. That's one test and set, one bus access, plus 3100 iterations to spin.
Is this only asking about the first round? Because isn't I guess like once a thread acquires the lock, isn't each subsequent round going to have like 100 less bus accesses?
Yeah, they don't sleep, right? I was like thinking it would sleep after 100 or something, but uh but I'm just going by the parameters they gave us. Each lock position results in 100 iterations of the spin loop for each thread. Um that is some unclear wording. I was presuming like if it was unsuccessful, it would get 100. It spins until it tries again. So that's like a guaranteed minimum or something. So yeah, test one is an SSL update. The rest is a test and set fail.
I
Uh,
think it's just like simple that we do not overthink that once a lock is acquired, how many times the other threads are going to run. Ideally, it's unbounded, right? Because
yes.
I don't know when we're going to release the lock. So they said that assume every thread will run 100 times. That's it.
Yeah. So one successful test and set bus access to acquire lock plus 3100 to spin for unsuccessful 3101. That makes sense. Then this one, I think I just gonna comment it was not counting the successful lock. Uh, okay, and then the spin on read is the one where it's just the invalidation part. So this is yeah, this was incorrect from the lecture. This was notifications, not bus accesses, right? Because everyone will create their own notification when they try to attempt it. Um,
No, I think this was n minus 1, not n square minus 1.
yeah, n squares are cache notifications. That's what I noted. So,
Yeah, yeah.
um, every waiting thread submits one test and set operation.
Yeah, equal
Yeah,
to 131, right?
32 then, right? Because it's the 32 contended threads.
No, here it says that one thread is already in the section.
Okay. Oh, so for the previous one, we were assuming this, which is why it was
Yeah.
31.
Here they say that one is already in the section and this one release the lock.
Upon, I was gonna like describe the process. So upon release, all cache copies are invalidated, triggering all threads to attempt all remaining threads. And test and set 31 test and set operations. The unsuccessful full 30 will have a cached copy to spin on. So there will be no further TNS until the next one. So I'm gonna say 31 test and set. If you look at the structure of the caching spin lock, it was so everyone attempts this once they detect it was not locked. So that's just 31 of those, or 31 of those. One is successful, it will proceed. The remaining 30 would hit the go back. It's 31 test and set. No credit. So I think this is a justification in case you have to describe it. So now read. Gonna like control X this. Here's a ticket lock algorithm. So the ticket lock, everyone was looking at the now serving, right? Otherwise they would sleep on the difference between the current one and now serving. Um, ticket lock was yeah, they will pause and then if now serving equals my ticket, then return otherwise loop.
Yeah, I think this looks good.
Yeah,
31.
31 threads, now serving is updated when unlocked, which causes a reload on all waiting threads. That
Yeah.
works. It's turned as MCS lock. I still don't know why they named it MCS lock. I think someone said those are the names of the people.
Yeah, it's the name. Meller, Crummy, and Scott. That's the
Uh,
surname.
this is
That's
the
the
same
paper name.
same with the freaking Anderson's lock people. They named it after themselves instead of just calling it the freaking array base lock.
Yeah. Everyone
But
puts their name, Lamport sequential consistency, and we'll get Lamport clocks later on.
oh my God. All right, this is the MCS lock algorithm. So this is the linked list one, right? They had to update the root pointer and then also set the next to nil or something. But then
Yes.
in between the two, you had to spin on the test and set if the root was not equal to your current pointer when you're updating it or something.
Yeah.
Yeah. 301 thread At lock release, then the next pointer is nil. It is safe to lock the algorithm and assume there's no thread. Not safe. At lock release. I'm gonna just like write out the justification. Operations happen. The current unlocking pointer sets the root to the next and sets the next pointer. Wait, it
That's the
does
root to nil.
sets the root to
I think nil, right?
nil if it is at the it is if next is nil. Wait,
No, if the root is current, then it sets the next to nil. But if the root does
root
not point to the current thread,
is
that means there's a new processor that has not completely updated it.
root set it's the it's just the root pointer to nil if root is pointing to the current. Say is not safe to operations happen at lock release, updating the root to the next, and then headed somewhere. It was synchronization algorithms. Link-based queuing lock, native spin lock, array-based queuing lock. It was set running to updating the running, and then it's more the acquisition point, right? When a new thread wants to register. So it sets the last requester pointer at the root to requester pointer to itself and then updates the running pointer to point to it. If the running pointer is unlocked, it could be running the unlock operation between the two, between the setting of the last requester pointer and the updating of the next pointer. The next pointer by the registering thread. Depending a false. When you throw once register itself, it sets the last requester pointer at the root to itself, then updates the running pointer to point to it. The running pointer's next pointer. If the running pointer is unlocked, that unlock operation, the running pointer could be the running pointer could be running the unlock operation between the setting of the last requester pointer and the updating of the next pointer by registering the thread. If the last requester pointer is different from the next pointer, then the view of the next pointer is in an inconsistent state and cannot be relied upon. That seems about right.
Yeah.
For justification. You can review lecture link-based queuing lock. Review link-based queuing lock lecture for justification. Justification. All right, then number two is you have a bus-based custom non-cache coherent shared memory DSP digital signal processor. That's a very long modifier for DSP. Um, each CPU and DSP has private cache. So this is like if you don't have cache coherence, how would you simulate it with the locking code? Um, and then I think so, there's some logic that got deleted, so you would need a fetch and then check. Need a fetch before a check. Fetch to get consistent state before the check. Yeah, there's some stuff here earlier. I don't remember where it went. It was I think I'm running out of memory on my computer. Uh yeah, fetch, atomic increment, and then a flush. Um need to get latest state before check. You need a flush on this one. I think this got unsuggested. So update, hold, flush, unhold. And then this one looked okay. This one we were confused on last night about the structure of each local CCSMP. We know that we should structure the children and the parent to be on a local CCSMP to minimize the amount of sharing at the next level. Um, is the local parent-child relationship so that the spinning arrays are shared locally and updated for array. Um, 1 out of 4 nodes on each CCSMP is designated as a parent. One of these is designated as P0 to a shared HN and I forgot the name of the next array. CR. Child ready and then to a cache coherent on P0 to spin on. I think this one's more detailed. Children data should be local memory. Update for each child ready. No cross machine cache coherence. Cross machine cache coherence is needed for the local group. Um,
I'm not sure if we need cache coherence because I think MCS runs in NCC also.
yeah, this is an NCC NUMA machine.
Yeah, so like there's no need for cache coherence in the MCS one. So that's what confusing to me. Even if we have nodes across the interconnection network, they only need to send one message request that they are done.
Oh, that makes sense for the P0 too. So P0 is the one that would notify everyone. It doesn't have, it maintains a local state so P0 would maintain a local state,
Mm-hmm.
would maintain a local state, and the other parent threads will send an update message to P0 cross machine.
Yeah, and P0
Cross
would
node.
be
Yeah.
like looping on its own local
P0 will
cache.
loop upon its own local cache for the other nodes to complete and will update its local cache when it receives messages from the remote nodes. Then when P0 P0's local array indicates that all nodes are complete. It will trigger wake up calls to both the local nodes and cross node local processors, uh, a local and send cross node messages to the parents on the other nodes to run wake up.
I added a link to the Hangout where we discussed this. It's a video, so
Yeah, it's I think a lecture as well, which made sense at the time. Virtualization lecture, scheduling, shared. Yeah, I think this is probably sufficient enough. So I think they want to see the local parent-child relationship to spin on. They want to see the cross-node messaging to the root without updating state. Zero loop on its own local cache, root cache, node cache for other nodes complete, and will update its local cache when it receives. So when P0 itself sees locally that it's received like three other node complete messages, then it would send out wake up calls cross node without having to update state cross node. That'll be done by the parent on that node. That makes sense. It's straight from the textbook. I don't think we have to describe too much in our own words. If we can just look at the lecture. Someone had a nice image here. Copy of the child ready. Okay. LRPC and scheduling. Yeah, this was like two options. Like when you create it, you have a binding object to authenticate that you're able to use the shared memory. And then kernel has this whole E-stack threat doctoring thing, which when you look it up, there's no documentation of what threat doctoring is and how it's different from like the context switching. So since it's only 2 points, I think that's why all you have to do validation and then kernel will schedule the not kernel server process. That's probably all you need. Validation, binding object to authenticate that it is able to make the call. And then E-stack. But then the kernel's not involved. Is not involved in
I also
message.
remember there was like a return trap as well from the server.
Execute. Yeah, I remember there's like a handling return
Yeah,
trap direction or something to the bind object. Uh,
just like one trap from the client and then one trap from the server. There were two traps.
making RPCs cheap binding validation. So procedure
Were
descriptor.
these the ones called marshalling and unmarshalling? Did I get that right?
That was without the lightweight RPC, right? You're doing the basically serialization, deserialization, or is that something
Yeah.
else?
Yeah. It was before the optimization that we do of making a shared memory. Yeah, this is before the optimization.
This is yeah, each client server interaction required two copy, marshal to copy, unmarshal to deserialize in kernel. But then wait, no, there's still marshaling and unmarshaling, right? A stack into E stack. But it's 2 points. I don't think they need too much detail. I hope at least.
yeah, the next two sub questions get into marshaling and unmarshaling.
RPC
Gotcha.
and SM. Yeah. All right, client stub. And then yeah, those return stack handling as well. So binding, kernel mediation, join a core server, making calls.
I don't know if we should mention return trap because it's I think the question was talking about like invoking the server procedure.
Yeah. If you're not confident, don't mention it. Just mention the minimum required, or else they're gonna. Actually, no. You can overload it, but I guess if you overload it incorrectly, they'll not check you on that. So validate, expecting a return trap to happen. No, kernel just expects a turn trap to happen, right? It doesn't like wait for it to. I'll keep return trap there actually. To the calling. So kernel allocates an each stack for server process to execute by doctoring and handles the return trap to the calling process. All right, I think that's all you have to say, just these two. And give any two valid reasons. Validation for binding object, kernel for allocating server, running server, and then handling return trap process. Um, Server expects a pointer to a linked list as a formal parameter. Why does not work? Yeah, pointer is still in local memory address space. Is a pass by value. How can you fix it? Pass by value deep copy. And then someone said serialized marshalling. I don't know, marshalling. Yeah, pass by value deep copy into the message. Um Server on marshalling has to that would
Does
present
marshalling only mean that we serialize it? That's it?
marshalling is on the client process,
Yeah,
right?
like so it just means that we serialize it. That's it, right? Or is it
Yeah,
something else? I guess that's what it is. Like they marshal the
into the stack, the
into
shared
the
stack.
A stack and then unmarshal. So like serialize and deserialize.
During marshalling,
Yeah.
marshalling, you will pass by value deep copy the message into the A stack. The server will demarshal or unmarshal show the copied link list and recognize it on the E stack. Recognizes references to it. This is to it on the E stack. Okay. Marshalling, traversing this. I don't think that just like if you're like trying to save space and you just say deep copy, I think that coalesces it. Um, Server stub needs to read it, create node. Yeah. All right. I think that's probably good enough for a 2 point question. Um, then tornado. Uh, so tornado was it would amortize the cost of binding or something to repeated access or something. Uh, yeah, replicating process object. That was a lecture in tornado. So process object is like access repeatedly or something, and more often than deletion. So you optimize for the common case. I say so optimize
Yeah, this is
the
also
common
mentioned in the paper where this graph is.
process objects. It was Process objects are frequently to handle local page faults while region deletion happens less frequent. By replicating the process object, you optimize for frequent accesses. Given this figure, the page fault handling, uh, everyone's on the same thread, just optimize for the common case here, and then explain synchronization of deletion across all shares. That was replicate region object.
I think you could just like basically copy the in like section 3.2 application of clustered objects for the tornado paper. It basically just answers
Yeah.
these two questions, I think.
Okay. Synchronization. What was it? Synchronization in parallel. Optimization of
It's the maximizing something
section
3.2.
3.2 allocation of clustered objects.
Yeah, that last paragraph.
By replicating become more expensive because of the need to keep process object consistent. Page fault is much more. That's like a direct quote. Uh, Generally worthy for the process object. Would appear similar. Delete, yeah. By replicating process after other operations such as deletion become more expensive. Let me just say optimize for the common case. That's like the thing for all these. Okay, I think we reached the end again. I feel like we have much better answers than we did last night for the second pass, and we really spent a lot of time on the lecture two questions and nailed them down as well as kind of the trick ones. So, I don't know if anyone else has any like other things you want to bring up, but I feel like
Oh,
we're in a good spot.
I had a quick thing for the hidden questions. Uh, so I'm thinking that they may be putting things on there that like weren't covered by the release questions. And as
Yeah.
far as like what I can think of that would be in that category, I'm thinking of like Corey and Cellular Disco. Uh, does anyone have any other things that they think might be good, like easy candidates that they might put in that category?
Was there anything on array-based queuing? Array-based queuing lock or CPU scheduler with the queue?
Oh yeah, that's a good one. The cache affinity and cache pollution.
Um, yeah, so that was near the end of, I believe, what parallel systems they're thinking about that. Like going through these exokernel, I think we covered the section two pretty deeply in the shared ones. Probably three and four are even more heavily weighted than the previous exams. Um, Running different virtual memory spaces.
I think there wasn't anything on like dissemination or tournament barriers either, so that might show up in there.
The gossip area.
Yeah.
Yeah,
Tournament.
dissemination tournament. Was it Ray in here and I just fell asleep during it?
There was
Anderson's.
Anderson
No.
was the array base, right?
Yeah.
Locking. I mean, it's relatively simple compared to the MCS. I feel like we might not see it because we already saw the linkless approach and they're pretty much the same. Uh, each page fault, assist call, interrupt. Let me just go to the lecture list and see what we have. Lecture one, we didn't see anything. I don't think we ever see lecture one in the test because it's just a review. Nothing on DOS. I don't think we've ever seen anything on DOS kernel, but we could still put it down. Maybe DOS on structure pros and cons. Microkernel, spin approach. Coursers and spin, we did have a question on that. That was because of the hardware interaction. Push the extensibility, logical protection domains, where crossings. Isokernel approach, code use of isokernel. L3 microkernel approach.
Sense reversing barrier. I don't know.
Oh yeah, sensor reversing barrier.
Yeah.
That should be
Yeah, I feel
relatively.
like a lot of the stuff I studied wasn't in here. I just got to say.
Yeah, but the ones that were in lecture two were really deep. I'm glad that we're getting them out of the way, shared.
Yeah.
Because
Yeah, for
those are
sure.
really hard to memorize. The microkernel virtualization. We did plenty of memory virtualization, right? The shadow page tables, the hypercalls, IO rings. We've done something on. Uh, ballooning. We've not done this. Definitely gonna be ballooning on here. I feel.
Yeah.
I
Did
think
he say that he might have questions based on the project that we completed?
what would there be on the project that we could be tested on?
I assume CPU scheduling and memory ballooning, but
So yeah, this one's didn't show up at all. Memory ballooning, memory pressure, take 25%. Oh, the memory taxing.
taxing, good one.
Uh, VM time sharing, the timeshares. So you'll do like the pre-provision, the virtualization, VM hard protection.
And was there a lot on the shared memory cow stuff in this? Is that what you're kind of getting
Yeah,
in that
it's
VM space?
so there was CPU virtualization. Yeah, there's one about like billing, right? If you either pay upfront and have priority time, or we like maximize time for like a running process. Uh, yeah, least state sharing, PPN, MPN mapping, memory subsystem. Do you think there'll be more in the TLB? Because I think there's some questions on the TLB, the tag TLB, in the written, but there might be some more. Yeah, measuring time, sending guess, control and data transfer. Uh, shared memory machines, synchronization. We did plenty on the spin lock, array-based queuing lock. Link, array-based not too much. Link algorithm grading. Uh, yeah, maybe grading across algorithms. I remember there was a table on like the light, medium, heavy usage of memory and a few others. Uh, this one looks with delay. Yeah, there was like a light, medium, heavy table somewhere in memory usage. Lightweight RPC we covered. Um, scheduling. Yeah, cache affinity scheduling is there. Cache aware scheduling. Yeah, cache affinity and then was it cache aware scheduling?
Yeah, the scheduling stuff, dealing with processor or process focus was definitely something I felt was missing. That algorithm grading is a great table. I don't
Yeah,
know if
yeah.
we really got hit with that so much as just a very specific question on spin on an architecture with algorithms.
It's probably algorithm grading, yeah, across schedulers and synchronization. Both schedule. Right, balloon memory, sensor versing barrier. I can't think of much else than um, modern OS. Processor related OS abstractions. Uh, if I go through where are the other notes? So structure, demand paging. So is there like something on page out, page in, and how that affects cache warmth? No, there was on the microkernel or exokernel. Uh, Kernel DOS-like structure, microkernel base, what we want, extensibility. Um, I think that covers the few that we did not look at um, on the written ones. Core services, default core services and spin we covered, exokernel extensibility, secure bindings. Let's look through the previous two tests. I think I'm kind of spinning on the exams. Uh, Exokernel, spin, border crossing protection, domain crossing, L3. Virtually index physically tag processor cache. So we did the physical tag processor cache. The VIPT was done.
Did a very similar question to that one, I think.
Yeah. We had virtualized environment of two objectives. Page call, syscall exception, external interrupt. Are the events given on a fully virtualized setting, packaged and delivered by hypervisor, array management? There was the so VM ability feature we had a question on. I think there was one on was it like the right flag? If you write, then you had to do a copy on write overhead.
Yeah, this is the thing with the cow I was saying. I didn't know that we got one like
Yeah,
that.
copy and write overhead. Sharing. Memory management. I think we should be fine, or it's already down. Memory taxing. Idle adjusted shares, shared memory. Or we already had the sequential consistency, so I guess we're good there. Uh, Oh, write invalidate, or is it the other policy for cache coherence
Oh,
versus read
copy
cop
or yeah.
write update.
Write update. Yeah, there you go.
Yeah, we haven't seen one of those yet. We just saw write invalidate as a definition, but differences. So that was one we haven't seen yet on section 4. So write invalidate versus write update. And that's shared memory multiprocessor. Each one has private caches. Anything on L1, L2, L3? The differences between L1 and L2. So like local to CPU, local to core, and then spin lock. We had plenty of time on spin lock. I don't think they're gonna keep going on this besides the cache coherence part. Um, oh, this one was the gossip one. Sharing about the processor with the barrier synchronization. Uh, yeah, at the end of the round, P6 is right. Yeah. Lightweight RPC and scheduling. Uh, so yeah, scheduling. We have on the list Tornado. Um, Anything on reference counting, or is that just like a niche of some of these? No, I'll go put that reference count as well. And Tornado. So the reference counting was versus locking, right? On the process object. Um, sudden spike, hidden potpourri. Uh, oh. So this one they didn't test IO ring in the written one, so they came back to it in the potpourri. Um, Hypervisor running out of slots, guest running out of slots. Um, and then fall 2025, what do we have? Spin performant microkernel. Two advantage of microkernel over monolith. Uh, Memory isolation from other apps in the same VM. IO rings. Full virtualization. Uh, yeah, requests. Visors, no. Balloon driver stuff is already on there. Parallel systems. Lock barriers. Then we have barriers on there. Dissemination barrier. Anderson's. Queuing. LRPC, we had a pretty detailed one. Right, one NUMA piece of memory, cluster DRAM object, region object, shown a figure. Operate. Okay, full virtualization. Oh, someone came up with the same MCS barrier thing. I think that's all the potentials we could have. If you have any you feel like it wasn't listed, please add them. But as for the rest of the questions, I feel like we're in a pretty good state. If we want to end it, I know we went hour and a half over, but I hope this was a useful session. Hopefully, anyone joining in from last night is able to kind of refine the answers that we had. Yeah, thank you, everyone.
Yeah, thanks for leading.
Yeah, no worries. Everyone's more intelligent than me, so I was happy to hear you from you guys. All right.
See you around.
All right, see y'all.